Welcome to this course module. In the last course module about routing, we had first contact with observables. Now, I want to dive deeper into observables in this section. Now, you could create a whole course about observables, so we're not going to dive that deeply into them, but I want you to understand what observables actually are and what you could use them for and why Angular uses them. So what is an observable? An observable basically can be thought of as a data source. Now in our Angular project, an observable basically just is an object we import from a third-party package, RxJS. The observable here is implemented in a way that it follows the observable pattern. So we have an observable and we have an observer. In between, we have a stream, a timeline. And on this timeline, we can have multiple events emitted by the observable, or data packages, you could say, emitted by that observable, depending on the data source of that observable, of course. So the observable could emit data because you trigger it to do so. You can do that programmatically. It could be connected to a button, and therefore whenever the button is clicked, an event in a data package is emitted automatically. Or as the Angular HTTP service does it, it's connected to a HTTP request. So when the response returns, the response is emitted as a data package. And there are dozens of other data sources too. We will have a look on where to find more soon. So as I said, the other part is the observer. This actually is your code, you could say. It's this subscribe function you saw earlier, or at least it has something to do with that. There, you have three ways of handling data packages. You can handle the normal data, you can handle errors, or you can handle the completion of the observable, because these are the three types of data packages you can receive. And in these hooks, in these boxes, you could say, your code gets executed. So you can determine what should happen if I receive a new data package, what should happen if I receive an error, what should happen when the observable eventually completes. Side note, an observable doesn't have to complete. There are observables, for example, hooked up to a normal button, which never complete, because how would you know when it completes? A user could click the button how often the user wants, right? Other observables, like the HTTP request on the other hand, will have a clear end and will complete eventually, because once the response is there, what else should happen? It's done. So this is how the observable pattern generally works. And of course you use it to handle asynchronous tasks. Because all these data sources here, user events triggered in your code or a HTTP request, are asynchronous tasks. You don't know when they will happen and you don't know how long they will take. So if you execute your normal application code, you don't want to wait for these events, or you don't want to wait for the completion of such a HTTP request, because that would block your program, would block your logic. Therefore, we need methods of handling such asynchronous tasks, and historically you might have used callbacks or promises, and it's not necessarily bad to use them. Observables is just a different approach of handling that, a different alternative, and Angular embraces observables, which is why, well, I chose to explain these, because Angular uses them a lot. And actually, observables have one major advantage: they're operators, which I will show later in this section too. Back to this slide. So we got our observable and we got our observer with the three buckets, you could say, or with the three hooks where different code is executed depending on the type of package we receive. And then exactly this happens. The observable might emit a couple of normal data packages, it might emit an error, or eventually it might get completed and the respective code is then executed. So that's the theory. Let's now take a closer look in our actual project. Attached, you find the very simple Angular project, where I essentially only have three links that take me to different pages for two different user IDs here and to the home page. Now, of course, there is one thing we already learned about in the routing section, and that can be found in the user component, which you find here in the user folder in that attached project. In the user component TypeScript file, of course, I have already set up a subscription to listen to changing route params, so that if I am on the user page, as I'm here, because user 1 and user 2 share the same component, if I'm here and I have the user ID 1 loaded and I click on user 2, this updates here in the DOM, even though it technically is the same component, and that is something you'll learn about in the routing section. Now, this is using an observable. Params here is an observable to which we subscribe. And that's just one thing you can already keep in memory. Observables are constructs to which you subscribe to be informed about changes in data. Because remember, observables are that stream of data, and whenever a new data piece is emitted, our subscription will know about it. So in this case here, params is the observable. It's a stream of route parameters, and that stream gives us a new route parameter whenever we go to a new page, whenever that parameter in the URL changes. And then here in this function we pass to subscribe, we get the new params, and we can extract our relevant param, in this case the ID param, from that. So that's how this built-in observable works and how you can think about it. Params is the observable, it's that stream of data that gives us new values. Now that's all nice, and Angular will heavily use such observables, and there you will never need to create them yourselves. You only subscribe to them, you don't need to create them, but to understand them, it certainly doesn't hurt to also create them. So let's do that as a next step. Let's build our own observable from the ground up and understand its internals. To build our own observable, I'll go into that home component, and there in ng-on-init, I want to build a new observable. Now, observables are a feature that's not baked into JavaScript or TypeScript. Instead, they're added by a package named RxJS. And that's why in Angular projects, if you have a look at package.json, which lists all your dependencies, you find RxJS here. Now, in the home component, I want to build my own observable here in ng-on-init, and for that we can import something from that RxJS package. So let's import from RxJS, and we don't need to do that when using observables, because thanks to TypeScript, it understands that params is an observable, and therefore it knows we can subscribe there, and we never need to explicitly inform it about the type. But if we want to create a new observable, we need certain features from that RxJS package. To be precise, that RxJS package gives us different ways of creating a new observable. And one of the easiest ways is the interval method, the interval function. You can just import interval like this, and then here you can call interval and pass in a number. And that is a bit like set interval, where you pass a number in milliseconds that will fire an event every X milliseconds. So if I pass 1000 here, then every second a new event will be emitted. Now this gives us an observable, and therefore we can subscribe to the observable here. And there I can now get my count. You can name this whatever you want and handle this or use this inside of this function. So I'm passing an anonymous function here to subscribe. That's the first argument we can pass to subscribe. It's the handler for all the data values that are emitted. So I pass this in, it gets the value that is emitted as an argument, and I just name this argument count because it turns out it will be an incrementing number for interval. We'll later also build an observable entirely from scratch where we fully control the emitted values. Here we'll take this half measure, which is a built-in function that gives us an observable, but still it's more from the ground up than the ones Angular ships with. So here we have interval, which will fire a new value every second. And in this function here, I will simply console log count. So the idea now is that we get a new value emitted every second and we log that to the console. Now let's save all files and open the developer tools here in our browser. And there, let's go to the JavaScript console and navigate to the home page. And there you should now see incrementing values being logged to the console, one value every second. And that of course comes from that interval function that gives us an observable. And again, this is not an observable we built entirely from the ground up, but it's pretty close. Now, when I navigate away now to user 1, you see that this keeps on counting. And that is something you have to be aware of. Observables don't necessarily stop emitting values just because you're not interested in them anymore. There are certain observables that emit a value once and they're done, like for example an HTTP request where you get back a response, something you'll see later in the HTTP module of this course. But there are other observables that keep on emitting values. And to stop that, and therefore to prevent memory leaks, which you would otherwise introduce if that keeps on emitting whilst you're not interested in it anymore, you should unsubscribe from any observable in which values you are no longer interested. And that's really important because before we do that, watch what happens if I go back to the home page. I'm on user 1, I was on home before, now I go back to home. What you now see is a new observable started. So we have the old one going on and a new one. And of course we can repeat that. We get more and more observables counting, and that of course is very bad. If that happens behind the scenes, you quickly run out of resources and you slow down your app, you introduce a memory leak here because your memory gets occupied a lot by data you don't need. So you definitely need to clear that. And to do that, we should store our subscriptions. And here I'll then name this first obs subscription. You can name it whatever you want. And the type of this private property of the home component will be subscription. And subscription also needs to be imported from RxJS. So make sure to add this import. And now here, subscribe actually returns such a subscription. So when we subscribe, we can store that subscription in our first obs subscription property. So we're not storing the observable here, that's the observable, but we instantly subscribe here, and therefore we store whatever subscribe returns, and subscribe returns a subscription. Now, the idea behind storing the subscription simply is that we now can also implement onDestroy here, which you need to import from @AngularCore, and that forces us to add the ng-onDestroy lifecycle hook, and inside of ng-onDestroy, we can now use our subscription and call unsubscribe. And that means that whenever we leave that component, we clear that subscription. And therefore, we prevent memory leaks because we're not keeping old subscriptions around. Now, if you save that and reload the app, you see our observable starts again. But if I navigate away, we get no new values. If I go back, it starts at 0 again, but the old observable is dead because we unsubscribed. And that's an important step. So this is an important step towards understanding observables. One common question I get is, okay, we unsubscribe here. Why don't we unsubscribe in the user component here, where we also set up a subscription? And that is a valid question. The answer simply is Angular does that for you. For the observables provided by Angular, like params, but also any other observable you'll encounter throughout this course that is provided by an Angular package or by a feature provided by Angular, all these Angular observables are managed by Angular. And therefore, you don't need to unsubscribe manually here. Angular will take care about this. So I promised you a custom observable to understand its internals, and what I gave you was interval. Now, it's closer to a custom observable because it's not coming from some Angular feature, but still this of course is kind of a utility function that gives us a predefined observable that fires a number every second. Well, actually, we can rebuild this manually. Let's comment out this code and let's build a real custom observable now. I'll store that in an observable, in a constant, and I'll name it custom observable or custom interval observable. You can of course pick any name you want. And to create a new observable, we can simply import observable, the type itself, from RxJS. Now you can use observable and call a create method on that, and this will do what it sounds like. It creates a new observable. Now, create actually takes a function, and I'll pass in an anonymous arrow function here, like this, which will get an argument automatically. RxJS will pass in that argument for us. And that argument is a so-called observer. Now, what's an observer? Now, you heard about the observer in the first video of this module. The observer, in the end, is the part that is interested in being informed about new data, about errors, or about the observable being completed. Now, our job here is to tell the observer about new data, about an error, or about the observable being completed. Here, we're not responsible for listening because the observer is the listener. Here, we get that listening part as an argument, and we need to tell it once we're done, once new data is there, and so on. So in this anonymous function, we can now use the regular setInterval method and set an interval of 1 second, let's say, as before. Now this again receives an anonymous function. It's the normal setInterval method, nothing special about that. And inside of setInterval here, we can now call console log or do whatever we want, or simply use our observer. And there, we now got methods like next. We can call next here to emit a new value. And that is important. The observer has a couple of important methods. Next is one of them. Error is another of them. So that would be the one you use to throw an error. And complete is one to let the observer know that you're done. Here, however, we use next. And to also have an incrementing number here, we can simply introduce a variable, count, which starts at 0. Inside of our setInterval, we then simply pass this on to next, and we then increment count by 1. So now here count starts at 0, we increment it by 1 whenever setInterval fires, and we let our observer know about that new data here. Now we can also subscribe to our custom observable. And I'll do this in the same place here in ng-on-init. Of course, you could do this in other places too, if this were stored in a service or in a property of that component simply. So here I can now call subscribe. And to subscribe, you pass the same thing as before. A function that simply accepts the data we're emitting. So in this case, we could name it count again, or to avoid naming confusion, simply name it data, whatever you want. And here I will now console log that data, just as before. Now let's save that all, and let's wait for this page to reload. And again, you see the same result as before. But now we built our own interval observable. And this is roughly what's happening under the hood here for the built-in interval observable too. It's giving us an observable, which will essentially fire for every X milliseconds we defined. And it lets our observer know about that new data. And that's what's happening here too. And if I navigate away, well, then we get a problem here because I tried to call unsubscribe of undefined because I don't store my subscription. Of course, that should be done here. So in my first opt subscription, I'll now store that subscription again, simply by storing the result of subscribe in the subscription again. So now with that, if that reloads and I navigate away, that works without issues again. If I go back, a new observable starts. So this is working, and this is a real custom observable. And this shows us how to emit new data. But what about errors and completing the observable? I mentioned this as well. Emitting new data is arguably the most important thing observables do. And in, I'd say 99% of all cases, when you subscribe, you'll pass that first argument where you're interested in the data you're getting. Or maybe it's 90%, because there is one other important use case too, especially when we think about things like HTTP requests, and that is error handling. This counter here can't fail. There is no error that could occur here. But that's a different story if you're sending HTTP requests, which we will later do. So here, of course, we can also fake an error. We can simply throw one and define our own condition when we want to do that. Now, to do that, we could, for example, check if count is greater than 3. So if that occurs, then we'll, first of all, still emit that new data with the next method, but then we'll also use the error method to throw a new error here. So here I'll create a new error object, count is greater 3, which of course is a horrible event that definitely is worth an error. Now, if we do that and I save everything, let's see what happens. It starts counting again. And as soon as we exceed 3, we get an error here, right? We get our error that we defined. And you see that the observable now stops emitting. It actually gives us 4, which makes sense because that's the last value it emits before this condition is true. But there are no other values emitted, because whenever an observable throws an error, it cancels, it's done. It will not emit any other values, it dies, so to say. And therefore, in that case, you also don't need to unsubscribe. You still can unsubscribe if you navigate away, you'll not get an error, but it's not necessary because, well, it was dead anyways. But you might not have known that when you unsubscribed, so unsubscribing is not an issue. Now, this is how you can throw your own errors, and of course, it's more important to not just throw them. That most of the time will be done for you when you're using some built-in Angular functionality that can fail, like HTTP requests, but it's important to know how to handle that. And for that, you can pass another argument to subscribe. Thus far, we passed the first argument, which is this data function. The second argument would be our function that gets called when an error occurs, and we'll get the error as an argument there. Now, of course, the simplest thing we can do here is that we log that error to the console. But obviously, you could do way more than that. You could send it to your own backend and store it in a database there. You can show an error message, an alert to the user. Let's actually do that. Let's show an alert. And let's show the error message here in the alert. So that's what we're doing here. We're logging it to the console. We're showing an alert. And now it starts counting again. And as soon as we exceed 3, here you go. Now we get our alert. And you see we don't have that red error here on the right anymore. Instead, it's now a regular console log because that's what we're doing. So now we're handling that error. And that, of course, is also an important part. Now, handling errors is nice, but what about completing the observable? I told you that throwing an error actually cancels the observable and lets it die, but completing it is something different. Completing can be a normal process in an observable. Now, our interval by default doesn't complete. It will emit new values until the end of time. An HTTP request, on the other hand, will complete. It completes whenever a response by the server is there. And of course, here, when we're building our own observable from the ground up, we can also complete this manually. In the end, we are defining how our observable behaves. Our event source is the set interval we have wrapped in our observable. And therefore, before we throw an error, let's say, we can also add another condition, say, if count is equal to 2, well, then we simply call observer complete. And there, you don't need to pass any arguments. Now, when you call complete, the observable will really come to a halt. And you can see that if you now reload, it logs 0, it logs 1, it logs 2, and that's it. Doesn't log anything else, doesn't reach our error condition because we complete the observable before it gets there. And that is important to understand and to keep in mind. Whenever an observable completes, it really is done. There are no other values emitted thereafter, which kind of makes sense because, well, it completed. Now, if you want to react to that completion, you can add a third argument to the subscribe method, and that is your completion handler function. It's a function that gets no arguments, because completing doesn't pass any arguments, and it's simply a function where you can do some cleanup work or whatever you need to do. And here I'll just log completed. Also important, you don't need to unsubscribe if your observable did complete, but again, you might not know that here in ng on destroy, so you can still do that without getting errors. So if I reload now, we see our logs again, and after the 2, we see completed. Now, also worth noting though, and important to keep in mind, you might think that complete, so that complete function here, also fires when you're getting an error. After all, the observable does finish after throwing an error, right? Well, that's not the case. If we change the complete condition here temporarily to, let's say, 4, and therefore this to 5, let's say, and therefore this will happen after this condition, which actually will throw an error, you will see something that might surprise you. We see our normal output here, and then we get that error, and that's it. What you don't see anywhere is our completed log. So this here never gets logged. And that's just one important characteristic you have to keep in mind about observables. When it cancels due to an error, then that's a different thing than when it completes. An error cancels the observable, it does not complete it. Technically, in both cases, no new values are emitted, but regarding the functions that get called here, there is a difference. That was a lot of talking about observables, but now we have an example of an observable and how it behaves under the hood. However, I know that this can look even more confusing, and you might ask yourself, well, when do I write this code? Because that's nice about the interval, but come on, I don't need that interval that often in my application. And you would be right, and by the way, if you needed one, you'd of course use the built-in interval function and not build your own one. So what's the idea behind that example? The idea is that you understand what happens inside of an observable. Whenever you subscribe and you set up your different handler functions here, RxJS in the end merges them all together into one object and passes that object, the observer, to the observable. And inside of the observable, it will then interact with the observer and let the observer know about new data and errors and so on. And that is how your functions get called. However, you rarely, very, very, very rarely build your own observables. More often, you use observables that come with libraries like Angular, like the route params observable we already used under the hood. That in the end is a custom observable built by the Angular team, but of course you just use it like that. You rarely build your own ones, but still it's super important to understand how they work under the hood. And in the end, they all work a bit like that. They wrap some event source. In this case, it's setInterval. In other cases, it could be an AJAX request or a click listener or whatever it is. And they give you data or possibly also errors or the complete event. And you will mostly use subscribe and pass in functions that deal with that data or those errors. Now, it's all nice what we learned, but there's one super important thing about observables and the RxJS library that you absolutely have to know, and that would be operators. Operators are the magic feature of the RxJS library, and they are the thing that really turn observables into awesome constructs. If we have an observable and an observer, we of course get data, and we listen to that with a subscription. That is what you learned. Now, however, sometimes you don't need the raw data. You might want to transform it or filter out certain data points. And of course, you could do all of that inside of your subscription or in the function you pass to your subscription. But there's a more elegant way. Instead of setting up that subscription like this, you can use built-in operators in between. That means that the data points, first of all, reach these operators that do something to the data, and that something can be anything. There are tons of built-in operators. And then you subscribe to the result of these operators. Now, let me show you a concrete example that makes that clearer. Let's say here in our application, we of course get our values 0, 1, 2, 3 before we get an error. And let's say I'm not interested in these values, but I want to have some text that says something like round 1, round 2, round 3, and so on. So in the end, I want to use that count, add 1, and add the word round in front of it. Now, obviously, what we can do is we can simply log round plus data plus 1 here, add extra parentheses around that so that it is really used as a calculation. And if we do that, well, we see round 1, 2, 3, and so on being logged here. Now, nothing wrong with that. And for simple transformations like this one, of course, that makes sense. But the more complex your logic gets, the nicer it might be to not care about that here in the place where you subscribe, but in an earlier place. So here I'll revert this to just logging the data, and I want to change the format in which that data arrives. Now, obviously, we could do that directly here where we create our observable, but what if you don't own the observable? What if you wanted to change the route params, for example? You can't change the original code. And that is where operators are important. You can use them on any observable, like our custom interval observable, by calling a method called pipe. Now, every observable has a pipe method. The pipe method is built into RxJS. Now you can import observables, not from the RxJS package, but from rxjs/operators. And there are tons of built-in operators, like the map operator, which is one of the operators you'll use more often. As a side note, if you want to learn more about RxJS and operators and so on, you can visit my homepage, academine.com, and there on the Learn JavaScript, you'll find a complete series on RxJS, which introduces you to RxJS and to operators as well. It uses a slightly older syntax. RxJS was changed in the meantime, which I, by the way, also cover on my page. Here in RxJS 6 what changed, but the core idea and the explanation about these operators still applies. That can be very useful for learning more about RxJS. But that's just a side note. Back to our code here. So we have that pipe method and we're importing map here. And map, as I mentioned, is one of the more important operators. Now we simply call map as a function inside of pipe here. And map in turn takes a function as an argument. So an anonymous function here if you want. That, however, gets an argument. That anonymous function gets an argument, and that is the data you would otherwise get here in your first subscribe callback. So in that first function you pass the subscribe. It's the current data of your observable that's being emitted by that observable. So we get that data here, and in map we now have to return new data. That can, of course, be the unchanged old data, in which case that map operator is totally useless. But it can also be transformed data, like, for example, round plus data plus 1. So what we previously did right in console log. Now we're doing it here. We just have to be clear about the format of data here, as it seems. You can, of course, do that by wrapping data in parentheses here in the argument list, adding a colon after it, and making it clear that this will be a number. And now if you save that, it will compile. But what you'll see in your project now is still the old output. The reason for that is, let's wait for this to complete. The reason for that is that this is applied, but we still subscribe to this observable, and this does not change the data inside of the observable. Instead, it only changes the data we get after pipe. So what we would have to do here is simply we have to take that and replace our observable here with it. So the concrete observable we're subscribing to. Now if we do that, so if we have our observable, then we pipe the data, so we add a couple of operators, in this case the map operator. Then when we subscribe thereafter, we'll get that mapped, so that changed data. And now when we save this, we'll see that we get round 1, 2, 3, and so on. So this is the map operator. And again, just as before, this is kind of a constructed example here. It is, of course, more useful, for example, if you're fetching complex data from a web server and you want to transform that data before you use it in a component. And that is something we'll do later too. But the core idea is the same. With pipe, we can add one or more operators. If you have more than one, you simply add them as arguments here to the pipe method. So the pipe method takes an unlimited amount of arguments, and each argument would be an operator imported from RxJS operators. And you can add as many as you want, and they will execute after each other and do different kinds of stuff on the data. This is map. Of course, for example, you could also filter. That's another operator indeed. So let's use that just to demonstrate one more. Now, there are dozens, by the way. Besides using my page here, you can also visit learnrxjs.io, where you find a long list of the operators with examples, so that's really useful. But back to our code. Now let's dive into filter. And if we wanted to add that too, we would simply add it here, separated by a comma in front of map as an extra argument here. And filter also gets the data, of course. And inside of that anonymous function, which we pass to filter, where we do get that data, we now have to return true or false, which decides whether that data point will continue in that chain, so whether it will reach map and thereafter the subscription, or whether it will be dropped, in which case it will neither reach map nor the subscription. Now, of course, we could hard code true or false here, but that's not too useful. Instead, we could say, yeah, return true if data is greater than 0. And that effectively means that we will return every value but the very first one. And therefore, since we print round data plus 1, we'll not start with round 1 because we're dropping this 0 value. Instead, we'll actually start with round 2 because only then this condition is true. So if we now go back to our application here, let this reload, we see nothing but then round 2, round 3, and so on. So round 1 indeed is skipped. And that shows you, hopefully, the power of operators, that they allow you to build up a chain of steps you want to funnel your observable data through that can be really helpful when it comes to transforming data, filtering out data, and so on. Now that we learned so much about observables, we're almost done with that section and ready to continue, but there is one other important construct that you should not miss, and that is the subject. Now, what's the subject? Well, let's say in our user component here, we have a button, which I'll add, and I'll give it a class of button primary, and I'll give it a label of activate. Now, the idea is that when we click this button, we change something in the app component, so in a different component, and we simply print activated here, let's say. So we add another horizontal line, and in between, we want to print activated, but we want to only show this if we clicked activated on the user component. Now, how can we make this work? Well, with a service and an event emitter, for example. That is something you also learned about earlier. So let's quickly do that. Let's add a new file here, the user service.typescript file here next to the app component. And in there, I'll export a class, user service. Nothing too special. It will get the add injectable decorator, which is imported from @AngularCore. And I will use the more modern syntax for providing it. I'll add provided in root here. Alternatively, you simply add it to providers in the app module here, which is also fine. But this is a shortcut, a shorter and easier way. Now we have that service. And in there, I'll add a property, activated emitter, which is a new event emitter. And event emitter is also imported from @AngularCore. That's a pattern I showed you earlier already. And that event emitter will emit a Boolean. We can now use that event emitter from inside our user component if we inject that service here. So the user service is injected here. For that, of course, make sure to also import it from that user service file. And now we just need to add a new method on activate. And in there, I'll call my user service, reach out to activated emitter, and call emit, and pass true here as a value. And now the last step is to wire up on activate here in the user component to the button by adding a click listener to the button, and there I will call on activate. Thus far, nothing too fancy. That is a normal way of passing the data around, or at least of emitting an event across components. Now we want to listen to that event from inside the app component, and for that we simply inject the user service here too by using that injection shortcut also, where we automatically bind it to a private property named user service. And I'll then add a new property here too, user activated, which is false initially, and in ng on init we can set up a listener. We can reach out to the user service, activated emitter, and subscribe to it. And in there, we get our did activate, or whatever you want to call it, Boolean, and we'll set this user activated equal to did activate. And therefore, whenever we emit true as a value here, user activated will switch to true. And in the app component HTML file, that now means that we can use ngIf here to conditionally show that paragraph as soon as user activated is true. Let's save all of that. Let's navigate to that user page here, and let's click activate. And indeed, we see activated here. So this is working, which of course is nice. This is the old approach with the event emitter. And this is an approach you could use, but there is a better one, a more recommended one. And that new approach, the better approach, uses a subject. Now, a subject is something we import from RxJS. So you import subject from RxJS. Instead of event emitter, you now create a subject here. Other than that, it's pretty similar though. It's a generic type where you define which data will eventually be emitted. In this case, a Boolean. So it's very similar to event emitter thus far. We also use it very similarly. In the user component, we don't call emit, however, but something you saw before already, you call next. Because a subject is a special kind of observable, you could say. We know observables, we can subscribe to them as you learned, but they're rather passive. You learned how to create your own observable, but the core idea always is that you wrap a callback or an event or something like that. A subject is different. A subject also is an object you can subscribe to, but it's more active because you can actively call next on it from outside. Remember, in the observable, we also called next, but that was from inside the observable when we created it. So that is a more active observable that is perfect when we want to use it as an event emitter. So if we don't have a passive event source, like an HTTP request or DOM events, but if we have something that actively needs to be triggered by us in our application. And that's exactly the use case we have here. We now can call next here in the user service on our activated emitter. The activated emitter is that subject. And in the app component, we still call subscribe because it is an observable and therefore we can subscribe. If you now save that, you click activate again, it still works, but now it's a subject. And whilst it technically, of course, works in a similar way, using a subject is the recommended way. Don't use event emitter, use subjects. They are in the end a bit more efficient behind the scenes. You can also now use all these cool operators because a subject in the end also is kind of an observable. So you have that too, which is a huge advantage. And it's simply something you can and should keep in mind. Use subjects instead of observables. One important note, just as with your own observables, you should unsubscribe to your subjects though whenever you don't need them. So add on destroy here to the app component, which you need to import, or to any other component where you set up a subscription to your subject. Store the subscription. Activated sub is a subscription. Subscription needs to be imported from RxJS, so make sure to add that import in your file as well. Store that subscription then, so here where you call subscribe, you simply set this equal to activated sub so that the subscription is stored here. And then you add ng on destroy, and inside of ng on destroy, you simply use your subscription and call unsubscribe. And now you have a great application without any memory leaks or anything like that. Now, one important note about subjects as a replacement for event emitters, this only counts if you're using them as cross-component event emitters, where you manually call next or previously emit. You don't use subjects instead of event emitter when you're using at output. So if you're using in a component, if you're using at output here with your own event, you still use the Angular event emitter. You're not using subject there because the subject is not suitable for that. There you need the Angular event emitter. You only use subjects to communicate across components through services, so through a mechanism where you in the end subscribe to somewhere, like here in the app component. If you're not subscribing to an event emitter, then it probably is an output. If you do plan to subscribe manually, then it is a subject. That's it for observables. You saw how you can build your own observable to basically get an idea of what's happening behind the scenes, how you can subscribe to it and provide different functions to do different things for data, errors, or the observable being completed. You learned about operators, which you add by using the pipe method on the observable, and then by adding the operators you import from RxJS operators, which are tools that might not look super useful right now, but which will actually become quite handy throughout the course, since they make it easy for us to build nice code structures where we have a clear chain of steps we want to execute on the data we're getting, let's say, from a server, and therefore they're really powerful. And you learned about subjects, which are in the end a better event emitter, you could say. And with that, you have a thorough foundation about observables. Now also check out the advanced resources you find in the last lecture of this module, and which I also already showed you throughout this module if you want to dive way deeper. But with that, we now have all the preparation to continue with the course. Let's now use our newly gained knowledge about observables in our recipe book, in our course project. Thus far in there, we are already using a pattern, which you just learned in the last section, that you shouldn't use, or that can be replaced with a better pattern. And that better pattern is, of course, to replace all our event emitters, which we have, with subjects. So for example, here in the shopping list service, we have that event emitter, which we already used to push new information about changed ingredients from component A to B. Well, we'll now change this to a subject instead. One tiny thing I also noticed is that here in the app component, we of course no longer need the onNavigate function, and therefore also not here this function handler. But that's a minor thing. Let's instead focus on the shopping list now. And there, in the shopping list service, I want to set up my subject. So for that, I will first of all add a new import up there. And I will import subject from RxJS, just as you learned it in the observables section. You can now simply replace event emitter with subject here, because it works almost in the same way. That of course means that we can get rid of that event emitter import up there. And now there's one thing we need to fix though. Whenever we call emit, we now have to call next instead, because subjects use next to emit or send a new value. Now, the parts where we consume ingredients changed, however, these parts don't need to change. So here in the shopping list component, where we subscribe to the ingredients changed event emitter previously, we now subscribe to the subject, and that is absolutely fine. It has the same syntax regarding that. However, there is one thing we do need to change. We don't need to change that syntax, but as you learned, it is a good and recommended practice to store that subscription in some property and clean it up when we leave the component. So I'll add a private property, ig change sub, or whatever you want to name it, which is of type subscription. And you therefore need to import subscription from RxJS at the top of your file. Now, with that changed, of course, it's not enough to create that property. I really want to store my subscription in that property. So I'll set this ig change sub equal to this SL service ingredients changed subscribe, because subscribe returns a subscription which we store in there. And now to clear it whenever we leave that component, let's add onDestroy as an interface, which you also import from @AngularCore. That forces us to add onDestroy here. And in onDestroy, we can now use our ig change sub property to unsubscribe. And this now is the recommended pattern, which will replace event emitter with a more optimal solution. Now we're using a similar pattern in the recipes area. If we have a look at the recipes service, there we have the recipe selected property, which is also an event emitter. And therefore, since this is also not decorated with output and not part of a component, which would be a totally different use case. So since we instead use that for a cross-component communication through a service, we should replace this with a subject as well. So let's replace event emitter with subject here, and therefore we can get rid of event emitter up there. And of course now, however, we have to import that subject here. So let's import subject from RxJS, and now make sure that wherever you are emitting a new value, you now use next instead. We're still setting up a subscription to it in the recipes component, but that was done to have a solution for loading different recipes before we added routing. Now, with routing added, we actually don't need this anymore, because now when we want to select a recipe, well, then we do this by clicking on it, and we use the router link directive here in our recipe item component to load different recipes. So instead here, we can actually get rid of recipe selected in total. But if we would use it as we did before, so where we would use that to select different recipes, you would use it as a subject. In our case, as I just mentioned, we can simply get rid of the usage of it and therefore also of the injection of recipe service here in our recipes component. And we can also get rid of the recipe model here. And with that all cleaned up, we're now using the subject in one place in the shopping list area, not in the recipes area, because there we have no use case for it right now. With that, our application looks good and works just like it did before, at least as far as we can go. And now we're using a subject instead of an event emitter. The other parts you'll learn about observables, what they do, how they work behind the scenes, that they can throw errors and that you can use operators, will become a bit more important later in the course. But now already it should be a bit clearer what this routing params thing is and, well, how we can conveniently pass data from A to B in the best possible way by using subjects. Welcome to this course module. This course module is about forms, so forms on your HTML page, and how Angular can help you with those forms. Now, on first sight, it might be strange why you would need that help, right? Because a form is something you can simply submit to the server, but then keep in mind you're creating a single page application, so there is no submitting to the server. Instead, you will need to handle the form through Angular. And if you then want to submit something to the server, you will need to reach out via Angular's HTTP service, which we'll cover later in the course, to that server. So you will need to handle your form through Angular. And actually, Angular will help you handling it, because not only will it allow you to get the values the user entered, it will also allow you to check if a form is valid. It will allow you to conditionally change the way the form is displayed, put some red borders around invalid controls. So Angular really ships with some powerful tools when it comes to working with forms. Let's take a closer look and let's understand what exactly Angular does for you, how it handles forms. So let's take a closer look at how Angular works together with forms. Consider this form. This is the HTML code of a form which you might use, and there is nothing Angular specific about this code. It's normal HTML code which you would place in your HTML documents to maybe display a form like this, with an input for the username and an input for the email address. Now, as mentioned in the last video, Angular's job now is to allow you to retrieve the values the user entered here, and also to check some other things like, is the form valid? Did the user enter valid information? And all that, of course, will happen in JavaScript, in TypeScript, so on the AngularJS side of your app, you could say. So you somehow need to be able to parse the values the user enters, and you somehow need some JavaScript object representation of your form in your TypeScript code to work with. So this object could look something like this. It is more complex in reality, but these would be the key features we need, for example. We need to have the value of the form. And there it would be convenient if we would have key value pairs where the key refers to the name of an input, like for example name or email as specified in the HTML code. And then it holds the values the user entered. This would make it super simple for you to work with these values in your TypeScript code and to do something with the values the user entered. It might also be helpful if some metadata was stored, like for example if the form is valid. And this would be changed to false, for example, if the email address wouldn't be a valid email address. This is what Angular does for you. It allows you, or it gives you actually, such a JavaScript object representation of your form, making it simple for you to retrieve user values and to see the state of the form and work with it. Now in the next lectures, we're going to take a detailed look and we will understand how exactly it works, how we can configure it, what we can do with it, how we can reset it, and much more. Before diving in the actual code, it's super important to understand that Angular actually offers two approaches when it comes to handling forms. It offers the template-driven approach, which is called like this because there you simply set up your form in the template in HTML code, and Angular will automatically infer the structure of your form, will infer which controls your forms has, which inputs, and makes it easy for you to get started quickly. It also has a more complex approach, the reactive approach. There, you actually define the structure of the form in TypeScript code. You also set up the HTML code, and then you manually connect it, which might sound more complicated than it is in the end, and therefore it gives you greater control over it. You can fine-tune every little piece about your form. Now, in this module, we're going to have a look at both approaches. In the next videos, I'm going to start with the template-driven approach, which is fine for a lot of use cases, before we then dive into the more advanced reactive approach. So here I am on a simple example form just to get started. The code responsible for it is this HTML code in the template of my app component here, and you can find this code attached to this lecture here. Now, it's a simple form. We're going to expand it or enhance it with some features throughout this module, but to get started, this is just fine. Now, if we have a look at this HTML code, you will quickly realize that on the form tag here, I don't have the action attribute pointing to some route. I'm also not specifying the method attribute, which typically would be post. The reason for this is that this form should not get submitted to a server. I don't want a HTTP request to be the result of me clicking the submit button. Instead, as mentioned earlier, Angular should handle this form, and therefore I don't have an action on it. This of course means that right now if I hit the submit button, nothing happens. If you have a look at the refresh icon up there, you see it's not spinning, nothing happens because we're not actually sending a request. Well, we will work on this, but first let's understand what actually happens behind the scenes and how Angular infers such a forms, creates such a JavaScript object for us as it does when using the template-driven approach. Let's understand how we get Angular to create this form object for us. In the last video, we had a look at the basic setup of our form. Now let's understand how Angular creates such a JavaScript object representing our form in the template-driven approach. The great thing is, you don't have to do anything. Well, almost anything. Make sure that in your app module, you actually import the forms module added here to your imports array and have the import at the top of this file. As the name implies, this built-in module shipping with Angular includes a lot of forms-related functionalities and is actually needed to get this template-driven approach to work, to get this form creation by Angular to work. Now, by default in a CLI project, this should already be imported, so it should work fine. But again, I'm just highlighting it because it's super important that you have this import, otherwise the following steps will not work. With this imported, Angular will actually automatically create a form for you, so a JavaScript representation of that form, when it detects a form element in HTML code, like it does here. So you can think of that form element serving as a selector for some Angular directive, which then creates such a JavaScript representation of the form for you. Of course, you can't see that form representation as of now. And it would be very empty, because one thing does not happen automatically. Angular will not automatically detect your inputs in this form. And the simple reason for this is that whilst you could argue that it should be able to scan your HTML code and detect that you have an input here, and that you have a select drop down here, you still might not want to add all these elements as controls to your form. So with control, I'm referring to what is in the JavaScript object. And again, not every input in your HTML code might be a control you want to have in your JavaScript form. Maybe you have a dropdown which value only changes something you view on the UI, but the input should not actually be part of what gets submitted. Maybe you use some third-party package which adds some custom form controls which are not labeled input, which don't use input as a selector, and then Angular would have no chance of detecting that this is a control of your form. So you still need to register controls manually. You need to tell Angular, hey, within that form element, what should be an actual control of my form? And this is what we're going to do now. Tell Angular, how does our form look like? Which controls do we want to have? In the template-driven approach, this is super simple. You simply pick the input which you want to add as a control, like this input here. And I'm just going to structure it a bit different to split it up over multiple lines to make it easier to read. And then you add ngModel, like this. Now, you might already know ngModel from the two-way data binding. And it actually is the same directive. In two-way data binding though, you saw that we used it with squared brackets and parentheses wrapping ngModel. Now we will have a look at this later again, but for now let's add it without any parentheses, without any squared brackets, just like this. This will be enough to tell Angular, hey, this input is actually a control of my form. So ngModel in the end is a directive made available in the forms module, something I mentioned earlier in the course when we had a look at two-way data binding. This is key to understand. You can use it to get two-way data binding, but it actually is part of a bigger module with more features, giving you full control over forms. Now for this to work, for this to be recognized as a control in your form, we need to give Angular one other piece of information. The name of this control. Right now it would see, okay, this input should be part of the JavaScript object representation of this form. So whatever the user enters here as a value should be the value of of this control. But what's the name of that control? We need to give that information to Angular, and we do this by adding the normal HTML attribute name. So name is nothing Angular 2 specific. Name is the default attribute you can add to any HTML control. Now here the name might be username because that is what we can enter in this input. And with this control will be registered in this JavaScript representation of the form. Now I'll do the same for the email. Restructure it so that it's easier to read, add ngModel, and add a name, like for example, email here. Well, and the same is true for the select here, which is just another type of HTML input. Here we can also add ngModel, and we can add a name, like secret, because I'm asking for a secret question here. And with that, we registered all the controls. Of course, we can't see that much though. Well, that is something we're going to have a look at in the next lecture when we see how we can submit such a form and therefore how we can see these key value pairs representing what the user entered into which input. In the last lecture, we configured our form here. We added some controls by placing ngModel on the inputs. Now let's make this form submittable so that we can actually see what the user entered. For this, I'll go to my app component. I already do have a method here which we will use later. Let's ignore it for now. And I'll add a new method on submit maybe. This should be triggered whenever this form is submitted by the user. In onSubmit, I want to output whatever the user entered. Well, first of all, we need to call this method. So back in the template, how can we call onSubmit? Now you might think that a good place would be on a click listener on this button here at the bottom, right? Because this is the button we click when we want to submit the form. However, this is not the best place to do it. Keep in mind that this button here is of type submit, so if we click it, as it is placed inside of a HTML form element, something else will happen. The default behavior of HTML will be triggered here, to call it like this. If you have a button in a form element, this button will submit the form, will send a request normally, but besides that, it will also trigger a JavaScript event, the submit event, that's built into JavaScript, built into HTML, you could say. Angular takes advantage of this and gives us a directive we can place on this form element as a whole. It is called ng-submit, and it actually only gives us one event we can listen to. So let's wrap it in parentheses. This event, made available by the ng-submit directive, will be fired whenever this form is submitted, so whenever this default behavior is triggered. And here we can call onSubmit like this, and to show you that this works, I will simply go into onSubmit and log submitted here, just like that. Now if we save this and let it recompile, let's go back and let's open up the developer tools. And if I now hit the submit button, you see submitted here on the right, because indeed the form gets submitted. Now it would be nice to see the actual values of the form though, to see that form object. And to see it, we have to go back to our template, because we're in the template driven approach. So as a rule of thumb, everything you do it in the template. Everything you want to change about this form, you want to add as functionality, you do it in the template. On this form object, we want to get access to the form created by Angular. Now you learned about local references you can place on HTML elements to get access to them. So we could place #f on the form element, and now we could access this form element on, well, the f reference in our template, and we could pass f as an argument to the onSubmit method and print it there. So now we know that we get the form, and actually this will be of type element ref, as we learned. So if we import element ref and make this of type element ref here, and we output the form here, so this element, if we now go back to this and hit submit, yeah, we indeed see that form object. We see some strange classes here, I will come back to them. But that still is not what we want. It's not a JavaScript object created by Angular. But this object is there, we just need to know how to get to it. And there actually is a trick, you could call it, but it's no trick, it's the default way to get access to this automatically created object. You set this local reference equal to something. Now we haven't done that yet, but we can set it equal to something exposed by this form here. Keep in mind, the form element is kind of a selector for a directive built into Angular, which will create this JavaScript object automatically. And then it will expose some data we can fetch here on this form element. We can get access to it by writing ng-form here between the quotation marks. So this might look super strange, but what this in the end does is it tells Angular, hey, please give me access to this form you created automatically. That's just something you have to keep in mind. This is how you get access to the form, to this JavaScript object created by Angular automatically. So therefore, here where we get this form, we now still pass it. Now this will no longer be an element ref, so let's remove this type here. Instead, this will now be of ng-form. So let's import ng-form from @AngularForms. And it kind of makes sense that it is of type ng-form, because that is what we're accessing here, this automatically created form. Now let's print it to the console one more time, and let's actually enter something into these fields to see that it worked. If I now type submit here, you see that now we get an ng-form object, an object which we certainly didn't create. And there we have a lot of properties. We'll have a closer look at those later. We also do have a value property. And if we expand this, we indeed see a couple of key value pairs here where we have the names of the controls. So the names we set up here on the name attribute, like username and email. We find them here. And then the values the user entered. And this is how we can submit such a form and how we can also get access to the form object created by Angular. We also see that our setup of controls also worked. In the last lecture, we learned how we can submit a form created by Angular and how we can access to this object Angular created for us. Now we had a look at the value property, which stores the input of the user in key value pairs. We see that we also have a lot of our properties. And that's pretty cool about this JavaScript object, about the form handling by Angular. It allows us to really understand the state of our form. We can see which controls we registered here on the controls object, email, secret, and username, and each control is of type form control, of course a type made available by Angular, where each control then has a couple of properties, mostly the same properties we have on the overall form though. And therefore let's go back to that overall form. For example, properties like dirty, disabled, enabled, errors, and most of the properties should be pretty self-explanatory. Dirty, for example, is true because we changed something about that form. If I reload the page and submit it now, you will see that dirty is false because I didn't type into any input. So therefore, of course, dirty is false. Disabled would be true if the form was disabled for some reason. Invalid is false because we haven't added any validators, so it isn't invalid, it is indeed valid. You do have the valid property down here too, so the form is valid right now. We will later learn how to add validators to make sure that a valid email address has to be entered, for example. And we also have touched, for example, to see did we click into some of the fields. The difference to dirty would be that for dirty we have to change the field, have to change the value of a field. For touch we simply have to click into it and now it would be touched. And you will later learn how these properties can be helpful in, well, changing the user experience. For example, disabling the submit button if the form is not valid. I will come back to this later. It's important to understand that you have all these properties, and definitely feel free to dive into the output we logged here and understand which properties you have, how they change, which properties the individual controls have, and so on. In the last lectures, we learned how we can register controls and how we can submit the form and also which properties this form has. Now, right now, we submit the form by passing the form, which we get via ngForm here, to the onSubmit method. This is absolutely fine and probably the approach you will use in many use cases. I just want to bring some other approach to your attention. You don't have to submit it here. Remember the component section where we learned about add_viewChild, which allowed us to access a local reference, an element controlled or which holds a local reference in our TypeScript code? Well, in the end, we do just have such a local reference here. And whilst it might not point to an element ref, but to the ngForm object, it still is a local reference in our template. So we can also use add_viewChild here. So I will simply comment out this onSubmit method here so that we have it in the code you can find attached to this module and show you an alternative approach. In this alternative approach, I will use add_viewChild, this decorator you learned about in the component section. So make sure to import it from @AngularCore. And I want to get access to the element which has the local reference f on it. So I pass f as a string as an argument to viewChild. And then I could simply store this in a variable named signup_form, any name you like, which will be of type ngForm, of course. Now in onSubmit, I could output this signup_form like this. And you should see that if I now submit this again, we still have this form. And I can also enter something so that we can see that this works too if we have a look at the value. So this gives us access to the very same form without passing it to onSubmit. This is especially useful if you need to access the form not just at the point of time when you submit it, but also earlier. And I will show a use case for this in a later lecture. For now, let's keep in mind that this is another way of getting access to the form in our TypeScript code, a perfectly valid way of getting access. And before diving deeper into why this might be useful or when we could use that, let's actually understand how we can control the validity of the form. So to determine whether the form is valid, if we enter the valid email address here or not. Because right now I can submit anything, no matter if this is invalid, if this is empty. It would be nice if you could add such validation and take advantage of the tools Angular gives us there to possibly also enhance the user experience by placing a red border around invalid elements or something like this. We'll have a look at validation in the next lectures. So as mentioned at the end of the last lecture, it would be nice if we could validate the user input, something very important in any app you build. Whilst you should still validate input on the server, as the frontend can always be tricked, you can greatly enhance user experience by also validating the input here. For example, we want to make sure that none of the fields here is empty and that the email address actually is a valid email address. So let's go back to our app component, to the HTML file, to the template, and see how we can add such validators. Now, since we use the template-driven approach, we can only add them in the template. And here we can, for example, add required to our username input. Now, required is a default HTML attribute you can add to an input. Here, however, Angular will detect it, so it acts as a selector for a built-in directive shipping with Angular, and it will automatically configure your form, you could say, to take this into account to make sure that now this will be treated as invalid if, well, it is empty. And on the email, we can, for example, therefore also add required, and there also is an email directive you can add. Now, email is not a built-in HTML attribute, it still is a directive, and keep in mind, required is only treated as a selector for an Angular directive here. An email is simply another directive made available by Angular, which makes sure that this is actually a valid email address. So now if we save this, and we have a look at our form here and I submit it. I can still submit it because we haven't set up anything which would prevent us from doing so. But if we have a look at it and check the valid attribute, you see it is false. And if I enter something here, so it's filled, but the email address is still not valid, you see that still valid is false. Only if I turn this into a valid email address here, only in this case. Now if we submit it, now you see valid is true. So now Angular tracks the state of this form and correctly informs us or gives us a chance of querying it whether this form is valid or not. And actually this does not only work on form level. If we dive into the actual controls, you see that on the email control, we also have a valid attribute, which is true. So it tracks this on a per control level and then also on a form level. Now, there also is another place where it tracks this and helps us. If we inspect this email element here in the HTML code, you see that it adds a couple of classes because the form control class here is by us. It's a bootstrap class to give it some styling. But ngDirty, ngTouched, and ngValid, these are not classes added by us, and the ng at the beginning makes it pretty clear who is responsible for adding these classes. Now watch these classes if I remove the @ sign here. You saw that ngInvalid was added and ngValid was removed. So Angular dynamically adds some classes giving us information, some CSS classes, giving us information about the state of the individual control here. Whether it is dirty or not, so whether we did change the initial value, whether it is touched or not, so whether we clicked into it or not, and whether it is valid or not. Now with that information, we can style these inputs conditionally. So let's in the next lecture take advantage of the fact that Angular tracks the state of the validity and of the form overall, and change the styling and the behavior, the user experience with that form. In the last lecture, we found out that Angular tracks the state of each control of the form, whether it's valid and so on, and conditionally also adds these CSS classes. Now with that information, we can go back to our form and you take advantage of it. Before diving into these CSS classes, the easiest way of taking advantage is down here on the submit button. Let's disable the button if the form is not valid. So I'll just split this over multiple lines and add some property binding. I want to bind to the disabled property, which will set the disabled state of this button to true or false depending on some condition, and I will specify the condition here. Now I could say true here to always disable it. That of course is not super useful. Instead here I want to check whether the form, remember we do have access to it on this f local reference here. So if this form is valid, or to be precise, if it is not valid. So if this form is not valid, the button should be disabled. And we can actually see this once this reloads, that now the button is disabled, and only if I enter some valid values here, I can hit the submit button again. So this is the first improvement in place. The second improvement is to take advantage of these CSS classes. We do get these classes added automatically, so we can now go to the style sheet of this app component, and we could say that on ng invalid, we want to give it a red border, so 1 pixel solid red. Sounds like a solid idea, doesn't it? Well, if we do this, you see everything's red now. The two controls, but also the overall form. The reason for this is that our overall form is also invalid, and that Angular also adds the ng invalid class, CSS class, to the form element. So a better approach would be to make sure that it is not added to the form. Now there are a couple of ways of doing this, and it's all just pure CSS logic. One idea would be that we want to be inside of the form element, but then it would still place these red borders around grouping divs. We will have a look at what I mean with this later. So the best way is to simply be explicit that we want to add it on inputs, for example. And of course, you could also add select here, so input with ng invalid or select with ng invalid and whichever elements you have. Just be creative here. There are different ways of achieving this goal. In the end, you just want to make sure that the border is applied to the right controls. Now with this in place, we see that now we only have a red border around the invalid controls, but we do have the border right from the start, which is also not great because I at least want to give the user the chance of changing it before showing a warning, showing that it's wrong. So a better approach might be to make sure that we only add a red border to an input which has the CSS class ng invalid and also the CSS class ng touched, so that the user has to at least click into it. Now by default, we don't see anything red, even though the form is invalid. But if you click in there and decide, yeah, I'm done, this is my value, well, now you see we have a red border because now we had a chance of changing it, we didn't change it, it is invalid, and we want to show this. And with that, we're taking advantage of this form state handled by Angular. We disable the button and we show a visual feedback to the user. Now you could of course go much further. You could also add a warning message below this input here, for example, and output, please enter a valid value, or be more precise than that of course, and add ngIf to conditionally show this if the input value is wrong. Well, this gives us one additional problem though. How do we determine whether this input here or this control here does hold a wrong value? We'll take a closer look in the next lecture. In the last lecture, we improved the user experience by taking advantage of the form state handled by Angular. Now let's improve this even more, and let's say we want to output some help text below this input to assist if there is an invalid value in there. Now we can use a bootstrap class here, help block, to make sure that this has the appropriate styling. And then we could say, please enter a valid email. We only want to show this if if an invalid value has been entered into the control associated with this input though. Well, a quick and easy way of getting access to the control created by Angular automatically as we added ng-model to the input is by adding a local reference to this input element here, for example, email, any name you like, and associating this now not with ng-form as we did for the overall form, but with ng-model. So just like the form directive automatically added by Angular when it detects a form element, the ng-model directive here also kind of exposes some additional information about the control it creates for us on the overarching form by accessing ng-model. So with this, we could simply check or say that we want to attach this span here if email is not valid, so add exclamation mark at the beginning. Now with this, if this reloads, you see that help text, and of course you can improve this by also chaining another condition that the email should have been touched to give the user a chance of changing it. So now you don't see the warning, but if you click in there and click out of there and it is invalid, you see that warning, and if you now enter valid data, it disappears. So this is another way of taking advantage of the state managed by Angular, but this also shows you how you can get a quick and easy access to control added by Angular. And with that, you should have the tools to really provide a pleasant user experience, showing the right errors, the right warnings, and styling the form correctly depending on the state of the form. Thus far, we learned a lot about the template-driven approach and how we can create great forms with it. Now let's move on, let's leave the world of validating user input here. And let's say we want to define some default values which should be displayed. For example, on the dropdown here. Right now it's empty by default. Well, it would be nice if one of the two questions would be selected, right? For this, we can change the way we add ng-model. Right now we add it like this, without property or event binding, no two-way data binding. Well, we can use it together with property binding. So let's add some squared brackets around it, no parentheses, so we're not using two-way binding as of now. And now we can bind it to a value. And remember, with it, I mean the control, this input here, which is turned into a control by Angular in the background. So this select here can now be bound to a default value. And you could either hard code a string into there, don't forget the single quotation marks in this case, or you set up a property like, let's say, default question, which would be pet. Pet, because that is one of the two valid values, the other one being teacher for this question here. So now we can bind this to default question. And if we now save this and let it reload, you see that now pet is selected. And of course, if we switch this to teacher, well, it shouldn't be a surprise that the other value is selected. So now all of a sudden we're using a default value. And of course, this does not only work for the dropdown, it would also work for the username. You could point to a default string there, pre-populating this field with a default username. Very useful and something you should definitely keep in mind, that you are not limited to using ng-model without any bindings. You can use one-way binding, property binding, to set a default value. Of course, this value can still be overwritten. You can still pick a different option here. Sometimes you not only want to pre-populate the default the user entered, but you also want to instantly react to any changes. Right now, everything about this form here only updates once I click submit. Then I get this form object where I can retrieve the value. We don't use two-way binding. ng-model is either used without any binding or with one-way binding. But sometimes you instantly want to check something or simply repeat whatever the user entered. Let's show an example. For this question here, I'm going to add a new form group, bootstrap style here, below the dropdown. I want to have a text area, let's say, to also introduce a new input. Let's name it question answer. Don't need the ID here, don't need columns. I want to have 3 rows, let's say, and I'll also distribute this over multiple lines. And now we could add ngModel to get access to whatever the user entered as a reply. But maybe, for some reason, we instantly want to repeat this reply. So below this, we could say your reply, and now we want to output the answer to the question. Well, for this, we could still use two-way binding on ngModel here and bind it to the answer property here. Of course, we need to introduce this answer property then there. An answer could be an empty string by default. With this in place, let me also add a CSS class to the text area, form control, to give it some nice styling. If this reloads, we see our text area here. And if I enter valid data here for my first pet, let's say, a rabbit named Nelly, you instantly see that here. So you can still use two-way binding. And actually, if I submit the whole form and open up the developer tools, you see in the value object, this is still part of this value object. It just is updated with every keystroke. But of course, if we submit it, we will get a snapshot of the value at a point of time we hit submit. So two-way binding is still possible. You can still use ngModel with two-way binding. And with that, you saw all 3 forms. No binding to just tell Angular that an input is a control. One-way binding to give that control a default value. And two-way binding to instantly output it or do whatever you want to do with that value. Our form has evolved quite a bit. Now let's say that on the value object we get when we submit the form, we want to group some things. For example, we want to group the secret and the question answer and the username and email to just have some structure in our object, because for a very big form, we might want to have such a structure. This would also be nice if we could then validate the validity, the status of our individual groups of inputs. Turns out that's easy to do with the template-driven approach. Here on our first group, username and email, I already have a wrapping div with the ID user data here. Now you can simply place another directive on it, the ngModel group directive, like this. And this will now group this into, well, you guessed it, a group of inputs. However, ngModel group needs to be set equal to a string. So for example, user data. This will be the key name for this group. So now if I save this with ngModel group added, if I enter value here and hit submit, and we have a look at the value of the form, you now see that we have a user data field here, which holds another object where we now have email and username. Now, not only did we add this extra field in our value, we also now have a different setup here in controls. Here we also now have a user data control with all the properties you know on those controls, like valid and so on. So if we now simply inspect our HTML code and this div with the ID user data, you see that there also we got the ngDirty, touched and valid classes added. So you can now also check the validity of this overall code control here, for example, which might be a nice feature in your form. You can also get access to the JavaScript representation by again adding a local reference to the element which holds the ngModel group directive. Here, for example, user data would be a fitting name. And then setting this equal to ngModel group. So just like we did before with email, which was equal to ngModel, I'm now setting this reference equal to ngModel group to get access to this JavaScript object. And this would allow us to, for example, output a message if this whole group is not valid. So we could simply output a paragraph here, user data is invalid, which we add if user data, this is the local reference created here, if user data is not valid. And let's say it has been touched. So user data touched is true. With that, if this reloads, you see that we don't see any message, but as soon as I click into one of the fields and then leave it, you see user data is invalid was shown. So now you really got a very fine-grained control over your form with all these tools. We're nearing the end of the first part of this section, the template-driven approach. There's still some things I want to show you. For example, how to work with radio buttons. We don't have any radio buttons in our form as of now, so let's add some. Let's add a property in the app component first with some genders. So this is simply an array where I have male and female, and I don't want to insult anyone. I know there are more genders nowadays. I'm going to go with the classic approach here, just to keep it simple. We have this genders array, and now with that array, I want to output genders here. So let's say below our your reply paragraph here, I'll add a new div with a class of radio. And this div should be replicated for all the genders. So I'm going to loop through my genders, maybe bind it to a gender variable. And this is just a setup Bootstrap uses to give this some nice styling. Of course, use any other setup to style your radio buttons here. I'm looping through all the genders. And now again, in the Bootstrap world, to create a nice looking radio button, I'm going to wrap it in a label, this input here, which is of type radio. And I'm going to wrap this over multiple lines too, just to make it all super simple to read and to understand. And here I will give it a name of gender, because on a radio button I can only select one of them in a group. So the name should be gender for whichever button is selected. And I will place ngModel on it to make it a control. And I will pre-populate, or I will set the value of this button equal to gender. So this variable of my ng for loop. Now with that, if we save this, we should see that we have some gender buttons. To output a text, I need to add it here after my input. So again, gender here, like that. And now we have male and female here. And if I just enter something so that I can submit the form, and I pick male here, you will see that on the value object here, we got gender, which is male. And of course, if I pick female, this will, you guessed it, be set to female. So this is how you can easily incorporate radio buttons by binding or by placing ngModel on the input as always, setting the value. Of course, you could also hard code the value, and that, well, makes it usable just like any other input. And if you want to set it to a default gender, of course, you can use one-way binding again to make sure that one of the two buttons is selected by default at the start when you load the form. You can also, of course, add the required directive or attribute to that input here to make sure that now the form will not be valid until one of the two has been selected. So that works just like on any other input. So I just wanted to highlight this because radio buttons can look like a very special case. They aren't. They are used like any other input when using the template-driven approach in your Angular app. We learned a lot about the template-driven approach. Before concluding this first part of the module, let's have a look at this suggestion username button here. It doesn't work, but I added this suggest username method here, where I create a default username. Now it would be nice that upon clicking this button, we populate this username input here with this username. Now you could think about some solutions using two-way data binding, and they would probably work. You could two-way data bind this to a username property, which you then change with this method. I just want to show you a different approach. Remember that we do have access to this form here through view child. Of course, it would be nice if we could set the value of one of our inputs. And turns out we can. For this, we got two different methods we can use. The first one would be on our sign up form, the set value property method here. This allows you to set the value of the whole form. And here we need to pass a JavaScript object exactly representing our form. So we would need to use or set up user data, which is our object 2, where we have, let's check, a username field, username set to the suggested name here, and then also email set to maybe an empty string, and secret set to pet maybe, and question answer. Keep in mind, this is this text area here. So question answer set to an empty string. And last but not least, the gender set to male. And with this all added, let's go to our template and hook up this button here, which is of type button so that it doesn't submit the form. And here I'll add a click listener and target the suggest username method. So if this now recompiles and we hit this button, you see super user was entered here. However, this approach does have one downside. If we already had some value entered there and then wanted to click suggest a username, it, well, overwrites all our other content. So this is not necessarily the best approach. However, it does show you how you can set the values of all controls with one convenient command, with the set value command, where you pass an exact copy of the form value, I should say, as a JavaScript object and can override the value of each control. Now, as mentioned, this is not the best approach, so let's comment it out. The better approach here would be to access the sign up form and now actually the form object on it, because sign up form, this overall ng form object, is kind of the container of your form, you could say. And there you also have the patch value method. So this is not available on the sign up form itself, but on the form group wrapped inside of it. And here you can pass a JavaScript object too, where you only override specific, certain controls. So here you could also pass user data. Let me restructure this so that it's easier to read. User data, and then inside of user data, here you might want to override the username, set it to the suggested name, but don't override any other value. So with this in place, if I now save this and I already have an email address entered and something here, and I click this button, now it only added super user and left all my other controls untouched. So set value and patch value, important patch value only available on the form wrapped by ng form itself. As a side note, set value would be available here too. So these two commands are very helpful. Set value to set your whole form, patch value to override parts of the form. Very useful helper methods I wanted to bring to your attention. Now we're almost done. Let's finish up our form here. We got a submit button and right now we only log it. Now let's add something to our little form here. Let's add a horizontal line below it. And let's summarize our data maybe in a new Bootstrap row here. So let's add a row class and then a column class here, a very simple one. Let's summarize our data there. I'll place the horizontal line between the Bootstrap rows. And I want to say or output my username here. I want to output my mail address, maybe my secret question and my answer to that question, as well as my gender. So just a nice summary. I only want to output this once the form has been submitted and then populate it with the data of my submitted form. So in the add app component here, I could add a new property named user maybe, which is a JavaScript object which holds a username property. let's set it to an empty string by default, an email property, and these names here, of course, don't have to match the control names in your form. That's a brand new JavaScript object not related to your form directly, at least. Then here we might also have a secret question, which is a string, and then we have the answer, which is a string, and finally the gender, which is a string. So that's my user object as created by default, and when submitting the form, I want to update it. So here I then want to say this user, and there I want to access the username, let's say, and set this equal to my sign up form, access the value of this form, and there we know we have a username input field like this, and replicate this now also for the email. And of course the value, of course, was available on the user data grouping though. So username and email was in the user data model group. Keep this in mind. So we have to access this model group property first before we can access the final username and email. However, the secret question here was available like this. We did name the control secret though. So make sure to use secret here when accessing it in the form value. And the answer, well, let's see which name we gave this. We gave it the name question answer, so let's use this when accessing the form. And finally, we want to set the user gender equal to what we stored in the sign-up form. Here, we did name this control gender too. You can check it down there, gender. So with that, we now update all that information in our user. Maybe we also want to track whether we did submit the form. So we do have a submitted property set to false initially, and we set this to true here because, well, guess what? We submitted the form. And with that, we could place ngIf on our row here to check whether the form was submitted. And only if it was submitted, I want to display this block. And here, I then want to output user, username, and of course all the other information we gathered, like user email here. So let's quickly add all of this. Here the question would be your first, and then we store user secret question. Here we have the answer, and so on. Of course, structure this in whatever way you want to structure it. I just want to show you how you can access your values and use them. And with this all in place, now you don't see that section by default, but if I enter something here like Anna, or let's suggest a username actually, my email address, my first pet, which is Nelly, and then the gender, I think that surprises you. That's not correct though. So let's hit submit, and now we see the data here at the bottom. This is how you can extract the data, how you can use it, how you can add a property like submitted to make sure you only display certain sections if the form was submitted, and how you in the end use that data. One more thing before we move on to reactive forms though. In the last lecture, we saw how we can finally submit the form, extract the data we want to extract, just so that you saw this too, that you just can access the value property on your form. Now let's say we did extract all the data, and now we want to reset the form. Well, turns out this is super simple. On our form, sign up form in this case, which again is just fetched directly from our template with viewChild, on this form, we can call reset like this. And this will reset the form. And what this means is it will not only empty all the inputs, you could do this with set value too, as you learned. It will also reset the state, like the valid, detached, and so on, these properties. So now if I enter something here again, like this, and I hit submit, you see everything is empty, and if we inspect it, you see that also the classes have been reset to pristine, invalid, and so on. So it's really like the page was loaded again. Very helpful to notice how to reset the forms. With that, you got a great overview over how you can quickly create powerful forms with Angular with the template-driven approach. This approach might be well suited for the majority of your use cases. During the rest of the module, though, we're going to have a look at the other approach, the reactive approach, which gives us even more control over our forms and which allows you to create more powerful forms, your own validators, and much more. So let's dive into this in the next lectures. In the last lectures of this module, we learned a lot about Angular forms and how we can create such a form and configure it to our needs. But remember, there were two approaches, not just one. So we had a look at the template-driven approach, now we're going to have a look at the reactive approach. This approach allows you to configure your form in greater detail. You create the form programmatically in TypeScript, and whilst this might sound more complicated, it actually isn't that difficult, and it might be what you need for your new project. So let's dive into this approach now. So, time to practice the things you learned about the template-driven approach in the last lectures. Here's your assignment. I want you to build a form which has a mail address input field, a drop-down with 3 options, basic, advanced, and pro, a password field, and a submit button in the end. I also want you to add some validators to these fields. The email should not be empty and it should be a valid email address. For the dropdown, there is no validator, but I want you to select a default or to set a default right from the start, the advanced option. And for the password field, it should not be empty. And once you created that form and added the validators, I want you to take advantage of the form status by displaying a message if the form is invalid and has been touched, or if a single element is invalid and has been touched. And once you submit the form, I simply want you to print the value to the console, though of course feel free to go for a more advanced solution where you output the values in the template. This is the assignment, have fun with it. In the next video, we're going to have a look at my solution. So, were you successful? Let's solve it together. I will leave the instructions here at the top so that we can have a look at them. And I will start with the form element. Remove the action, of course, because we don't want to send a request. Instead, Angular should take over. And it already takes over because it detects the form element here. Now, in this form element, I'll add a form group, a div with a CSS class of form group, and this is a pure styling thing. Has nothing to do with Angular forms. It's just to make it look nice. In there, for the mail address, I'm going to add a label for an element with the ID email. Let's name it mail. And let's add the appropriate input below it, type email maybe, set the ID email. And now, to register it as a control in our Angular form, we have to add ngModel. Remember, this is how we tell Angular that this input now actually is an active control of this form Angular created automatically. For ngModel to work, you need to make sure that you added here an app module in the imports array. So with this added, we also need to add a name here. The name should be email because it makes sense, I guess. It is an email address we want the user to enter here. And I'm going to distribute this over multiple lines. Now, this should also receive 2 validators. It should not be empty, and it should be a valid email address. So let's add required, this HTML attribute, which will be taken over by Angular, so that Angular now checks the validity. And then the built-in validator Angular offers, email, to check whether this is a valid email address or not. With that, we're almost done. The last thing I want to add here is I want to add a CSS class, form control, to make it look nice. Again, this is a bootstrap class, has nothing to do with Angular forms. With that, I'll move on to the next control. I'll also place this in a div with a form group CSS class to make it look nice. And in here, we want to create a drop-down to allow the user to choose a subscription. So I'll add a label for, well, let's name it, give it an ID of subscription. And here we could say choose a subscription, something like this. And then a drop-down is created with a select element here. Now the name could be subscription because it makes sense. The ID should be subscription to match this label. And I will also add ngModel here. And we already have the name, so no need to add this again, but we need to add a class form control. We don't need to add it, but again, I want to have this look all right. With this, the select is configured. Now we need to add the options. And we could hard code the options in here, but just to show an alternative, and this is purely optional, I'll go into my app component, and here I will add a subscriptions array as a property. And here I simply want to add basic, advanced, and pro as free strings in this array. And with that, I can now go back to the template, add the option, but not fill it manually. But instead, I will simply add an ng for loop to loop through all these subscriptions I set up. So let subscription of subscriptions. And this allows me to bind value here via property binding to, whoops, not like this though, like this, to the subscription of the current iteration. And then we can, of course, output it here too to give the user something to see as well. And with this, if we save, just to check if we're on the right path, I already got ngserve running. That looks all right. Now with this, we need to set a default value here though. And one way to do this, a nice way actually, is to create a property, for example, the selected subscription we could call it, and set this equal to advanced. Should of course be a value of our array here. So we can use this selected subscription property here to set the default value by using one-way binding, property binding on ng model. So I'm going to distribute this over multiple lines as well. And now ng model with squared brackets, to again set up property binding, should be bound to the selected subscription, to the property we just created in the TypeScript code. With this, if we now save this and have a look at it again, we should see that advanced is now the default option because we're setting a default value. Keep in mind, if we now change the selected value, this will not update selected subscription here because we set up property binding, one-way binding, not two-way binding. It's not updating the property is only setting the value of our dropdown. That's important to keep in mind. Now, the last field to add here is the password field. So let's quickly do this. Just add another form group maybe. And in there I'll add a label for the password, say password here, and add an input which should be of type password to hide the characters, which should maybe have an ID of password to match the label, and a name of password because it makes sense, I guess. And of course, very important, add ng model to register it as a control in our form. Now with this, we created this as well, and here we should add the required validator because again, this is what we expect here. The password field should not be empty. I'll also add the CSS class form control to improve the styling. Again, this has nothing to do with Angular though. This is purely optional to make it look nicer. With this, our form is almost complete. I'm now going to add a button here at the bottom with two bootstrap classes, button and button primary. I'll say submit on this button and I'll set it of type submit. This is technically not required since the only button in a form will automatically submit it, but just to have semantically correct HTML code, this button will submit the form, so we should set it of type submit. With this, if we now have a look at our finished form here, looks all right. Let's check if the validation works. If I check my mail address, it's invalid. If I enter a valid email address, it's valid. If I remove the @ sign, it's invalid. So this looks all right. The subscription doesn't have any validation. Now for the password, it's invalid. It should change as soon as I type one character, and it does. So this is all valid. Let's now make this form submittable, or actually, let's first work on these warning messages. I want to display warning messages for my mail and my password input because these are the two inputs which have validators. So in the form group of the email, below the input, I'll add a span, and on the span I'll add the class help block. Again, this is bootstrap styling to make it look nice. Of course, you can use any other CSS framework or your own CSS code. And in here I will say, please enter a valid email. Now it would be nice to not always see this message, but only if the mail input is invalid and was touched, to give the user a chance of actually changing it before we show an error. Well, therefore, what I can do here is I can add a local reference, email, and bind it to ngModel as we learned it to get access to this control Angular creates for us on the form. Now with that, I can add ngIf here and say if not email is valid, so if it is invalid, I want to show this, but also email should have been touched. So if these two conditions are true, I want to show my help text, and the check, which we do now, should show that it works. If I click in there and click out of there, we see the warning. If I now enter a valid email address, it's gone. So this works. Now let's also copy this and add it for the password here in the form group as well. Here I will say, please enter a valid password, and adjust my code to place a local reference on the password field. Maybe give it a name of password and bind to ngModel again to get access to this control which was created. And then I'm going to replace email here in the ngIf condition with password. And now we should get the same behavior down there. If I click in there and click out of there, we see the warning. If I enter something valid, it's gone. If I remove that, we see the warning again. So this is working. Let's now add a message for the whole form. For this, right above the button, maybe I'll add a paragraph where I will simply say the form is invalid. Any message you like, of course. And now I want to get access to the form. So I will place a local reference on this overall form element, because this is how we can learn that we can get access to the form Angular created for us. Give it a name, F or form or whatever you like. I'll name it sign up form. And set this equal to now ngForm, not ngModel, because we're not talking about a control here, but about the whole form. And there it is, ngForm. And with that, we can use it down here or anywhere in our template actually to check whether the sign up form is valid. If it is not valid, so with an exclamation mark at the beginning, and if it has been touched, then I want to show the form is invalid. So if I click in here, click out of there, we see the form is invalid. Let's enter something in both fields. It's gone. Last step is submitting the form. To submit the form, we have to hook up the submit button. And remember, you don't add a click listener to the button. Instead, you take advantage of the default behavior of HTML and add the ngSubmit event here. Now here we can execute on submit or any method name you like and add this method in the component on submit like this. Add it here, and now you could either pass the form as an argument to this form, to this method, excuse me. So simply pass it here, the sign up form, and then receive it as an argument would be perfectly fine. Or you use @viewChild to get access. So that is what I'll do here. I'll use @viewChild, which needs to be imported from @AngularCore. Select my sign up form, so this local reference name you created. Give it any name you like here. This does not have to match the name you chose in the template. So this could just be the SGN form, just to show that it may be different. This will be of type ngForm then. Make sure to import this type from @AngularForms. With this, we now got access to the form in our template. So here, in our TypeScript code. So here we can now access it like this and output the value of our form once we submit it. So let's see this in action. Let's head over to our form, enter some valid values here like this, open a console and hit submit. And this looks all right to me. We got an object with our free controls and the values we did enter. So this was a tiny little exercise about the things you learned in the last lectures. Let's now move on to the reactive approach. Just like before, I already created a little template, a little HTML code for the form with which we're going to work. It looks like this, and you can find it attached to this video. Now, as I said, in the reactive approach, the form is created programmatically, so in TypeScript code. So this is where we should start working on it in this app component here, in this TypeScript file. Here, I want to create a new property which will hold my form in the end. And no worries, programmatically doesn't mean from scratch. Angular offers us a lot of tools to quickly create such a form. So I want to store it in a property which you may give any name you like. I'll name it signup_form. And important, this will be of type form group. Now I could auto import it, but since it's important to understand, I'm going to import it manually this time. Form group needs to be imported from @AngularForms. This is the forms package, as the name says, and it contains a lot of classes we will work with. In the template-driven approach, we already imported ngForm from it. Now, ngForm was this automatically created wrapper, you could say. But it was wrapping a form group in the end, because in Angular, a form in the end is just a group of controls. And this is what a form group holds. Therefore, the overall form also is just a form group. Now this is all. We don't need to set an initial value for now. This gives us a property with which we can work, which will hold our form in the end. Now important, for the reactive approach to work, especially later when we connect our programmatically created form to our HTML code, you need to import something in app module. You don't need the forms module. This is required for the template-driven approach. Instead, you need the reactive forms module. Make sure to also import it up here from @AngularForms. So reactive forms module, this is the module containing all the tools we need now to build our form on our own and then connect it to our HTML code. So back in the template, in the next video, we're going to create the actual form. So we set everything up in the last lecture. Now let's create our form. Now we could initialize it right here to set a value immediately, but I don't like to do this here. I want to have it in a method because it actually is quite a lot of code and it's not the best place to have it right here at the top in the property declaration area. So I will use the onInit lifecycle hook for this. So we'll import onInit, make sure to import it from @AngularCore. And therefore I'm required to implement the onInit method, and in here I will initialize my form. You should initialize it before rendering the template, of course, so make sure to use a lifecycle hook which is called before the template is rendered. Here I will set up my signup form and we'll set it equal to what? Well, keep in mind, signup form is of type form group, so we need to create a new form group here, just like this. Now we have almost a valid form. We need to pass a JavaScript object here and we're theoretically done. This is our first created form. This JavaScript object configures it, and as it's empty, it simply says, or it tells Angular, hey, this form doesn't have any controls. So let's add some. Controls are basically just key value pairs in this object we pass to the overall form group. So let's have a look at our HTML code. We have a username field and an email field, and then we got the radio buttons here at the bottom. So it would make sense to have a username control. I'm wrapping this in quotation marks to make sure that during minification, when this code gets mangled, this property name is kept because I will reference it in the HTML code. This might not be necessary, it might not get destroyed, but just to be sure, I'm wrapping it as a string. So here, what is this now? Well, this is a form control, another class made available by the reactive forms module, or by this forms package here, I should say. So I will set up or create a new form control here, and form control should also be added from the forms package from @AngularForms. Now to this form control constructor, we can pass a couple of arguments. The first argument is the initial state, the initial value of this control, you could say. The second argument will be a single validator or an array of validators we want to apply to this control. I'll come back to this. The third argument will be potential asynchronous validators. I will also come back to this later. For now, I want to set an initial state of null to have an empty field. But you could also pass a string like default username, and now this would later be displayed as a default username. Again, I'll keep it at null for now. Now, have a look at the template again. The next field is the email. So I'm going to add another control, another key value pair in this JavaScript object, which will also be a new form control. And here I will also set a default value of null. Again, validation will be added later. Now, gender, this is the gender the user selects, is also a new form control. It might be a radio button, but that is just a normal input in the end. So to Angular, it simply is a control. And here I could set this to null, but I want to select a default gender. So here I will actually select male because that's my gender. Feel free to pick female, of course, or add more genders to this array of genders up here to begin with. With this, a basic form is initialized. It has 3 controls, and that is all for now. This is our first basic form. Now in the next lecture, we're going to connect this form we created here in TypeScript to our form we have set up in the HTML code. In the last lecture, we created our form here in TypeScript. The issue is, it's nice to have it here, but our actual form, you could say, lives in the HTML template. So we somehow need to synchronize our HTML inputs and our own form, or this form in general with our own form. Right now, Angular doesn't know which of our TypeScript controls here relates to which input in our template code. It actually doesn't even know that our form, sign-up form here, should be attached to this form. Right now, the one thing it is doing is, it is auto-detecting that this is a form and it creates a form for us. Now, we don't want it to do that. So we have to add some directives to override this default behavior to give Angular different instructions. For these directives to work, you definitely need to make sure that you add the import to reactive forms module in your app module, otherwise you will get errors. Now, the first directive we need to add is here on the form itself, via property binding, the form group directive. Now this simply tells Angular, hey, please take my form group. Don't infer one, don't create a form for me, use my form group. And we need to set up property binding here because we need to pass our form as an argument to the directive. So here we should reference our sign-up form, the property we created here, which stores our form. We're passing this via property binding to the form group, and now this form is actually synchronized with the form we created in TypeScript. But we still need to tell Angular which controls should be connected to which inputs in the template code. For this, we get another directive. On this input here, for example, the username, we add the form control name directive to tell Angular, hey, what's the name of this input in my form, in my TypeScript form? Well, the name is username, this name here, because that's the control I want to connect to this input. So I simply pass username here. If you're wondering why I'm not using property binding, I'm passing a string here. So if you want to use property binding, you can do this by wrapping this in squared brackets and then enclosing username in single quotation marks. Otherwise, it would search for a property named username. But this is overly complicated. If you just want to pass a string, simply omit these squared brackets and you're good to go. So with this, we're telling Angular, hey, my form should be connected to the form stored in the sign-up form property. And in this form, this input here should be connected to the control with the name username. Well, now I can simply repeat this for the email. Here the name was email, the name we set up here. Now this control is connected. And for the gender, of course. So on this input here, I will bind this to gender. Now with this, let's save this so that it compiles. And now let's have a look at it. We don't see any errors, which looks good. We see that male is pre-selected, looks promising because that was the default value we set when we created the control in TypeScript. And if I now switch to female, only one of the two is selected. We also see that if we select email here, that the Angular classes are attached, untouched, pristine, valid, and so on. So it indeed looks like our inputs in HTML are correctly synchronized to our form we created in TypeScript. So this was successful. The next step is to actually submit the form to see how this works. In the last lecture, we successfully synchronized our HTML form and our TypeScript form. Let's now have a look at how we can submit this form. In the template-driven approach, we used ng-submit, the ng-submit directive here on this form element. Well, we still do the same here, because we still want to react to this default submit event which is fired by HTML, by JavaScript. So we still add ng-submit here, and we could execute our onSubmit method, any method you like. So let's add this method here now, onSubmit. The difference to the template-driven approach now is that we don't need to get the form via this local reference. That actually wouldn't work anymore because we're not using Angular's auto creation mechanism. But we don't need to get this reference because, hey, we created the form on our own. We already got access to it here in our TypeScript code, actually in every method in the TypeScript code. So we can simply console log this sign up form, just like this. And this is how we get access to the form. Now, if we go back to our running project and we simply enter something here, switch this to female to see if it is correctly updated, and hit submit, we see our form group here. And it has the properties we already know, amongst them the value, which correctly represents the object we passed here. Key value pairs with username, email, and gender, and the appropriate values. This is the cool thing about the reactive approach. Whatever you set up here as an argument, whatever you set up here as an object you pass to the form group which makes up your form, that is what you get out as a value of the form. So you can bind it to your own model, the model of your application, and easily make sure that the form structure matches the structure of your model. So this is how you can submit the form, how you can still access the value as you did before, but now using your own form, the form you created in TypeScript. Now that we're able to submit a form, let's actually add some validation to it. In the template-driven approach, we would simply add required here, for example, to make this field required. It doesn't work like this in the reactive approach, because keep in mind, and that's key, you're not configuring the form in the template. You're only synchronizing it with the directives, form control name and form group, but you're not configuring it here. The TypeScript code, that is where you configure it. That is why form control takes more than one argument, this constructor here. You can not only set the default value, the second argument allows you to specify some validators. So you can either only pass one validator here, like for username, where I only want to make sure that it is required. And you do this by adding the validators object, make sure to import it from @AngularForms. And there you get a couple of built-in validators you can use, for example, required. Now make sure to not call it, to not execute it, so don't have parentheses after it, because you don't want to execute this method. It is a static method made available by validators here. Instead, you only want to pass the reference to this method. Angular will execute the method whenever it detects that the input of this form control changed. So it just needs to have a reference on what it should execute at this point of time. So this is the required validator, but as I said, this is only one option. You can also add multiple validators by simply passing an array of validators. So here to email, I'm going to pass an array of validators because I want to have the required validator, just like on the username, but I'll add another validator too here. I'll add the email validator. And this again also doesn't need to get executed, we just need the reference. So here I now also passed my validator, and now we do have validation in place. If we now go back to our form and we inspect and let it reload and we inspect the email field here, for example, it's invalid. If I enter something here, it's still invalid. If I enter an email address though, it becomes valid. And the same of course for username, it's invalid right now. As soon as I enter something, it becomes valid because it's now not empty anymore. So this is how you can add validation to this approach. So in the last lectures, we added validation. Now, as in a template-driven approach, we can now use this form status to display messages. But it works a bit differently because we access the controls differently. Let's say we want to display a message below the input here for the username, if that is incorrect. So I'll add a span with a class of help block, again that bootstrap class, and I'll say please enter a valid username. Like this. Now in a template-driven approach, we would place username on this and say ngModel to get the reference. This doesn't work here because again, this is not set up via ngModel. This is not registered via ngModel. But it's still very easy. We can simply add ngIf, of course, because we want to determine whether to display this or not. And then we can get access to this by accessing our overall form. And here we have a get method. The get method allows us to get access to our controls easily. Here, you can either specify the control name, or I will come back to this later, the path to the control. Now for now, the path is the name because we only have one level of nesting in our form object. And here, the name is username. So this gives us access to this username control. And now valid holds whether this control is valid or not. So if it is not valid, I want to output this. And of course, again, to give the user the chance to change it, I will also check if sign up form get username actually was touched. So by adding this, we should see no messages displayed. If I click in there and click out of there, we see the error. And if I enter something valid, it's gone again. So this is how easy you can get access to a control in your form with this get helper method. Now I will repeat this for the email here. So below the input here, I will simply exchange username for email. And I will do it for the overall form. Here I can simply remove this get access here and just execute valid and touched on the overall form, which of course also has these properties. So please enter valid data, might be the right message here, and up here for the email it should be please enter a valid email. So with this in place, we should see nothing right now. If I click in here and out of there, we see the message for the username as before and for the overall form, which is still there because email is invalid. But now if I enter something valid there, we don't see it. If I remove this, we see the message for the field here and for the overall form again. So now we're using the form state again. And of course, keep in mind, these CSS classes, ngTouched, ngInvalid, are still added. So you can still go to your CSS code and say I input with ngInvalid and ngTouched should still receive a border which is red, for example. So that is still possible. The classes are the same as in the template-driven approach. So now if I click in there and leave it, you see it now has a red border, which disappears as soon as the value becomes valid. So this is how you can still use the form state. Important takeaway, you access your elements differently with this get helper method to conveniently get access to them. In the last lecture, I was already mentioning that get also takes the path to an element. What did I mean with that? It's very simple. You can specify a path here because you might have a nested form. Let's say username and email should be inside a form group. We used such forms in the template-driven approach too. So here we could create a form group named user data. And now this is a new form group again. Form group is not only there to be used on the overall form, that just happens to be a form group too. but you can still have form groups in form groups. So here we could have a form group, which of course, like the outer form group for the overall form, also takes a JavaScript object. And now we can add our form controls inside of this group. So now we have a nested form. We need to reflect this in our HTML template because right now, if we have a look at our form, it will break. You see this in the console. We get an error because correctly it cannot find a control with the name username. Because on the overall form, there is no such control. It's nested in the user data form group. So first of all, we need to update our synchronization. And we easily do this by wrapping our form controls here in another element, like a div, for example. So the email and username would be the two controls we wrap in there to replicate the structure we have in the TypeScript object. And on this div, we place the form group name directive. So you kind of could see the schema here. Form control name to tell Angular which property in our TypeScript object representing the form relates to which input, and form group name to tell it the same for a form group. So depending on whether you have new form group or new form control here. So here the form group name is user data with a capital D. And now with this tiny addition, I don't need to change anything else. It's almost working again, but we still get this error here, or a different error, but still related to the topic, that valid cannot be read on null. Well, that makes sense because get username still fails. Because what are we trying to do here? We try to get a form control with the name username on our sign-up form. We don't have that here. We have it nested in user data, but that's not the same. So we need to update get to point to the path or to contain the path to the username. And that would be userdata.username. And it's as simple as this. You structure your path separated with dots. So if you have a new object, just place a dot in between. So let's paste it everywhere where we used one of these nested controls for email as well, therefore. And if we now save this, it should update and not display any errors anymore. Instead, we should see the behavior we saw before with the messages we get if we enter invalid data, because now the form is working again, taking into account form groups, so nesting inside of our form now. And as you saw, it was really easy to reflect this in our HTML code. It's all about keeping that in sync in the end. We covered a lot about the reactive approach. There's one other nice feature I want to show you though. Let's add a new area to our form, maybe below the radio buttons here. Here I want to add a new div, and in this div I want to allow the user to dynamically add form controls. Let's say I want to allow the user to add his hobbies. So your hobbies, something like that. Then I'll add a button with some bootstrap classes button and then maybe button default. Make it of type button, that's important, so that this button doesn't accidentally submit the whole form. And here I'll say add hobby. Now when the user clicks the button, I want to dynamically add a control to my form here. And that's actually super simple to do. Specifically, I want to add this control to an array of controls because I might have multiple hobbies. So I'll add a click listener here on add hobby. Seems like an appropriate name for this method here. And in there again, I want to add controls. So I'll add the method in my TypeScript code on add hobby like this. And now I need to add a new control, type of control to my overall form. I'll name it hobbies because that is what I'll store in there in the end. And as I said, this should be an array because it could be no hobbies or 10 or 100. So the type here is not form control and it is not form group. Instead, it's a form array. Make sure to import this from @AngularForms as well. Now, a form array, of course, holds an array of controls. So you pass an array here to initialize it. In this array, you could already initialize some form controls with new form control, or like I'm doing it here, you leave it empty to not have any hobbies at the beginning. Now, when we click on add hobby, I want to add a new hobby to that array. So here I need to access my form. Now I want to get access to my hobbies array, and I can do this by getting hobbies. It is a control in my overall form in the end. And now I need to tell TypeScript that this is of type form array to not get an error. You rarely have to do this, but here we have to explicitly cast this. So by placing a lower than sign, then form array, so the type, and then a greater than sign, and then placing this in parentheses, we're telling TypeScript this part here actually is a form array, so everything enclosed in these outer parentheses now is treated as form array. So now I can push a new control on this array. If we would have not casted this, we would get an error. So now we can push a new form control there, but I will outsource this to keep this line short. So here the control is created and stored in a constant, form control. And the hobby, well, that should be something the user can now enter. So we'll actually create it with no default value. Of course, you could also change this behavior to pass an argument to onAddHobby and then pre-populate it with this value. I want to add a validator though, so this still works because I'm creating a normal form control here. So the required validator seems appropriate because the hobby input should not be empty. And now I can push this control on my array of controls. With this, we are able to add controls, but we won't see it. We need to synchronize it with our HTML code. Therefore, on this outer div here, I'll add a directive form array name. So again, you see the pattern. We had form control name to tell Angular that we want to connect the input to a form control. We had form group name to do the same for a form group. And now we have form array name to do the same for an array. So form array name, and the name was hobbies, the name we chose in our TypeScript object. This tells Angular that somewhere in this div our array will live. Now we can use this array here. So I will create a new div with the ID form group for some bootstrap styling. And here I simply want to have an input which allows the user to enter the actual hobby. So this type text is all right. I now somehow need to loop through all the controls which are in this array. So on my form group here, I will actually add an ng for loop to loop through all my hobby controls. So in my sign up form, that would be my hobbies, which I can get like this, and they're the controls. With that, I can loop through all them, and I also want to extract the index of the current iteration. I will need this to assign this input to one of these dynamically created controls. Because on this input, I of course want to add the form control CSS class, but besides this, very important, I need to add form control name because we still need to synchronize this input with the dynamically created input. Now this dynamically created input will not have a name chosen by us, but it is in an array. So the name will simply be the index in this array, which is why I'm retrieving it here. So I can simply bind form control name, and now I will need property binding because I'm now not passing a string, I'm instead passing this local variable I'm creating here, I, to pass this index. Let's save this and see if this works as expected. If we have a look at our console, no errors. Let's click add hobby, and we indeed see a new input, no errors still. Let's check it. It's invalid, this looks good. So if I enter a hobby here, now it becomes valid. And now if I enter the rest here and go to the console and hit submit, you will see that in the value of this form, we actually now have hobbies, which is an array where we have cooking, and of course, we could also add sports, and in this newly submitted form, you would now find that this array of course holds cooking and sports. So this is how you can use a form array with the reactive approach very easily. It's all about synchronizing it in the end and about knowing that you have to explicitly cast it to make this work. So in the last lectures, we learned a lot about the creation and configuration and usage of our own forms. Now let's use another cool feature we can easily implement when using the reactive approach, adding our own validators. Thus far, we always use the built-in ones, and to be honest, with all the built-in ones, you should be able to cover most of your use cases. But let's say we have some usernames you don't want to allow the user to use. In this case, I'll go to my TypeScript file, and here I'll add a new property, forbidden usernames, for example. And in this array, I'll add Chris and Anna as forbidden usernames, if written like this. So now I want to create my own validator, which checks whether the username the user entered is one of the two usernames specified here. Now, a new validator can be added pretty easily. A validator, in the end, is just a function which gets executed by Angular automatically when it checks the validity of the form control, and it checks that validity whenever you change that control. So a validator is just a function. Let's name it forbidden names. Now, a validator, to work correctly, needs to receive an argument which is the control it should check. So this will be of type form control. A validator also needs to return something for Angular to be able to handle the return value correctly. This something should be a JavaScript object, and now the following notation might look strange. It should have any key, which can be interpreted as a string. And this is just TypeScript syntax for saying, hey, we want to have a key value pair where the key, again, can be interpreted as a string, which is true for a key in an object in general. More importantly, the value of that key value pair, that should be a Boolean. So this function here should return something like, let's say, an object where we have name is forbidden. This would be the key name, which is interpreted as a string, and it could be true. So this is what this function should return in the end, for example. The message itself, the key name, is up to us. And therefore, we can now add the logic in this function. In our case here, I want to check if the value of the control is part of this forbidden usernames array. So I want to check if this forbidden usernames index of, so if it contains a certain element, and the element is the value of our control we pass here, the control we're checking. If this is the case, I want to return an object where I say name is forbidden, any short error code you want is true. Now in the other case, I want to return null. And now this is important. If validation is successful, you have to pass nothing or null. You should not pass this object with false. This might sound counterintuitive, but that's just how it works. It should be null or you simply omit the return statement. This is how you tell Angular that the form control is valid. Well, and this is all. We created our own form validator or own validator here. Important, it receives the control and it returns this object with an error code and then true, for example, if it is invalid. So now to add this, I will go to my username, and actually we now want to assign an array of validators. So I'll change this appropriately. And I'll now add a reference to my forbidden names function. Again, don't execute it, only pass a reference. And now if we save this, we get an error. Now this can be a tough one to spot. What's going wrong here? This error has something to do with the way JavaScript handles this. In forbidden names, I'm accessing this here. Now this might look alright because I'm in this class and I access this forbidden usernames. But think about who is calling these forbidden names. We're not calling it from inside this class. Angular will call it when it checks the validity. At this point of time, this will not refer to our class here. So to fix this, I actually need to bind this. The good old JavaScript trick to make sure that this refers to what we want it to refer to. So with this in place, if we now let this recompile, the error is gone. Let's now check the validity of this input here. It is invalid, but if I enter test here, it stays invalid. The reason for this is that right now I'm checking if control value is part of this array. This will return -1 if it is not part. Well, -1 is interpreted as true though. So we need to check if this is not equal to -1. So if this is not equal to -1, that means we did find it, that means it is invalid. So now with this in place, if we go back, inspect this again, and type test here, you see it becomes valid. If I type Anna here, it becomes invalid. So our own validation here is working fine. Now in the next lecture, I will have a look at this strange error code and how we can use that. In the last lecture, we added our own validator and we saw this strange error code. Let's see what it is up with this error code. So right now, this form is invalid. This field is invalid and the overall form is invalid. I can still submit it though because I haven't disabled the button. So if we have a look at this, we see the errors property on our form. If we open this, it's null though. The interesting part is if we have a look at our controls here, for example, user data and then there on the controls, the username. Here, if we have a look at the errors, you see the name is forbidden, true key value pair. So this is where Angular actually adds the error codes on the individual controls on the errors object. So we could take advantage of this by going back to the HTML code and fine-tuning this error message. Let's say we want to say the username is required if the field is empty, and we want to say this is an invalid username if it is invalid. So we could say this field is required here. Our current check will not suffice though, because here we only check if it's valid in general. So here we could simply wrap another span in there and check if sign up form get user data username errors. If this has the name is forbidden error. If it does have this, I want to say this name is invalid. I'll also add another span. And here we need to find out what the actual message is if the field is required. So I'll enter the text here for now, but then we need to check what the error message would be. So let's quickly submit this form here and check on our controls, user data, and there on the controls, the username, and there again, the errors. We see here the code would just be required, so we can now check if it contains the required error. With that in place, if I now click in here and out of there, we see the field is required. If I type Anna in there, we see the name is invalid. And if we type something valid, we don't see anything. So this is how we can use these error codes. And of course, you could also use ng switch here or any other setup. The key thing is to understand that these error codes can be used to show the right error messages. And of course, you can come up with even more complex setups where you have TypeScript objects in your TypeScript code, where you map error codes to specific messages and dynamically output that here. This is the basic example, the basic way of using these codes. In the last lecture, we saw how we can use these error codes, and we also saw that we can add our own validator. We checked if the name is invalid, the username. But typically, you might need to reach out to a web server to check this. That, however, is an asynchronous operation because the response is not coming back instantly. Instead, it just takes a couple of seconds. So we also kind of need asynchronous validators, which are able to wait for a response before, well, returning true or false, is it valid or not. Turns out we can create such asynchronous validators. So let's create one here in the app component. I'll name it forbidden emails. This asynchronous validator also takes the control as an argument. Now we also need to return something here, but this will not be an object with an error code and a boolean. Instead, this will be a promise, which wraps anything, or an observable, which wraps anything. For the observable, you need to import it from rxjs/observable. And these are, of course, two constructs which handle asynchronous data. That's exactly what this validator is about. So here, I now want to create a promise in this validator, a new promise it will be, which returns us anything. And as all promises, this receives a function with resolve and reject as arguments we can execute in that function. And in that function, I now want to set a timeout. After 1.5 seconds, I want to return a response to simulate the fact that we have an asynchronous task like reaching out to a server. So this will be the function which gets executed after 1.5 seconds, this anonymous function here. And here I will simply check if control value equals test@test.com. Of course, we could also check if it's part of an array. I will simply check for this single email address. If this is the case, validation failed. And as in the synchronous validator case, this is when I will return an object with a key value pair with this error code. Here, of course, since we are in a promise, I don't return, I resolve. And again, I resolve this object where I say email is forbidden, like this, set this to true. And if we pass this check here, so in the else case that we have a valid input, that we have a valid email address, I will simply resolve null. Now, of course, we need to return this promise in the end. So with this, we set up our asynchronous validator. Now we can add it. Let's add it to the email. And here you don't add it in this array of normal validators. Instead, we use the third argument we can pass to form control. This is an asynchronous validator or an array of such validators, just like the normal validators, but reserved for the asynchronous ones. So here I will use my forbidden emails validator. Again, don't execute it, simply pass the reference. And you need to bind this if you plan on using this in there. I don't, so I don't need to do it here. Now let's check if it works. If we compile this and we inspect the email, it's invalid. If I enter something here, you see it stays invalid. If I enter test2, closely watch ng invalid. Did you see that? It changed to ng pending because it was evaluating the input. Then it changed to ng valid. Now if I remove the 2, and therefore I will enter an invalid email address because that's the one we're checking for, it again switches to pending and then to invalid. So this is now how the asynchronous validator works, and of course this would work with code where you reach out to the web, for example, and we correctly therefore of course see our error message. So these are asynchronous validators, really easy to add when using the reactive approach, as you saw. We're almost done with this section. We worked a lot with reactive forms now, and in the last lecture at the end of it with the asynchronous validator, you saw that the status of this input switched from invalid to pending to valid, for example. There actually is a form state you can track in general. I'll do this here in ng on init. On my signup form and on each control of this form, so on get any control to, you have two observables you can listen to. Status changes and value changes. So let's listen to value changes. As mentioned, this is an observable, so we can subscribe to it. And as the first argument, we pass the callback, which is executed when new data arrives. So this will be the value, because we're listening to value changes. And we can log the value here. So if we do this, have a look at our form. If I type something here, you see with every keystroke, the object here is printed, the value of the form actually. This makes sense because value changes is fired whenever we change something about the form. So whenever we type into any input. So this is value changes. And again, you can also call this on an individual form control. I'm going to copy this and then comment it out because we also have status changes. So here we receive the status now. Let's view this. Here, if I type something, you see invalid, because the form is invalid. If I type something in here where we have an asynchronous validator, you see it switched to pending and then after 1.5 seconds to valid. So status changes and value changes. Two nice hooks, observables, you can listen to or you can subscribe to if you really want to closely watch what happens in your form or again on an individual control and want to react to that. Not only can you listen to the updates in your form, you can also update the form on your own. Just like in the template-driven approach, set value and patch value are there for you. I will quickly show it here. You can, of course, on your form as a whole, call set value and pass a JavaScript object which should now resemble the object structure up here when you create the form. So where you have your user data, which then is an object, where you have your username and set this equal to max, for example. Have your email, set this equal to max@test.com. Have your gender, male, and of course your hobbies, potentially an empty array. So if we do this, we should see that now our form is pre-populated with some values because we immediately call set value. And of course, you can also call this upon the click of a button. And as in the template-driven approach, you also have patch value, of course, if you only want to update a part of the form, like for example, the username, switch this to Anna. Now you should see that the username is changed to Anna. The rest still contains the values I set with set value. So just to bring this to your attention, patch value and set value are also available. And the same is true for resetting. So if you want to reset the form after submitting it, we can simply call reset here. So let's quickly do this and hit submit. Now it's gone. So this empties our form. Now with that, you should have the tools to work with the form, to configure it to your needs, and to really build powerful forms. Time to practice this in the next assignment. Time to practice the reactive forms. Here's a little assignment I prepared for you. I want you to create a form, again, which has these inputs. A project name input, a mail input, and the project status input, where the project status should be a drop-down with 3 potential values: stable, critical, or finished. Now, of course, creating the form means creating it in TypeScript and then connecting it to the HTML template here. Also add a submit button, and thereafter I want you to add your own validator, which checks if the project name is test, which isn't allowed. Thereafter, implement that same validator as an asynchronous validator, replace the old one, and generally, when the form gets submitted, simply print it to the console or display it on the template if you want to do this. The main thing about it is, of course, about building that form. So, I wish you fun with that. In the next video, we're going to see my solution. Were you successful with that form? Let's build it together. As in the template-driven assignment, I will do it right below the instructions here, and I will start by adding the form element here. And generally, I will start by creating it in my HTML code here, though that will not create the form for Angular, because we will later set it up in TypeScript and then connect it to our template code here. So, as before, I'll add a form group div with a label for the name, so project name would be a fitting description. And I'll add an input, type text sounds alright, ID name sounds alright. I'll split it up over multiple lines already since we're going to add some things, and add a class of form control. This is the first input. I'm going to duplicate this because now I want to add the email of the person who created this project, you could say. So let's simply set up the mail input here, make it of type email maybe. And I want to add that dropdown. So let's add another form group. And in there, select dropdown. We don't need the name actually. We need a label though, where we set the status. So project status would be a fitting description, I guess. Set the ID to status therefore, and in the select we need our options. Now you could use an array to dynamically populate them or hard code them in there. I will go with the hard coded approach here, though you will typically probably have the dynamic one. The first value would be, as you see up here, stable. So say stable here, and thereafter we also have critical with a display value of critical, and finished where we display finished. So this would be our dropdown. I also want to add the form control class to that and split it over multiple lines. Then I'll add the button at the end of the form with the classes button and button primary, make it of type submit, and simply say create project maybe to mix it up. So this is the general setup. ngserve is already running, looks alright to me. Stable is selected by default because it's the first element we added here. Now let's create this form in TypeScript. So in my app component here, I'll name it project form and it will be of type form group. Make sure to import this from @AngularForms. What else did we learn? We need to unlock all the reactive form directives by going to app module, and we don't need forms module, we need reactive forms module. So make sure to import that from @AngularForms and add it to the imports array here. With that added, we will later be able to synchronize it. For now, let's create this form, and I'll again do this in ng-on-init. So I'll add the on-init lifecycle hook and import it from @AngularCore. ng-on-init gets added here. And then I will set my project form equal to a new form group, because again, the outer form is just a form group, where I will pass a JavaScript object to configure it. Now here I want to have, let's say, a project name control, so a new form control therefore, with a default value of null. I don't want to pre-populate it. And for now I will only add the validator, which requires it to be not empty. Make sure to import validators from @AngularForms, because that's the first requirement. It should not be empty. Now for mail, I'm going to duplicate this and set up my email control. It's also null, but it has more than one validator. It does have the required validator, but then it has the email validator. Again, don't execute these methods. You only want to pass the reference to the methods. Well, the final control is this dropdown here with stable, critical, and finished. So I'll add yet another control. Now here I will name this project status. Form control here, I will set a different default value. It would make sense to have stable as the default value, but that's selected automatically. I want to change this, so I will set it to critical. This is the value we need to assign with a lowercase c at the beginning, because that's the behind the scenes value HTML knows. So let's pass a string with critical here. And well, we don't need any validators because we can't unselect it anyways. This is our form. Of course, feel free to also nest this to add a form group if you want. This would be an extra challenge. Now, this is the basic setup where all is on the same level in this form. With this form created, we need to synchronize it with our HTML code. Again, just because it's important. For this, you will need reactive forms module. And then I can go to my form here and with property binding, bind form group to my project form, to this form we just created. Now let's also connect the inputs, like here, with form control name, of course, to tell Angular which name does our control have in a form, in our form. Here it's project name for this first input, so I'll pass this here. For the email, it will just be email. And for the dropdown, if we have a look at our TypeScript code, it was project status. So I will pass project status here. Now our form is connected. I will now also add ng-submit to submit it and call onSaveProject maybe, and create this method now in my TypeScript file here, in the app component TypeScript file. And here I simply want to log this project form value because I'm only interested in the value. So ng-serve is still running as mentioned before. It's recompiling. This looks good, no errors. Let's enter something here and let's hit create project. And we see the value looks good. Looks like we successfully connected it. Now if we have a look at our instructions here in the HTML code, we finished this part. We created the form, we added the controls, and we set up this basic validation. Now we are required to create our own validator, which doesn't allow test as a project name. Well, we saw how to do this, and we could do this here in the same file as we did before, but to mix it up and show you that you can also create your own validators bundle, kind of, I will create a new file here in my app folder, and I will name it custom validators.ts. And in there, I will export a class, which I'll name custom validators. Now, you probably don't have that solution, which is absolutely fine. It's just that I want to also show you an alternative. I want you to learn something when looking at my solution too, even if you did have a perfect solution before. So this is just an alternative, not strictly better, just an alternative. In my custom validators class here, I want to have a static function which I'll name invalid project name. Now, for such a specific validator, having a global bundle of validators might not make very much sense, but I guess you can imagine projects, apps, where you do have such a global repository of validators. In the end, we're using the built-in repository of validators here too. Now we're creating our own ones. So invalid project name will receive a form control here as input. Make sure to import it in this TypeScript file too, because we're using the type here, so we need to tell TypeScript where this is coming from. And we will return an object where we again have a key value pair, where we have a key which represents our error code, and then a boolean. And now I simply want to check if control value equals test. And if this is the case, I will return an object where I say invalid project name is true, like this. Otherwise, I will return null. So with this, I created my own static method. Static is important so that we can access it without having to instantiate our own class here. Now back in our app component, we can assign this by going to the project name, wrapping this required validator in an array because we're now going to add multiple validators. And in here, I now want to reference my custom validators class, which I therefore need to import at the top from /custom validators. And in there, the invalid project name function, which we don't execute as before. And as a side note, if you use this in there, make sure to bind it again, even if that were placed in the app component TypeScript file, because it will be executed by Angular at runtime, and then this will not refer to what it refers to during development, in this case here. So this allows me to save it. Let's now check the validity. If we inspect this input here, it's invalid because it's empty. If I enter something, it's valid. If I enter test, it becomes invalid again, so our own validator works. Again, it would have been perfectly fine if you would have added this to your app component. Let's now add an asynchronous validator. So here, I will implement the same with async in front of it to make clear what the difference is. And I'll then also name it invalid project name. Of course, you could also create this in the app component file. We will receive the form control here, and we will return either a promise of type any or an observable of type any. An observable needs to be imported from rxjs/observable. With this in here, I again will create a promise I will return. So a new promise, which will receive a function as an argument to the constructor. This function will receive resolve and reject. And then I will execute a timeout in there. Let's say after 2 seconds, I want to execute this function here, this anonymous function, where I will again check if the control value equals test. So as in the synchronous validator, but now asynchronously. If this is the case, I will resolve this exact same error code here actually. So like this. Otherwise, I will resolve null. So we should resolve null if it is valid. Well, and then I can return the promise here. Now with that, we can attach this validator. So besides our custom invalid project name here, let's actually change this to test project so that we do have 2 different values to check for. So I can leave the old validator on there and attach my asynchronous validator as a third argument to form control. Here I will also reach out to my custom validators and then the async invalid project name. Again, don't execute it, only pass the reference. And I will simply split this over multiple lines to be in line with the requirements of TS-lint here. So, like that. So with that, we configured this form control, null default value, 2 validators, one of them our own validator, and the asynchronous validator checking for the test project name. With that, let's save this and therefore reload this project and now inspect our project name. It's invalid. If I enter test there, it's also invalid. If I enter test per, it's pending and valid. If I enter test project, it's pending and invalid. So our own asynchronous validator is working too. And with that, we practiced some of the things you learned in the last lectures of this course. Again, feel free to play around with that, build much more complex forms. And in the next course module, we're actually going to apply some of the knowledge we gained in our course project in the recipe book. See you there. Were you successful with that form? Let's build it together. As in the template-driven assignment, I will do it right below the instructions here, and I will start by adding the form element here. And generally, I will start by creating it in my HTML code here, though that will not create the form for Angular, because we will later set it up in TypeScript and then connect it to our template code here. So, as before, I'll add a form group div with a label for the name, so project name would be a fitting description. And I'll add an input, type text sounds all right, ID name sounds all right. I'll split it up over multiple lines already since we're going to add some things, and add a class of form control. This is the first input. I'm going to duplicate this because now I want to add the email of the person who created this project, you could say. So let's simply set up the mail input here, make it of type email maybe. And I want to add that dropdown. So let's add another form group. And in there, select dropdown. We don't need the name actually. We need a label though, where we set the status. So project status would be a fitting description, I guess. Set the ID to status therefore. And in the select, we need our options. Now you could use an array to dynamically populate them or hard code them in there. I will go with the hard-coded approach here, though you will typically probably have the dynamic one. The first value would be, as you see up here, stable. So say stable here. And thereafter we also have critical with a display value of critical, and finished where we display finished. So this would be our dropdown. I also want to add the form control class to that and split it over multiple lines. Then I'll add the button at the end of the form with the classes button and button primary, make it of type submit, and simply say create project maybe to mix it up. So this is the general setup. ngserve is already running. Looks all right to me. Stable is selected by default because it's the first element we added here. Now let's create this form in TypeScript. So in my app component here, I'll name it project form and it will be of type form group. Make sure to import this from @AngularForms. What else did we learn? We need to unlock all the reactive form directives by going to app module, and we don't need forms module, we need reactive forms module. So make sure to import that from @AngularForms and add it to the imports array here. With that added, we will later be able to synchronize it. For now, let's create this form, and I'll again do this in ng-on-init. So I'll add the on-init lifecycle hook and import it from @AngularCore. ng-on-init gets added here. And then I will set my project form equal to a new form group, because again, the outer form is just a form group, where I will pass a JavaScript object to configure it. Now here I want to have, let's say, a project name control, so a new form control therefore, with a default value of null. I don't want to pre-populate it. And for now I will only add the validator, which requires it to be not empty. Make sure to import validators from @AngularForms, because that's the first requirement. It should not be empty. Now for mail, I'm going to duplicate this and set up my email control. It's also null, but it has more than one validator. It does have the required validator, but then it has the email validator. Again, don't execute these methods. You only want to pass the reference to the methods. Well, the final control is this dropdown here with stable, critical, and finished. So I'll add yet another control. Now here I will name this project status. Form control here I will set a different default value. It would make sense to have stable as the default value, but that's selected automatically. I want to change this, so I will set it to critical. This is the value we need to assign with a lowercase c at the beginning, because that's the behind the scenes value HTML knows. So let's pass a string with critical here. And well, we don't need any validators because we can't unselect it anyways. This is our form. Of course, feel free to also nest this to add a form group if you want. This would be an extra challenge. Now, this is the basic setup where all is on the same level in this form. With this form created, we need to synchronize it with our HTML code. Again, just because it's important. For this, you will need reactive forms module. And then I can go to my form here, and with property binding, bind form group to my project form, to this form we just created. Now let's also connect the inputs, like here, with form control name, of course, to tell Angular which name does our control have in a form, in our form. Here it's project name for this first input, so I'll pass this here. For the email, it will just be email. And for the dropdown, if we have a look at our TypeScript code, it was project status. So I will pass project status here. Now our form is connected. I will now also add ng-submit to submit it and call onSaveProject maybe, and create this method now in my TypeScript file here, in the app component TypeScript file. And here I simply want to log this project form value because I'm only interested in the value. So ng-serve is still running as mentioned before. It's recompiling. This looks good, no errors. Let's enter something here and let's hit create project. And we see the value looks good. Looks like we successfully connected it. Now if we have a look at our instructions here in the HTML code, we finished this part. We created the form, we added the controls, and we set up this basic validation. Now we are required to create our own validator, which doesn't allow test as a project name. Well, we saw how to do this, and we could do this here in the same file as we did before, but to mix it up and show you that you can also create your own validators bundle, kind of, I will create a new file here in my app folder, and I will name it custom validators.ts. And in there I will export a class which I'll name custom validators. Now you probably don't have that solution, which is absolutely fine. It's just that I want to also show you an alternative. I want you to learn something when looking at my solution too, even if you did have a perfect solution before. So this is just an alternative, not strictly better, just an alternative. In my custom validators class here, I want to have a static function which I'll name invalidProjectName. Now for such a specific validator, having a global bundle of validators might not make very much sense, but I guess you can imagine projects, apps, where you do have such a global repository of validators. In the end, we're using the built-in repository of validators here too. Now we're creating our own ones. So invalidProjectName will receive a form control here as input. Make sure to import it in this TypeScript file too, because we're using the type here, so we need to tell TypeScript where this is coming from. And we will return an object where we again have a key value pair, where we have a key which represents our error code and then a boolean. And now I simply want to check if control value equals test. And if this is the case, I will return an object where I say invalid project name is true, like this. Otherwise, I will return null. So with this, I created my own static method. Static is important so that we can access it without having to instantiate our own class here. Now back in our app component, we can assign this by going to the project name, wrapping this required validator in an array, because we're now going to add multiple validators. And in here, I now want to reference my custom validators class, which I therefore need to import at the top from /custom validators. And in there, the invalid project name function, which we don't execute as before. And as a side note, if you use this in there, make sure to bind it again, even if that were placed in the app component TypeScript file, because it will be executed by Angular at runtime, and then this will not refer to what it refers to during development, in this case here. So this allows me to save it. Let's now check the validity. If we inspect this input here, it's invalid because it's empty. If I enter something, it's valid. If I enter test, it becomes invalid again, so our own validator works. Again, it would have been perfectly fine if you would have added this to your app component. Let's now add an asynchronous validator. So here I will implement the same with async in front of it to make clear what the difference is. And I'll then also name it invalid project name. Of course, you could also create this in the app component file. We will receive the form control here, and we will return either a promise of type any or an observable of type any. An observable needs to be imported from rxjs/observable. With this in here, I again will create a promise I will return. So a new promise, which will receive a function as an argument to the constructor. This function will receive resolve and reject. And then I will execute a timeout in there. Let's say after 2 seconds, I want to execute this function here, this anonymous function, where I will again check if the control value equals tests. So as in the synchronous validator, but now asynchronously. If this is the case, I will resolve this exact same error code here actually. So like this. Otherwise, I will resolve null. So we should resolve null if it is valid. Well, and then I can return the promise here. Now with that, we can attach this validator. So besides our custom invalid project name here, let's actually change this to test project so that we do have 2 different values to check for. So I can leave the old validator on there and attach my asynchronous validator as a third argument to form control. Here I will also reach out to my custom validators and then the async invalid project name. Again, don't execute it, only pass the reference. And I will simply split this over multiple lines to be in line with the requirements of TS-lint here. So, like that. So with that, we configured this form control, null default value, 2 validators, one of them our own validator, and the asynchronous validator checking for the test project name. With that, let's save this and therefore reload this project and now inspect our project name. It's invalid. If I enter test there, it's also invalid. If I enter test per, it's pending and valid. If I enter test project, it's pending and invalid. So our own asynchronous validator is working too. And with that, we practiced some of the things you learned in the last lectures of this course. Again, feel free to play around with that, build much more complex forms. And in the next course module, we're actually going to apply some of the knowledge you gained in our course project in the recipe book. See you there. Welcome back to our recipe book course app. We already added a lot of features to it. Now I want to add forms. We have 2 places where we need to add forms. When we create a new recipe or edit a recipe in the recipe edit component, and on the shopping list here. We already are able to add elements to the shopping list, but we can handle this in a better way through a form. And then I also want to make these other buttons here work. The form for the recipe. As soon as we can create new ones, I also want to make the delete button work. Let's start with the shopping list form in the next lectures. Here, I want to use the template-driven approach, and certainly feel free to go ahead and try implementing this on your own, but there are a couple of different approaches of implementing it, so probably we won't have the same solution. In the next lecture, we'll start together and I will show you my approach. So let's start working on that shopping list form. As mentioned, I want to use the template-driven approach. So in the shopping list edit component here, we already got our form element up here. Now Angular will already take control over this, and we already got the forms module added in app module by default. We of course will need this too. So with the form here, we now can start working on our form controls. I will get rid of these local references. I will no longer use that approach. I will also get rid of the click listener on the add button. Instead, I want to use ng submit to submit the form, and then call onAddItem here. I also will get access to the form created by Angular, and as you learned, we can get access by placing a local reference on the form element, and now this would give us access to the form element itself. But by setting this equal to ngForm, we get access to this JavaScript object Angular created behind the scenes. And now we can simply pass this object to this onAddItem method. So that is how we can submit the form, but we also should register some controls. We got a couple of controls here. Let's start with the first one. Here on the name control, I will assign a name, so the name attribute of name. So a lot of names here, but of course the name between the quotation marks is the name of the property we'll later have in this form object Angular created. And I will assign ngModel to this input so that we register it as a control in our template-driven form. Now for the second input, the name will be amount, and then I'll also add ngModel and make sure that you import it from forms module, otherwise this is not available. So we should have this control added to our form too. And the add button here will submit the form because it's the only button of type submit. The other two buttons are of type button. So in onAddItem, in this TypeScript file now, I no longer will use my element refs here. So I can remove these declarations here. I can get rid of the viewChild and element ref import, and I can get rid of these two lines where I extract the data. I still want to create a new ingredient, but now we will simply get the form here, and it will be of ngForm, so of this type. Since this is the form, we will get the value of the form on the value property. Now we can simply use the value and access name to get the name of the ingredient and value amount to get the amount, because name and amount were the names we specified here in our template on these input elements. Well, let's see if this works. If I save this and we go back to the shopping list, ngSturf is still running. Here, if I add bread 1, that looks good. Works like before, but now using the better approach of using the built-in tools and therefore building a better form. Now we can also take advantage of validation and so on, and that is something I will do in the next lecture. In the last lecture, we registered our controls and we made our form submittable. So that is what we did then. We can still use that form. Now I want to add validation. For example, the name should be required. This must not be empty. And the same for our number. Now it should be a number, and due to the fact that this input is of type number, it should already be hard to enter anything else. So with this, we now added some validation. Now to take advantage of this, I want to disable the add button if the form is invalid. So we'll bind to disabled here and we'll disable it if form is not valid, if this is true. So if this check here is true, and this will be true if the form is not valid. So let's save this, and this looks good. I can't click the add button. Now let's try again. Let's insert something into amount. This works. Of course, a negative amount works too though. So an easy way of making sure that we may only enter numbers greater than 0 is to use another built-in validator, the pattern validator. This will check the user input against a regular expression. Now, the regular expression achieving what we're looking for would be the following one, which needs to be pasted between single quotation marks, so as a string. It's this one. Since it's a string, we can also omit these single quotation marks and omit the squared brackets to use the shortcut of using property binding when binding to a string, where we don't have to use the squared brackets. So what this will basically do, this regular expression, it will allow any number greater than 0. So we can see this in action if we now save this and go back to the application. If I add bread and 1, this is valid, -1 doesn't work, -10 doesn't work, -01 doesn't work, +01 does work, 10 does work, and 0 does also not work. So it does exactly what I wanted to do. So now we added validation to this input field. Now let's make sure that once we click one of the existing items, we actually load that item so that we can edit it. So, time to make our items editable by clicking them. In our shopping list component, where we have our items, I want to add a click listener to the item so that we, well, can click it. Here, I want to call onAddedItem, of course, any name you like. Simply copy it. Now here though, I also want to get the ID of the ingredient, and I need the ID so that I'm later able to replace the correct one in the array of ingredients which is managed in a service. So let's extract the ID like this, I equals index, to get the, well, index of the current iteration, and let's pass it here as an argument. Now I can copy this name and go into my TypeScript code. Here I want to add onAddedItem. And I know that I will get the index here, which will be a number. And now there are a couple of ways of getting this information, this index, to the shopping edit component, which is in the end where I want to get it to, because that is where we are editing. I will use the service, or specifically a subject in that service, to which I can listen in the shopping edit component. So I will add a new subject in the shopping list service, and that I'll name started editing. Sounds like a fitting name. It'll be a new subject, and subject is a generic type. It will hold a number in the end. That's all I need to change here. With this subject created in onAddedItem, I can reach out to the shopping list service, which we already inject, and then use started editing and emit a new value, my index, which will make sure that now we pass on this index to our subject for now so that we can listen to it in some other place. That other place is going to be in the shopping edit component. Here in ng-on-init, this sounds like a good place to do the listening. I'm already injecting the shopping list service. So here I will subscribe to my started editing subject. And of course I should clean up this subscription if we destroy this component, so I will store it in a property named subscription, which is of type subscription, which I should import from rxjs subscription, and I'll move up both these imports here to the top of the file. So with that we got our subscription property. As I just said, I want to store my subscription in this property. And now I will implement onDestroy. Therefore, you should import this interface from @AngularCore. And then also implement ng-onDestroy to clean up the subscription, just to be sure that you don't create a memory leak. So that's the cleanup work, but what should happen inside of this? Well, here we know that we will receive the number of the item we're about to edit. And this will be triggered whenever we submit the started editing information. We also know something else. We only get here into this anonymous function if started editing was triggered, so if we are editing. So that is an important information when it comes to what we should do once the form is submitted. Should we create a new item or edit an existing one? So I want to store the mode we're in here in a property. I'll name it edit mode, and by default it's false. Here, however, I will set edit mode to true, because we are editing, right? So with this, we now get the index and we are editing. I also want to store the index of the item we're editing. So edited item index could be a property name. It will be a number in the end, and it will get initialized here. Edited item index will be the index we're getting here as an argument. So with that, we got a lot of important information. Now with that information, I want to load the item we're about to edit. So that is something I'll do in the next lecture. In the last lectures, we did a lot of setup to get the information about the item we're about to edit. Now let's edit it. I want to get the item we want to edit, and for this, in the shopping list service, I'll need a new method, which is simply getIngredient, which expects to get the index, a number, and which will simply return us the ingredient from our ingredients array, so the ingredient at this index. So with that returned, we now can reach out to this new method in our shopping edit component and store it in the edited item maybe, which is an ingredient, so of type ingredient. And we do this whenever we get a new information that we're in the edit mode, I should say. So here, edited item will be set equal to, reaching out to the shopping service, to the item we get from the getIngredient method. And here we simply pass our index. So with this, we got a lot of information here. Now we need to update our form if we are in edit mode. And for this, I want to get access to the form. Now on the form, we do have a local reference, f. We can use this together with @viewChild to get access to it. So here I will actually use @viewChild and make sure to add the import from @AngularCore. I will reach out to f, and this will be the shopping list form of type ngForm. So make sure to assign this type here. Now, once we got all the new information inside of the subscribe callback, and that is of course important, outside of there, this will not be run each time we get a new information, but it might be run before we got any information at all. So outside would be wrong. Inside of this callback here, I want to reach out to my form and call setValue here. And now I want to assign a new value. For the name, I will use my edited item, and here the name. And for amount, you guessed it, I'll also use my edited item and then the amount. And this should make sure that whenever we select a new item, we actually populate the form with the right values. We can already try this with ngserve running. Once our page reloads, if I click here, we indeed select the correct item. So that is working as expected. Now, of course, it still adds it as a new item, so we need to make sure that if we are editing, we correctly rename this button to update or something like this, and that we then also do update the item and don't add a new one. Let's do this in the next lecture. In the last lecture, we finished our setup, which allowed us to load an item. Now I want to make sure that if we are in the edit mode, we actually don't add a new one, but update the existing one. It starts in the template with the button name. Here, this won't be add at all times. Instead, this will only be add if we, are indeed adding an item. Otherwise, it will be save. So here we can check if edit mode. And if this is true, and I'm using a ternary expression here, I want to output update maybe. Otherwise, if we are not in edit mode, so if we are creating a new item, I will save add. And now with that, we see add as the default, but if I click an item here, this switches to update. Now with that, of course, I also want to change the way we save this. So in onAddItem, right now we always call addIngredient. Now that's not correct if we want to update an existing one. First of all, in the shopping list service, I'll add a new method, which I'll name updateIngredient. UpdateIngredient. And here I expect to get the index of the ingredient which should be updated and the new ingredient of type ingredient. And with that information, I can simply reach out to my ingredients, get the one with the index I'm looking for, and set it equal to the new ingredient. And thereafter, I want to call ingredients changed and emit my updated ingredients. And as always, just a slice of them as we did before. So with this, I'm now updating the ingredient here. We need to call this method in onAddItem if we are in edit mode. Well, nothing easier than that. We can simply use an if expression, check our mode here. So if edit mode is true, Well, then I don't want to add a new ingredient. Then I want to reach out to the shopping list service and call update ingredient. And here I will pass my edited item index and my new ingredient. Otherwise, then in this case here, I will call add ingredient. So now if we save this, we should see that indeed, if I change this to 10 here, or 19 because I mistyped, and I click update, it does update here. And the same for tomatoes, it updates here. Of course, also if I rename this to bread. So that's working, that is awesome. Now let's see if it also works if we create a new item, bread. Now it correctly adds a new one. And if we now click on this, we do indeed edit it, so this works fine. However, now I also want to reset the form after updating or creating an item. And I also want to make this clear button work, as well as the delete button. Let's start with resetting the form though in the next lecture. So let's reset the form once we click update or add. Definitely go ahead and try it on your own. Time to pause the video now before I will show you how I would do that. So, were you successful? There is something tricky about that, but let's start with the straightforward part. After we saved our updated value, or either saved the updated value or the new value I should say, we can of course call form reset here. Now if I do this, let's see if it works as expected. If I type bread here, 10, and I click add, it resets, so this works. If I select tomatoes and change this to bread, it updates it to bread. But now we're stuck in the update mode. If I add bread again, maybe 12, it still updates the old one, right? It doesn't add a new one because we never leave the edit mode. The reason for this, of course, is that initially we are in edit mode set to false. Then we switch it to true whenever we get the started editing observable to fire, but we never switch it back. Well, we should switch it back, and actually we only need to switch it back here in onAddItem. Here I can simply call this edit mode and set it to false, no matter what it was before. This ensures that we definitely leave it because we are done. Also, we could rename this onAddItem to simply say onSubmit, because onAddItem is not correct all the times. But that is not important, that is just a little cosmetic change. Also rename it in the template then though. So with this in place, if we now try this again, let's add a new item, that works. Let's edit an existing one, bananas, 2. And now let's try adding schnitzel, 1. Now you see that seems to work again. Now we can correctly update, tomatoes, our items here, and it switches between edit mode and update mode. Of course, I also need to make sure that the delete and clear button works. So let's work on the clear button next. We already finished resetting. The clear button is pretty similar to that. So here I'll add a click listener and I'll execute on clear. And in the TypeScript file, I'll now add the onClear method here. How can we clear our form? Well, we already got access to the form because we added here with viewChild. So I can simply call this slForm reset. And I need to make sure that I also set edit mode back to false. If it was false before, it doesn't hurt. If it wasn't false, I ensure that we leave it. So with this now, if I select the item and I click clear, we're out of it again. So I can now add a new one. And if I'm in already adding one, bananas, and then I hit clear, I simply cancel this. So now I have to start over. But I can still update the existing ones. So that is all working as expected, now with the clear button added. In the last step, I want to make sure that we can delete items we selected here. So we added the resetting and the clear mechanism. Let's now make sure we can delete the items. For this, of course, I need another click listener here, and definitely try solving this on your own if you want. So that is your chance to pause the video. If you don't want to solve it on your own, or if you are already finished with it now, well, we can definitely go ahead and do it together. So I'm calling on delete here when I click the delete button, and I'll add this method to my shopping edit component. Well, in on delete, what do we need to do here? We need to inform the service that it should remove one of the items in the array. That is basically almost all. We also need to make sure that we call this on clear, because we definitely also want to clear the form if we delete the item which was loaded. Now in a shopping list service, I need to add a method, delete ingredient, and I expect to get the index where I should delete it. With that information, I can simply use my ingredients array and splice one of the elements. Splice allows us to start at a specific point, for example at the index here, and then splice one element, thus removing it. And then of course, as always, we should call ingredients changed. And of course, you could refactor this in its own method, but I think that's okay like this too. So here I will slice or simply pass a copy of my ingredients. And with that, the final step is, before we clear everything, I will reach out to my shopping list service, call delete ingredient, and simply pass the edited item index as a value. Now, this will throw an error if we click delete without loading an item. So therefore, I will simply add ngIf to the button, and I'll just restructure it to make it easier to read. ngIf to only display the button if we are in edit mode. So now by default we don't see delete. If I switch to an item, I can see and I click it, it resets the form and it deleted the item. Now no more items are left. Of course, I can still add new ones and delete them again. So that is our shopping list form working with the template-driven approach, and a lot of other nice features like the service, really showing you how you could set up something like this, how you can use set value, how you can reset the form, and therefore hopefully build the form you need. Now in the next lectures, I will move on to the recipe edit form, which we will create using the reactive approach. In the last lectures, we edited our form using the template-driven approach. Now let's move on to the reactive approach for the new recipe or editing an existing one. We got our recipe edit component here, and it doesn't have a form inside of it. So we should definitely change this. In here, I will start by adding a row, and then a column which should span the full width on all device sizes, and then the form without an action because we don't want to send a request. We want to handle it in Angular. Now we will need a couple of inputs here. I will actually begin with the save and cancel buttons though. So right at the start of this form, I'll have another bootstrap row, call XS12 will be the width, and here I want to have a button of type submit with a class of button and then button success, so that it's a green button, which should simply save the form, should save the recipe. I'll have a second button of type button so that it doesn't submit the form, which will be which will get the class button danger, which should simply cancel the editing here. So these are the two buttons which allow me to control the form in the end. Now for the inputs. I definitely want a row with my default column width here, where I will add a div with the form group CSS class to simply use that bootstrap CSS class to give it some nice styling. Then I'll add a label for the name of that recipe, and I'll say name here, and I will add the input. The input will be of type text with the ID name maybe, and let's already structure this over multiple lines, and with a class of form control to make it look nice. Now I will actually copy that row and paste it in below this name. Here I want to have my image path. So I'll name it image URL here, this input. And here I simply want the user to paste in the image path. So that will be this row. Below it I'll add another row. Here I won't have my form group though. Instead I want to preview the image the user pasted in. So I will simply add my image element here. I will later bind the source and assign the image responsive class to it. We will fine-tune this later if needed. So that allows the user to enter a title and an image and see that image as a preview. Now I'll add another row with another label, which should now say description, so the description of our recipe or the content of the recipe. So I'll assign this for the ID description, which of course will be this, but this will not be an input. I'll change it to a text area. Therefore, I also need a closing tag for this. On this text area, I want to provide, let's say, 6 rows for typing, so that it's not too big, not too small, should be okay. Well, and then below this, I'll add yet another div. This will later be required for the ingredients of that recipe here. So here we will actually need to create an array of controls and we will need to manage this. We did learn how to do this, but here we will see it in practice in a real project. Now here, as this will be for my array of items, I will get rid of the label and get rid of the ID. Also get rid of that div here. Instead, I will add a new row inside of there. We're going to have multiple ingredients probably. And each row should then have a couple of columns. The first one spanning almost the entire width. It will hold the input for the name of the ingredient. The second one being very narrow next to it, which should hold the amount. And the third one, also a very small column, should hold a button which allows me to delete an ingredient. Therefore, button danger, and put an X on it. So if we have a look at this, that is how a single ingredient will look like. Now we don't have descriptions for these inputs. You could of course restructure this form and try placing labels next to them or use a different layout. I like that layout here though. With that we got the HTML code almost finished. There is something missing, but before we work on this, let's make this base form work without ingredients for a start. So in the last section we created the HTML code for our form. Now let's initialize our form. And we will use the reactive approach, as I already said. Now for this approach it's important to understand if we are in edit mode or new mode. And we do get this information here. Why is that important? Well, of course, because depending on this we need to pre-populate the fields or not. So I will create a new private method in the recipe edit component, which I'll name initForm, because it is responsible for initializing our form. The form itself shall be a property here, so I will name it recipe form, and it will be of type form group, as you learned, to be imported from @AngularForms. Now we can build this recipe form here in initForm. Basically, I will reach out to it and assign a value, and this value will be a new form group to give us the outer shell of our form, so to say, the frame. Form group takes a JavaScript object where we have key value pairs for the controls we want to register. So the first control I do want to register here is the name of the recipe. This will be a new form control, so we should import form control from @AngularForms2. And here now, as I said, it's important to decide whether we are in edit mode or not, because that will determine whether we want to assign an initial value or not. Well, we could simply create a variable at the top here, which holds our recipe name, and let's set it to an empty string by default. Then let's add some logic which decides what the value should be if we are in edit mode. So let's check if this edit mode. If that's the case, then recipe name should probably be something else, and it should probably be the value of the recipe we can load with the ID we got here. We do have the ID stored up there. So we can simply inject our recipe service. Let's do this here. Recipe service, make sure to add the import at the top here. And now we can fetch our recipe here, the recipe we're currently editing. So I will fetch it right at the beginning, the recipe, reaching out to the recipe service, and then with get recipe and passing the ID of the recipe we know we are editing, I can get it. Actually, I shouldn't do it here because I would try to get one if we don't have an ID because we are not in edit mode. I should do it in here. So now we got a recipe. Now we can simply access the name of the recipe and assign this to our variable here. Now, the same will be true for the image URL, the recipe image path. It's an empty string by default, and the same is probably true for the description. So recipe description is also an empty string by default. And the ingredients, I'll come back to these. So for now, let's overwrite all these variables if we are in edit mode. So recipe image path will be set to recipe image path, and recipe description will be set to recipe description here. And with that, we can simply assign recipe name here for the name as a default value, because it will either be an empty string, that's the default, or if we happen to be in edit mode, it will have the name of the recipe we are editing as a value. So with that, we got the name. Now let's also assign the image path. Here I'll also add a new form control and set this to recipe image path. As a side note, we'll take care about validation later. And let's assign the description here, a new form control again, and we should assign the recipe description. Now again, I'll take care about the ingredients later. That is our base form created. Now when should we call init form, this method here? We should call it whenever our route params change, because that indicates that we reloaded the page. So that is where we should call this init form. Now with that, we are creating the form and it probably will work. However, now we need to synchronize our form to our HTML code. We'll do this in the next lecture. So we created our form. Let's now synchronize it to the HTML code. For this, first of all, and that's very important, we need to add something to the app module. In the imports array, we now not only need the forms module, we'll also need the reactive forms module, which needs to be imported from @AngularForms. Otherwise, synchronizing with our HTML code will fail because we don't have access to the directives we need for that. So therefore, what I'll do is go to my recipe edit component HTML file, and now I want to connect my form. Let's start on the overall form element. Here we have the form group directive, which we should use with squared brackets because we need to pass some data to that directive via property binding, and that data is our recipe form. So let's quickly assign this. Now we're telling Angular that our overall form is managed by us and that Angular itself should not manage it. Instead, it should take our form. With this, we can now assign our own controls. So let's simply go to a first input, the name here, and there we have the form control name directive. Now we could enclose it in squared brackets and then use single quotation marks between the double quotation marks, or we omit both and simply use this syntax. And now the name here, of course, has to match the name we set up here. So here we chose name, but we should choose the same in the HTML code. Now we'll copy this also for the image URL. Here I chose image path as a name, so let's make sure to use this. And of course, description for our text area here. Here I also will add the form group name directive and assign description. Now to be able to see something, I'll also set up the ng submit listener and listen to on submit. Now here of course I don't need to pass the form as an argument. Instead I can simply add the on submit method here and for now simply log my recipe form to the console. Let's see if everything works as it should. So once this has recompiled, I'll head over to the form and this looks okay. It almost works as expected. The name was pre-populated for the selected recipe and it does update if we change this to Big Fat Burger. The description is not displayed though. So that is not how I want this to behave. As a side note, on new recipe, it correctly sets this to an empty form. So that is okay, but would be nice if the description is displayed too. If I submit the form, let's have a look at the value. Description, actually it says what else you need to say. So what could be wrong about the description then? Well, if we have a look at the text area, I simply assigned the wrong directive. It should be form control name. With this in place, if it reloads, this looks much better. So with that, the synchronization is working. The next step is to get our ingredients to work correctly. And that actually will involve a couple of steps because we need to manage this array of ingredients for that. So let's work on our ingredients list. The base form is working, but of course we got another control which we haven't added yet. This is this array of ingredients. So when we initialize the form, we actually will have one other default value for the recipe ingredients. This will be a new form array. And you should import form array from @AngularForms. This form array is initialized with a default value of an empty array because we don't have any ingredients by default. Now with this, if that is our default, what do we overwrite it to here in edit mode? Well, there we will simply need to check if we have any ingredients to begin with, because theoretically you could create a recipe without ingredients. So here what I want to do is I want to check if my recipe which I loaded, if it does have ingredients. So if that is defined, I know I can safely use them. So in this case, I want to use all the ingredients, so I can simply loop through them with a for off loop. So for a single ingredient of my ingredients, I can go through all of them and I can push them onto my recipe ingredients form array, which has a push method. Here, I don't push the ingredient, I push a new form group instead, because I do have two controls which will control a single ingredient, the name and the amount. So these will be grouped in a form group, and here I will have a name, which is now a new form control, with a default value of ingredient name, and I will have an amount control, also a new form control, which has the default value ingredient amount. Whoops, not name, amount. So that is a form group I will push onto this array, because again we have two controls here. Validation will follow later. And with that we get a default value for recipe ingredients if we have a recipe and if this recipe then has ingredients. With that we can assign the ingredients control down there, and it simply is our recipe ingredients, which already is this new form array here. So that's looking all right. Let's see if it works, and for that of course we need to synchronize our array with our HTML code. So in the recipe edit component, if we scroll down to that section where we want to use the array, I'll first work on the div which wraps the whole section we're going to use. Here I need to add the form array name directive. This will then be bound to ingredients, because ingredients, keep in mind, is the name of our form array here. So that assigns that in this area we're going to handle this array of controls. Now each control, of course, is now going to be our row here. So on this row, I can place the form group name directive referring to the individual form group name. Because remember, in our array, we will have form groups, as each pair of name and amount control creates a form group. Now what's the name of the form group though? We didn't assign it because it's part of the array. Well, we learned how to get this name. We need to add ng4 to this div, and then we can loop through all the ingredients, through all the controls I should say, in our array. So I can loop through the ingredient control of my recipe form, and there get the ingredients control. Get is a method which gives us access to that, and here all the controls of this control. So this gives us access to all the controls, and the individual control is now saved in the ingredient control property or variable we can use in a template. And I can also extract the index of the current iteration, which will be the name for my form group. So with property binding, I can now bind I here. This should give me the form group. Now we also need to populate these inputs, and there it's very easy because now we're inside the form group, and there we have names, we have name and amount. So here we can again use form control name, set this equal to name for the first control, and form control name equal to amount for the second one. Let's see if that works as expected. Well, it already looks pretty good to me here. We got buns and meat, and if we added the schnitzel, we get meat and French fries. So that gets populated correctly. This is working as intended. With that, we got our array added. Now, of course, we also need to add a way for us to dynamically add new items to that. In the last lecture, we added our array. Now I want to clean up how it looks, some styling, but mainly I want to add a button which allows us to add a new ingredient to that array. Well, to work on the styling, all I really want to do is I want to have some spacing between the rows. Well, there are a couple of ways of getting this style. What I will simply do is I will add an inline style, a normal style, no Angular style, no ng style directive. A normal style where I say margin, top, and set this to 10 pixels maybe. And with that, it looks much better. So that's all I wanted to do for now. The more important part is that we're able to add new ingredients. And for this, I'll simply add a new button at the end of this array area. So outside of the div which is responsible for my individual form groups, I'll add a new row with a new column inside of it. And here I will simply add a button which says add ingredient, which will be of type, or which will get a class of button success maybe. So now it sits directly at the bottom. Maybe let's simply add a horizontal line between rows, and that looks pretty good. So now we get this button. Let's now also hook it up. I will add a click listener on add ingredient, and here in this method, which I'll add to the TypeScript file, I want to add a new control to this array of form controls. Now I can simply do this by accessing my recipe form. There I can get my ingredients control, and I know that this will be a form array, but Angular, or TypeScript to be precise, doesn't know this. So I will explicitly cast it with this cast command here, basically by enclosing the type I want to convert it to between smaller than and greater than signs, and then enclosing this all in parentheses. And now the part here between the parentheses is treated like a form array because I know that it indeed is one. So here I can call push, and I want to push a new form group because remember, we don't push a control here, we need two inputs, so a group of inputs. And there again, I will have a name, which is a new form control, and I will have an amount, which will be a new form control. And we don't need to provide any initial values because I don't want to have any. So if I save this and we go back to the application, we should indeed see that once this reloads here, if I click add ingredient, we add a new line. However, I also submit the form with each click, as you can see here on the right. This is quickly fixed by making sure that this button receives the type button, and now it shouldn't submit the form anymore. So now it just adds ingredients. This is all working. This is great. Now, before we make this form submittable or we do something up on submission, let's make sure that we add some validation to it. We finished our form in its basic form, but time to add some validation to it. We do add validation, of course, in our TypeScript code. Right now, there is no validation attached to any of the controls, and that is not really the behavior I want. When we initialize the form here at the end of init form, for the name, for example, I want to add a built-in validator. So from the validators package, which we need to import from @AngularForms. So from this package, I want to add the required validator. Don't execute it. Don't add parentheses. You only want to pass a reference to this validator so that Angular is able to execute this method at the time it validates the input. Now, the image path, that should also be required. So I'll repeat the procedure here. Add required, don't execute it. And I'll copy it because I also want to require the description. For the ingredients, when we create a new ingredient here, the name should also be required. And the amount, here I'm going to add two checks. The first one is that it's required. The second element here actually is the pattern validator. And here we can copy the pattern we used in the shopping edit component. This regular expression here, it's the same expression I want to validate here, that we only have positive numbers. Here in pattern, you simply pass a regular expression by putting two forward slashes and in between your expression without any quotation marks here. So that is the pattern, and we do execute this method because this acts like the factory. It gives us back the configured validator then, which will be used by Angular. But to configure it, we need to pass an argument, right? We need to tell it what should be our pattern. So that are the validators for a new form control in the array, for the new amount control, I should say. Let's also copy that to the onAddIngredient method, where we also create a new form array form group. So here I will set the default values to null and then also add my validators. And the same for the name, should have an empty default value, and then here just the required validator. So now validation should be added to the form successful. And to use it, I will disable the save button if the form is not valid. So I will bind to disabled and check if recipe form is not valid. Well, let's see. If this reloads, we should see that the save button gets disabled, I would say, but right, we got a valid form here. So let's empty the name, and it's disabled. That looks good. Let's now empty the description, disabled, the URL, disabled, or any control here. So the name of this ingredient, or maybe the number or a negative number. So that all seems to work. The validation state is successfully taken into account. Now to finish the validation, I'll go to my CSS sheet and I want to mark invalid inputs. Now we get this handy ng-invalid class, which is added to anything which is invalid. And that's the problem. If I add a border of, let's say, 1 pixel, solid and red, well, watch for yourself. If I remove that, not only is the name input field invalid, the whole form is. So the whole form has this ugly border. Well, we can simply change this to assign ng, or assign this class, the style I should say, only to elements which have the ng-invalid class, but which also are an input, or optionally, to be very explicit here, a text area in our case here with ng-invalid. So with this now, we should make sure that if I remove this, only the box itself receives the red border. To prevent this from having the red border right from the start, I'll also add ng-touched here as a check or as a class which has to be present, so that we at least had to click into that control to mark it as invalid. You will see what I mean if I add a new recipe. Everything is clean. If I click in here and out of there, now it has the red border. So that is validation working as it looks to me. Now let's make sure that we can actually submit a form and save it or successfully update it. With validation added, let's make sure we can update or save our recipe. So in the recipe added component, in onSubmit, I don't want to print the form, I want to do something with it. I want to save it in my array of recipes or update an existing one. So for this, I will need to change my recipe service. Right now, it has no method which allows me to add or update recipes. So I'll add it. Add recipe is a method I will need. And here I expect to get a recipe of type recipe or update recipe. Here I expect to get the index of the recipe I should update and then the new recipe, also of type recipe. In the add recipe case, I will simply take my recipes array and push a new item on it, this new recipe. And in the update recipe case, well, I will take my recipes array, take the element at the index I got here as an argument, and set it equal to the new recipe. That is the logic in the service for now. In the recipe component, recipe added component, excuse me, we already inject this service. So in onSubmit, I now check if we are in edit mode. If we are, then on my service, I of course want to call the update recipe method because I'm interested in, guess what? Updating it. I don't want to create a new one because we're in edit mode. So here I will pass the ID of the recipe we're working on and then the new recipe. Let's create this new recipe outside of this if check. The new recipe simply is a new recipe using our recipe model, which you therefore have to import at the top. And with that imported, let's configure it. We actually have to pass all the data this constructor expects. So we can access this on our recipe form. Here on the value, we know we will have a name. We also know that here on the recipe form, on the value, we will have the description. Now that's getting long, so I'll put this over multiple lines here. The next argument we expect is the image path. And guess what? We know that our value will have that image path because we configured this form and it's controlled. So we know that all these values will be present once it is submitted. Also because we added validation to prevent, well, the submission of values which are not valid. And here the same for the array. We can simply use our recipe form, the value, which is stored in our array ingredients. Let's see if that is in the format we require it to be. So with that, we get our new recipe. Now we can simply pass this new recipe here as an argument to update recipe, or if we are not in edit mode, we will call the recipe service, the add recipe method, and pass our new recipe here. As a side note, since our value of the form has exactly the format of our recipe model and the same names like image path and so on, and this is something we especially wanted to make sure and we focused on, you can skip this step of saving it in a new constant and just pass this recipe form value, because the object stored here should have a valid format to fit one of our recipes. So that is a fine way of then taking really advantage of the reactive approach we're using here. With that, we're saving the data. Now let's see if that actually gets added to our list of recipes. If we type 2 here, well, I don't know, didn't change here. If I type something here and I click save, I don't see it, but we also don't get an error. Now let's check, do we submit it? Yes, we do, and this button is of type submit. What's wrong? Do you figure it out? We had this problem earlier in this course. It has something to do with our recipe service. We add and update recipes, but when we get a list of recipes, we return a copy, here with the slice method. Therefore, this is not the same array we're using in our component as the one we're storing in this recipe service. So the one we're updating is not reflected in the components. We can simply use the same approach as in the shopping list service. I'll have my recipes changed event here, which is a new subject, and subject is imported from RxJS subject. Make sure to add this import. This will then pass an array of recipes as a value. And now here, when we call add recipe, I simply use this recipes changed event here, so to say, and emit a new value. This new value is a new copy of my recipes. So that's the same approach as we used in the shopping list service. The same, of course, here when we update a recipe. And as I mentioned earlier, in the shopping list service, you could refactor this into its own method. So with this added now, we can go to our recipe list component, which is in the end where we get our recipes, and an ng on init, I now want to listen to this event. So on the recipe service, on recipes changed, I will subscribe to that event. And if it did change, I know that I will receive a new array of recipes. That is the data we will get in this callback then. And then inside here, now I want to get my updated recipes, or simply set the recipes equal to the recipes I got passed here, I should say. That's an approach comparable or pretty similar to the one we used in the shopping list service. So let's save this, and now if we try to edit this recipe, put a 2 after the name, now it got updated here. And now if I add a new recipe here, some image that won't be displayed of course, just a test, and let's even add an ingredient, bread 10. If I hit save, we see it here, of course without an image, but that seems to work, and if I put this to the shopping list, bread was added. So that is all working here, and the errors you see here on the right, they simply occur because we can't fetch this image. So this is our recipe form now working, both for updating and for new recipes. Now let's see if there is something else we should do. Well, there are 2 things we should definitely do, 3 actually. We should enable this delete button, and when editing a recipe, no matter if creating a new one or editing an existing one, we should make the cancel button work, and upon hitting save, we should navigate away. Actually, that's the same which should happen when hitting cancel. So that would be a challenge for you again. Make all 3 buttons work. Save and cancel to simply navigate away, and then also the delete button to delete our recipe. Here is my approach. What I want to do is, I want to start with the delete button. For this, I'll start in the recipe service and add a delete recipe method. Recipe, where I will get the index of the recipe, which should get deleted. And in here, I will then use my recipes array, call the splice method and splice at the index one element to remove it. Thereafter, I'll call recipes changed and emit a copy of the updated recipes like this. That's the first step. Now I can call delete recipe from the recipe detail component, which is where we have this delete button, by adding a click listener on delete recipe. And here I will copy that and implement it in the TypeScript file here on delete recipe. And I simply want to reach out to the recipe service, call delete recipe, and now we also need the ID here. So we used it early in this course to have this more complicated way of navigating, but for deleting, now we really need it. So here we should add this ID as an argument. So before we test this, let's also make the cancel and save button work and let them navigate us away. So in the recipe edit component, which is where we have these buttons, here we should hook them up to an event listener. So cancel we should hook up. The other one already is automatically triggering the submission event. When we hit cancel, I want to execute on cancel. And in the recipe edit component TypeScript file, we don't need that import anymore, so we can remove it. But the thing I wanted to do is I will add the onCancel method. And in onCancel, well, here I simply want to navigate away. So for that we need the router of type router. So let's inject it here. Make sure to import the router type from @AngularRouter. And with that injected in onCancel, I can simply access the router and navigate, and I want to go up one level. If we were editing, this will take me back to the detail page. If we clicked on the new button, it will take me back to the recipes page. So for this to work, we need to tell Angular what our current route is, and we do already inject it here, the activated route. So with that, we can pass the second parameter relative to this route. So that happens if we click the cancel button. I actually want the same to happen once I submit the form. So here I will call onCancel, even though it sounds wrong, but we are done at this point. We can simply navigate away. Let's see if that all works. If I click cancel, we're back to our recipe. The same for this one. And if I do change something and hit save, we're also back to the updated recipe. And if we create a new one and I hit cancel, we're back to the please select the recipe state, which makes sense. And if I enter something here and click save, we're back to this state too. So this is our application working fine here. All these buttons working. Let's see if we can delete this recipe now. Looks almost okay, but we still see it here in the detail view, even though we deleted it. Can demonstrate this again for the schnitzel. See it? It's still here, even though we removed it. So that is something we need to update before we are finally done with this section. So we're almost done, but the delete button isn't entirely working as expected. It's updating the list, but we're staying on the page of the deleted recipe. So to change this, we need to go to the recipe detail component, which again is where the delete recipe button lives. And then on delete recipe, we simply need to navigate away. We already got the router injected here, so we can simply call this router navigate. And now I simply want to navigate to /recipes here. And with that, we should have the right user experience that once this updates here, that if I click delete here, it is deleted and we're taken back to the main view. So let's try this a final time here with spaghetti, searching for a fitting image for spaghetti. Let's pick this one here. And let's insert it here. And let's finally enter a description. Tasty spaghetti. Let's hit add ingredient to add some spaghetti, 10 let's say, and let's save the form. And this all works, but one thing is not working. Do you see which? The image. We're not getting a preview of the image here. So let's fix this in the next lecture before we finally move on. In the last lecture, we added our own recipe, spaghetti, and we recognized that the image preview is not working. Well, that makes sense because if we have a look at the recipe added component, here where we try to preview the image, we're not binding the source. We should do this. I'll add a local reference named image path to that input because I want to get access to that input inside of this template. And then I'll bind the source here to that local reference, so to image path value, because that is exactly what I want to display here. With that, if we now create a new recipe and paste in our old link, now we immediately get a preview of this image. So now this is working as expected, and now if I add my spaghetti recipe, very tasteful, with my new ingredient, spaghetti, 100, and some tomatoes, 3. And if I hit save now, here it is. Now we can see it. Now we can edit it. Multiple exclamation marks make it more meaningful. We can send it to the shopping list to find our spaghetti and tomatoes there. Well, we already have tomatoes here, so we can delete these here, I guess. And we lost it. Where are our spaghettis? If I go back to recipes, spaghettis are gone. So that seems to be another bug we need to fix. The bug we recognized in the last lecture is a pretty mean one. If we add a new recipe here, we hit save, and we go to shopping list and go back, you see it's lost, it's gone. Again, test, test, and gone. So what's happening here? The issue we encounter here is that we provide our recipe service in the recipes component. So all the components in this area share the same instance. But if we navigate away to the shopping list area, the recipes component is destroyed, and so is the instance of this service. So what we need to do to ensure that our service survives is we need to add it to our app module here. By adding it here, recipe service, and adding the import to, we make sure that now we have one instance of the service all the time available as long as our app is running. So now if we add the spaghetti one more time with our beautiful image, very tasty as mentioned before, and I hit save, now if I come back, it's still there. And as you can see, I can still edit it. So this is now working. Now we can try putting it to the shopping list, which of course doesn't add. We first of all have to add some ingredients like spaghetti. But now this is working as expected. Well, almost. With the remaining bug that here, once we click this X button, we're not deleting the ingredient. So that is something we should also have a look at. We're almost done fixing bugs. Our recipe service is now working as expected. If we switch back and forth, the spaghetti are there. But now, if we go back to recipe added component, this delete button, this X here, is not working. First of all, it's even submitting our form, and we definitely don't want that. So we should set the type to button. Then I'll also add a click listener and say on delete ingredient. And here, of course, I should pass the information which ingredient should get deleted. So I should pass the index I, which is simply the index of the control we want to remove. With that, we can implement the onDeleteIngredient method in our TypeScript file here. And I know that I will receive the index here, number. Now with that, I can get access to my recipe form to call the get method and get access to my ingredients, which I know is a form array. So let's cast it as we did earlier too. And now we can call the remove add method and pass the index to remove a specific form control, the one at the position we want to delete. Now with that in place, we can save this. And now if we open a recipe and edit it and remove this, now you see it indeed removed the ingredient. So now we updated the recipe and therefore we only sent the French fries to the shopping list. And again, the other bug we had before is fixed. Our recipes survive. Now to clean this app up, there's one other thing I forgot to do earlier. In the recipe list component where we subscribe to our recipes changed event here, well, we should unsubscribe if the component gets destroyed. So let's implement onDestroy and import this from @AngularCore. And then I will add ng onDestroy here. And I want to store the subscription in a property named subscription of type subscription, which needs to be imported from rxjs subscription. And then I can store it by assigning it as a value here in onInit. The subscription is assigned. And in onDestroyed, I can now unsubscribe again to make sure I don't cause any memory leaks here. So with that, with all these bug fixes we added, our app is looking great. It should work fine now. We can add new recipes here. We can edit existing ones. We can remove the ingredients there and add new ingredients if we want, of course. We can then use them and send them to the shopping list. There we can delete them. We can add new items or decide otherwise and clear the form. Our forms are working great here and use quite a lot of useful tools you may use in your next application, which are great to enhance it and to offer a great user experience. With that, let's move on to the next course section. Welcome to a new course section. This course section is about pipes. And let's start with the most important question first. What are pipes? Pipes are a feature built into Angular 2, which basically allows you to transform output in your template. This is the main purpose of a pipe. It transforms some output. Now, there are pipes for different types of output and also for synchronous and asynchronous data. We will have a look at this throughout the course. The general theme is always the same though. A basic example would be the following. You have a username. That's a property in your component. For example, here it holds a string, max. Now you want to output that username in your template, and for this you probably use string interpolation, as you learned it throughout the course. Now that's all right, but then you decide it would be nice if the output, which is max if you do it like this, would be all uppercase, but only when you output it. So you don't want to change the property itself to uppercase, because imagine you use that throughout your code and it should still be, well, as you assigned it up there, but you want to transform the way it is displayed once you render it to the screen. Now for this, you could use a pipe, namely the uppercase pipe. This actually would be a built-in pipe, and we will have a look at the built-in pipes in a second. Now with that built-in pipe in use, you would now see max, all uppercase, being printed to the screen, because this is what this pipe does. It transforms the value. Now, that is the main purpose of pipes, transforming values. Let's dive into them a bit more. Let's view some of the built-in pipes, and then let's also build our own pipes. Let's go. I got a little example project set up here, and you can find it attached to this video. Now, the code responsible for what you saw here on the screen is basically this app component template, where I output a list of servers, and the servers are stored here in my app component TypeScript file. I got the servers array, which simply holds a couple of JavaScript objects, each representing a server. And then at the bottom here, I got a little helper class, which simply retrieves the right CSS classes, which should be attached to that list group item, depending on the state of the server, if it's stable or offline. So this is the project we're starting with. It looks all right, but we got a couple of things we could fix here. Now, for example, we got a server name, which looks all right to me, but then we got this instance type here, medium, large, small, and we got this state. Now, you could, for example, put this instance type to be all uppercase, and the date, I'd like to change something about the state too. But let's start with the instance type, medium, large, small here, to see how to use pipes. And you will see it's actually pretty simple. To change it, we have to go to the template, to the HTML file, because remember, a pipe is only responsible for transforming the output. So the right place to use it, logically, is the template. Now here, I want to change this server instance type thing here. I'll just bring it into a new line here, and the same for server started, just to make it a bit easier to read. And now I would like this server instance type to be uppercase. Now that's easy to achieve. We just add the pipe symbol, hence the name, pipes, and then the name of the pipe. And as mentioned before, there are a couple of built-in pipes, and you can also build pipes on your own. We'll have a look at this in one of the next lectures. Now, a good built-in pipe for making this all uppercase, of course, is the uppercase pipe you saw on the slide before. With that added, you now see, if you save this and go back to your web page, that all the instance types here have been converted to be uppercase. So without changing anything else, without, and that's important, changing the property itself, here the the instance types are still lowercase. Without changing anything here, we change the way users can view it simply by adding a pipe here. That looks pretty good to me. Now let's move on to the date. And for this, we got another pipe we could use. So if we have a look at the HTML code here, the server started output here is responsible for rendering the date. Well, if we add the pipe symbol here too, we could add the date pipe, another built-in type. And I will come back to where you find those built-in pipes in a second. Now with this added, let's save this. And now you see, out of the box, this looks much nicer. But it might not be the way you want it to look. So let's learn more about how to configure pipes in the next video. In the last video, we added a couple of pipes. The uppercase pipe to transform the instance type and the date pipe to transform the type. But as mentioned at the end of the last video, it would be nice if you could configure a pipe, because this layout here, this way of displaying the date, might not be the layout, the format of the date you want to output. So it would be nice if we could parameterize a pipe, and we can. For example, on the date here, we can add a parameter to configure the pipe by adding a colon, and this is the case for any pipe. You configure it, you pass a parameter to it by adding a colon. Of course, the pipe needs to be able to handle a parameter, and again, I will come back to where to find out how these pipes work or what the built-in pipes do, how they can be configured in a second. The date pipe can take a parameter, and we simply add it after this colon. Now, the date pipe expects to receive a string parameter, so let's pass a string. And there you basically set up the date. I'll come back to the options you have in a second. Now, for the moment, let's just enter full date, camel case, so a capital D. Let's save this and go back to our application. And you see, now we get a better formatted date. Now, might still not be what you want, but again, I will come back to other options in a second. It is what I like to see here. And this is how easy you can parameterize a pipe. You can pass parameters by simply adding a colon and then the parameter. As a side note, if you would have multiple parameters here, you simply separate them with additional colons. So the date pipe doesn't take an additional parameter, but if it would, you could pass it by adding another colon and then the second parameter. Now, with these basic functionalities set, let's have a look at where you can learn more about the built-in pipes and how you can configure them. Let's dive into this in the next lecture. In the last lecture, we parameterized our first pipe here, the date pipe. Now let's learn more about all the built-in pipes and how we can configure them. The place to learn more is the official documentation. So you can just head to angular.io and there under docs, click on API reference. Now, you may ignore the version number up here. It should be 4 point something when at the point of time you view the video. I'm just recording this in advance, but the pipes won't change or haven't changed. So here you can enter pipe as a filter, and then you view all the pipes which are built into Angular. And there you see we got a couple of them. We already used the date pipe and the uppercase pipe. But there also is the slice pipe, which allows you to take a slice of the input. And there you would see that the slice pipe actually takes multiple arguments, the start and the end. So where it should start slicing out a piece of the word and where it should end. There you can also view a detailed explanation and an example. So this is really a great place to dive into pipes and play around with them, since there is not much sense in covering them all in detail here video by video, as they are very specific in the use case, and the documentation here is really great for diving deeper into it. So with that out of the way, I want to have a look at the date pipe. Here you can see how you can configure it. You can see a couple of different shortcuts for getting a specific date format, or you can format it from scratch with the typical symbols like lowercase d for a day and so on. So this is where you can dive into how to make the date look exactly how you want it to look. Now with that, let's move on to creating our own pipe, or almost move to that point, one other thing, and then we will move on. Now with our pipes being added and parameterized, it's also important to know that you can combine pipes in Angular. So far, we only used pipes on their own. So we added the date pipe to our server started output here, and we added the uppercase pipe to the instance type. Now, what if we wanted to, yes, format the date like this, but then for some reason also make it all uppercase? Now, you can simply chain pipes by adding a pipe symbol after a pipe. So we could add uppercase here. Now, the order might be important. Generally, it will be parsed from left to right. So server started gets into this pipe here. So the date pipe gets applied to our server started property output here, to the string interpolation. The uppercase pipe then gets applied to the result of this operation. And I can show this if I save it like this. You see that the date indeed is uppercase. Now, if I switch positions here and put the uppercase pipe first and then parse the date, you see we get an error. And if we open up the console and view this error, you see that this argument here is not correct for the uppercase pipe. It doesn't know how to parse it because it is a date and not a string, and there are elements which can't be turned into uppercase. So this is why it's important to watch the order. You should apply the pipes in the order you want to transform your input. So transforming the date into something which can be parsed first is absolutely fine, and as you will see, will work correctly. You see it here. But the other way around wouldn't work in this example. So again, always keep this order in mind, from left to right. This is how it gets executed and how pipes get applied. With that out of the way, let's create our own pipe in case there is some functionality we need which is not available in one of the built-in pipes. Thus far, we already learned a lot about the built-in pipes or on pipes in general. You learned how to use them, where to find out more about them, how to pass parameters or possibly multiple parameters, and also how to chain pipes. This is great, but sometimes you need some functionality which just isn't built in. In this case, you need to create your own pipe, and thankfully, this is super simple. Now, creating our own pipe is as simple as creating a new file in your app folder and then giving it a descriptive name. For example here, I want to create a pipe which shortens my words, the input. Because let's say I want to shorten this name of my server, so the testing environment server somehow gets cut off. Now for this, I will create a shorten pipe, so I will name the file shorten.pipe.ts to keep this naming convention of being descriptive about what's in a file. Now this newly created TypeScript file should simply hold a class, which I export of course, which I'll name shortenPipe. Now this shortenPipe, this class, needs to have one special method to be usable as a pipe. And whilst not strictly necessary, it's a good practice to implement a certain interface which requires you to implement that method. The interface is called pipe transform, and you need to import it from @angular/core. So make sure to add this import at the top, pipe transform from @angular core. And with that implemented, you see that I now get an error in my IDE. You would also get an error if you now try to compile this. Because what we need to do here is we need to apply, or we need to provide, the transform method. Now adding the transform method like this still is not 100% correct. Transform needs to receive the value which should get transformed. So we need to get the value here, which is of type any, and then we would receive a list of arguments. Now, for now, our pipe here doesn't take any arguments, so I will omit any other arguments here in the transform method, so we only receive the value. Now, to shorten this value, a quick and easy way to do this would be to return, and this is important, transform always needs to return something because a pipe is just, you put something in, you get something out, so you need to get something out, otherwise it won't work. So here we want to return a new string, and this new string should be the old value, but somehow is shortened. And we could simply use the substring method, substr. This is a built-in method JavaScript offers, where you can define how long this string, the substring you want to extract should be. So you want to start at index 0, at the start of the value, and then let's say we want to have it 10 characters long. This would only give us back the first 10 characters. Again, we can see this if we save it like this, returning this substring of values so that we only get the first 10 characters. Now to use this pipe, we need to go to app module and add it to declarations here, the shorten pipe. So just like components and directives, you also need to add pipes to declarations. Make sure to also add the import pointing to the shorten.pipe.ts file, of course, as always, without the .ts at the end here. Now with this added, we make this pipe available, and then we can go to our app component and use it, I'd say, but how would we use it? Well, we have to go back to the shorten pipe first. This class is implementing the interface we need to implement, but it lacks one important thing. We need to add a special decorator, the pipe decorator, which is also imported from @angular core. In the pipe decorator, you can specify the name for the pipe by simply adding name and then, for example, shorten. Now by setting it up like this, you can now go to your template and on the server instance type, which is, on the server name here, we simply add a pipe symbol and now shorten our own pipe. Now, if we do this and save, you see it gets cut off, and if we count the characters, this looks like 10 characters. So now our shorten pipe is in use. It's not super pretty though. So we can improve our pipe, and this is now something which is not really related to pipes. I'm simply adding a new string to my shortened string, and this will simply be 3 dots and maybe a blank space in front of it. So now the shortening should look a bit prettier because now we cut it off, though we always see the 3 strings. So another improvement might be to first check if if the string is really longer than 10 characters. So here I first check if value length is greater than 10 characters, because only if it is greater, only in this case I want to shorten it, otherwise I will return the unchanged value. So now in this case, you see if this reloads, it shortens all these names. But if we were to remove the server here and the blank space on the first server so that it's just called production, therefore it just has 10 characters, you see now we don't have the 3 dots here because we improved our pipe. But this is all pure JavaScript tuning, not really related to pipes. The important part about pipes is that you A, add this pipe decorator, B, make sure you have the transform method, possibly enforced by adding the pipe transform interface, which is a good idea, which is a good practice, and C, by adding your pipe to the declarations array in your app module. And with that, you're good to use your own pipe and to create your own pipes and adjust them to your needs. Now let's improve this pipe in the next lecture. In the last lecture, we created our first pipe, the shortened pipe, and it's already working quite well. But it would be nice if we could allow the user to specify the number of characters at which point you want to shorten the pipe, or shorten the value. Right now, we're always using 10 characters as a limit. This is hard-coded into the pipe, and this might not be the best pipe you can build. Instead, it would be nice if we would receive a second argument in the transform method, the, let's say, limit. And this should simply be a number. Now, limit would be what you then use here in the check. So only if it's greater or if it has more characters than this limit you want to shorten it. And then, of course, you use limit here in your substring method too. Now with this little change, you allow the user to pass a parameter to the pipe, because now you receive a second argument in the transform method. And since you receive this second argument here, the user may pass one parameter to the pipe. You don't need to change anything else, don't need to change anything in the decorator. This is all. Now with this we can go to our app component. And if we would leave it like this, you see it's not shortened at all because we're not passing any limit. Therefore, it's undefined. Therefore, we always fail this check whether it is too long. Therefore, we always return the original value. But if we do pass a parameter, and remember, we do this by adding a colon and then the value, let's say 5. If we do this and save this, now you see we're shortening after 5 characters. And if we pick 15, now you see the first 2 names go through quite well because they are short enough, but these last 2 names are shortened. And this is how you can, of course, add multiple parameters. You would add another parameter simply by adding another argument here. So this would be another arg of the type you want it to be, whatever it is. And then with that added, you could simply add another colon and your second parameter. This is how you parameterize your own pipes, and of course you could also chain them with built-in types and so on. You can use it like a built-in pipe. It's just your own pipe. So this is awesome. Let's now move on to an advanced use case and to some limitations you might face when using pipes. In the last lecture, we created our own pipe and we also allowed the user to pass a parameter. Now I want to create another new pipe because I want to show you something which might look strange at the beginning. Let's add a new element here above our unordered list, and this should be an input field. So input of type text. I want to allow the user to filter our service, for example by status, so that once you type stable in there, you only see service with the status stable. So therefore I need this input text field. And I want to use two-way data binding to bind it. So ng model and bind this to filtered status, for example. This, of course, would be a new property I set up here in my component. So below all my servers, I have filtered status, which is an empty string at the beginning, filtered status like this. So if we save this, we should see this new input field here at the top. Let's maybe add a horizontal line below it just for styling reasons. And with that, we can enter something here, but of course, this does not do anything. Now I want to build a pipe which I can apply to this list somehow, which allows me to then only view the servers which do indeed fulfill the requirements here. So to do this, I will add a new pipe here. And for this, I will now use the CLI. So ng generate pipe would be the shortcut here, or just gp, and then the name of your pipe, and I will name it filter pipe. So by typing filter, this gives me also a testing file, which I don't need, but then the filter pipe here. And there you can see it also pre-populates the name here in my add pipe decorator, and it gives me this interface and, well, gives me this transform method in its most basic form. So in here, I want to allow the user to filter, and I will indeed get an argument, the first argument of this list of arguments. This will be what the user entered. So the filter string, you could say, and this will be a string. Well, and then here I want to implement some logic which allows me to only return the elements of the array which fulfill this argument, or which fulfill this filter string here, where the status of the server matches this filter string, to be precise. For this, I will first of all check if value.length, and value will here be the array of servers. It doesn't have to be a string. This is the first important takeaway. It can also be an array here, can be any data you output in the end. So here, I want to check if the value length is 0, so if it's empty. In which case I will just return value, so I will basically just quit. There is nothing to display. And now after checking this, the interesting part happens. Here, I simply want to check, or I want to loop through all my items in my value, and value here will be an array, keep this in mind. And then I want to check if my status of each server matches the filter string up here. So for this, I can simply check if item.status, and of course you could write this more generic and pass the to be filtered property here as a second argument, like prop name, which is a string, and then you could simply say item prop name in square brackets. So if this equals my filter string, only if this is equal, only in this case, I want to return it. So I should add a new result array. This is an array I will use temporarily here. And I will push new items on this result array. So I will push any items on this array which fulfill my criteria here, which are, or which have a status or a prop name in general, equal to my filter string. So here I will then push item on this array and return this result array in the end. And therefore, this result array will only hold the items where the prop name I pass as a second argument here, or as a third argument actually, where this prop name or this value of the prop name is actually equal to my filtered string. Now with this, the pipe is finished. You have to make sure that it has been added to app module. The CLI did this automatically here for me. If you created it manually, make sure that you add filter pipe to declarations and add your import at the top. And then in the app component, we apply it here in the ng for loop. And this might sound strange because before we only used it in string interpolation. But keep in mind that I said at the beginning of this module that pipes transform your output. And the ng for loop is simply part of your output. Therefore, of course, you can add a pipe here too to my servers. And then I simply say filter. Of course, we need to pass two parameters here. The first parameter is the filtered status, this property which holds my string for which I want to filter. And the second argument is my prop name, so this will be a string. And this string should be status because I want to filter on the status property. Now if we save this and reload the app, you see no servers are displayed by default because no servers match this criteria. If I type stable here, you see we see the stable server, but that doesn't look correct because we should have more than one stable server. If we have a look at our app component, we get 3 stable servers. So we only view the first one, and the reason for this is simply that right now, here, I'm returning inside of this for loop, so this is a little logical mistake here. We should of course return outside of it and also create this array outside of it, like this. So, with this change in place, now we should see that once we add stable, we see all stable servers, and once we add offline, we see the offline server. So our filter pipe is now working as expected. Now, if we wanted to see all servers, we need to adjust this code that in case our filter string is empty, so we could add this here as an OR condition at the top. If filter string equals an empty string, that then we see all servers. And now we are able to filter for whichever servers we want to see. This works great, but there is one issue we will dive into in the next video. In the last video, we created this filter pipe here, which allows us to filter our servers for their state, and it seems to work great. We do have a certain issue with it though. If we allow the user to add a new server, and I will quickly add this functionality by going to my template and by adding a line break and then a button with the classes button and button primary, where I say add server, which will execute a new method on add server like this. And then in the app component, I will quickly add this method on add server. And here I will simply take my servers, push a new server on it. And of course, this will just be a generic server here, which will have the instance type of, let's say, small, a name of new server. Let's keep it super simple here. A status of stable, and started could be new date and then the same date as all the other servers here. This is not the recording date as a side note, just like or how the way you want it. So with this, we are able to add a new server. And if I now click on add server, you see it's getting added here. If I filter for stable though, and I hit this button, you don't see it getting added here, but it is there. You can see if I remove the filter altogether. So I added a couple of servers and now we can filter for them again, but they weren't added whilst we had this list filtered. And this is actually not a bug. I'll quickly reload this and filter for stable again so that we can see this. If I hit enter here, as mentioned, it's not getting added, but it's there. We can see as soon as we clear our filter. Now, the reason for this behavior is that Angular is, thankfully I should say, not rerunning our pipe on the data whenever this data changes. So as soon as we change what we enter here, and even if we would only add a blank space and then remove it, we would update our pipe again, as you can see. So adding the input, or excuse me, changing the input of the pipe will trigger a recalculation, will trigger the pipe being applied to the data again. But changing the data won't trigger this. And this is a good behavior because otherwise Angular would have to run this pipe or rerun this pipe whenever any data on the page changes. This would be really bad because that would cost a lot of performance, and this is also the reason why no built-in filter pipe exists, because filtering, you would say, is a pretty common task, but the Angular team decided against adding such a pipe because you typically have a high performance cost if you want to enforce it being updated even if you are in filter mode. So by default it doesn't work here, but we can force it to work. But again, be aware that the following change will make sure that whenever we change data on the page, our pipe is recalculated, you could say. So this might lead to performance issues, so you should know what you're doing, which is why I'm really emphasizing this. You can force this pipe to be updated whenever the data changes by adding a second property to the pipe decorator. It's called pure, and you can set it to false. By default, this is true and doesn't need to be added. Now, if you do this and the app reloads, let's filter for stable servers and add new servers. And now you see they get added here too. The reason simply is that the pipe now gets recalculated whenever data changes, and as mentioned before, this can lead to performance issues, but might be what you're interested in. So it is fine to use it. This is what this pure properties, therefore you can set it to false, which basically means this is not, you could say, purely focusing on whether the pipe arguments changed, but now it will also be recalculated whenever anything changes on the page. And again, this might be a bad behavior. I'm just emphasizing this because it's so important to understand. But if you know what you're doing, if you do need this behavior, definitely go ahead, set pure to false, and you are good to go. And with that, we now get a working filter pipe with this little downside of potentially hitting performance issues if we have a very long list here. In this module, we learned a lot about pipes, what they are, how to use them, how to parameterize them, how to chain them, how to create our own pipes, and how to maybe create an impure pipe forcing update on each data change. Now there's one built-in pipe I want to have a closer look at, which does something different than all the other pipes. It helps us with handling asynchronous data. And to demonstrate how this works, let's say we have another property right here at the top, which says app status, or which holds our app status, which could also be offline, critical, whatever. But here, this will not be a string like offline. Instead, this should get loaded after, let's say, 2 seconds. And to simulate this, I will set this equal to a promise. And you can imagine this data being returned from a HTTP call, from a server, something like this. So in this promise, I will initialize this promise with a callback method passed to the constructor, where this method itself takes 2 arguments, resolve and reject, the 2 functions we can execute inside of this promise to resolve or reject the promise. And in the promise, in this callback function, I will then set up a timeout. Let's say it triggers after 2 seconds, so after 2000 milliseconds. And then this method here will get executed. This method I pass to the setTimeout method. Now here in this function, I want to simply set my app status. So I want to resolve to, let's say, stable, whatever the status should be. So what this will do is it will set app status to stable, but only after 2 seconds. So if we try to output this app status here, let's add a line break or another line break to have a blank line in between, and then a heading where I say app status, and then I try to output app status with string interpolation. If we do this, you see object. And this is correct because it is an object. It's a promise, and a promise is an object. But after 2 seconds, we know that this is no longer an object. It now is a string. But Angular doesn't know, because it doesn't watch our object. It doesn't see if this object actually transforms to something else or if this returns as a value. It just knows it's a promise, I'm done. And it's good that it behaves like this, saves us performance. We should be explicit about how our app behaves. But thankfully, there is a nice little pipe we can use here to make the transformation of this data easier. We know that it will be a string after 2 seconds, and we want to output this string. Or it will resolve a string after 2 seconds, I should say. And we want to output this string. So we can add the pipe symbol and then async. This is a built-in pipe, and by adding it, well, watch for yourself. You see, I will reload the app. There's nothing there at the beginning, but after 2 seconds, you see stable. And this is what async does. It recognizes that this is a promise, and as a side note, it would also work with observables. There it would subscribe automatically. And after 2 seconds, it will simply recognize that something changed, that the promise resolved, or in the case of an observable, that data was sent through the subscription, and it will print this data to the screen. And this is the pipe with which I want to conclude this section about pipes. Now you should feel really comfortable about using them, building your own pipes, and as you see here, working with async data with pipes. Now we will see this async pipe being used in the HTTP section later, but for now, let's move on to some exercises regarding pipes. One important note at this point, my IDE changed slightly here. The only reason for that is that I switched the IDE because I had to re-record these modules where you see the new IDE, which does not mean that the other modules are old or outdated. It just means these modules here needed an update to be up to the quality standards I want to enforce and to teach you the latest of Angular. If you see videos with a different IDE, then these videos still are perfectly fine. That's the only reason for that change. I hope it's no big problem. The project, of course, is exactly the same. The folder structure is exactly the same. You will only have some tiny visual changes. Time for some exercises. I got 2 tasks for you in this assignment. The first task is to build a reverse pipe, which basically reverses a string. You could, for example, then reverse your instance type, medium, large, small, something like this. Not super useful, but a nice practice. So I want you to build this pipe, this reverse pipe, and just as a note, there is a reverse method in JavaScript you can use, but it only works on real arrays, not on a string, which technically is an array of characters, but there it won't work just like that. You would have to split the array by an empty character first, the string I should say, by an empty character first, then apply reverse, and then join it together with an empty character to get a string again. So this is the first part of the assignment. The second part is that I want you to sort this list, to build a sort pipe, which sorts this list by, let's say, the name of the instance, production, user database, and so on. I wish you fun with that. In the next video, we will view my solution, how I solve this. So, were you successful? Let's start with the reverse pipe. I will generate it with the CLI, with ng-gp, and then reverse like this. And this will automatically add it to app module and also add the import. So make sure that you add this manually if you created the pipe manually. Then I will remove the test file and add reverse. We don't need the argument because we won't parameterize our pipe here. But the thing I want to do here is, instead of returning null, I want to return the value, then as mentioned, split it by an empty character to get an array, then reverse it, and then join it together with an empty character. This will simply reverse a string. Well, and in my template, I can now apply this to, let's say, the instance type. And it doesn't matter if we do this before turning it to uppercase or after. So you can place it at either of the 2 positions. I will do it after turning it to uppercase. Here, I will call reverse. Let's save this and view our result. And this looks good. We reversed our statuses here, or not our statuses, our instance types. So might not be super useful, but a good practice. Now let's create the sort pipe. For this, I will repeat the pipe generation command, but now with sort to create a sort pipe. Get rid of the testing file. Again, this is added automatically to app module, to declarations, and as I import by the CLI, make sure to add it manually if you're not using the CLI for generation. And then here in this pipe, as mentioned before, I actually want to sort my values here. And I assume that I get the prop name passed as a string, the prop name by which I want to sort. Again, this is optionally, you could also hard code it into the pipe here. Now let's return value. And as mentioned, there is a built-in sort method you can use. Now this sort method should allow you to sort this array. But in order to be specific about how to sort it, we need to pass some argument here. This is a ordering function, which will simply get 2 arguments, for A and B, for example. And then in the function body, we determine on how we want to compare it. This function will be called by JavaScript automatically. It will pass the arguments automatically, where the arguments will be the items in the array in this case. And then here we simply need to define how are these two items compared. And I know that I want to compare them by the name, so by the property we pass here. So here we can simply check if a prop name, so if the value of this property is greater than b prop name. In this case, and this will work for strings just fine, I can return 1, which means this is greater, this should come first. Otherwise, I will return -1. And this is important, your sort function, the function you pass to sort here, needs to return 1 or -1 or potentially also equal. To say they are exactly equal, then you would return 0, I will leave this out here, or 1 is bigger than the other, in which case you return 1, or 1 is smaller than the other, in which case you return -1, and JavaScript will handle the rest and put them into the right order. So this is the sort pipe, as mentioned, it has already been added. So now to sort it, I will apply this to my servers here, and we already filtered them. So on the filtered servers, I will add the sort pipe, and I want to filter for the name. So let's save this and reload, and now you see it's indeed filtering by name. So the server with D at the beginning comes first, then we have P, T, and U. Now if I add new servers, you see they are added at the end, even though they should be inserted in between, because a server starting with N certainly doesn't come after U. It's alphabetical, it's ordering here in the end, right? This of course is again related to this impure pipe thing, because we need to add pure and set it to false to enforce this pipe to being able to reapply to this array whenever this array changes. So now if we add something, you see it gets added in between, just like we had to do it for the filter pipe with the same disadvantages. I want to highlight this, but again, if you need this behavior, here you go. So 2 tiny little exercises. I hope they were useful. See you in the other modules. Bye. Thus far in our application, we always worked in the browser only. That means that we control all our data with Angular, we store our data somewhere in memory in the browser, and it also means that whenever we restart the application, all our data is gone. It also means that we can't persist data anywhere, and of course a typical requirement of an application you're building would be that the front end, so the part that runs in the browser, which is your Angular app, that this does not work standalone, but that it is able to communicate to some server, to store data there, to fetch data from there, to do whatever you need to do in your application. And that is exactly what we'll have a look at in this module. We'll learn how Angular communicates with a backend, with a database, and so on. You'll learn how to send HTTP requests and also how to transform data if you need to. You might remember that Observables section where I gave you a first introduction to that. Now we'll take a closer look. So how does Angular connect to a database, or how do you connect Angular to a database in your application? Well, of course, it is a use case that you will often have. In your Angular app, you generate data like posts or recipes or whatever you have in your application, and you want to store that data in a database and also fetch it from there when your app restarts, when a user revisits your page, and so on. And it doesn't matter which kind of database we're talking about, if that's a SQL or no SQL database, doesn't really matter. The thing is, you don't connect Angular to a database directly. That means you don't enter your database credentials into your Angular app or anything like that. This would be highly insecure because everyone can read your Angular code. Since it's a front-end JavaScript application, everyone can inspect the code there. And that is fine, but that also means you must not store credentials in there, for example. And you will learn how you can still authenticate users and so on later in the authentication section, but you definitely don't want to store database credentials. For more information on how secure your JavaScript code is, you can have a look at an article in a video I attached to this video here. So if we don't connect directly to a database, what else can we do then? Because we certainly don't want to have our standalone, independent, unconnected Angular app. Well, you send HTTP requests and you get HTTP responses to and from a server. A server, in the end, is defined as an API here. That means it is, for example, a REST API or a GraphQL API you are communicating with. And in this course, we'll use a REST API, which is the most common form of API you work with. Now, such a API, in the end, is almost like a normal website, but when you visit its URLs, you're not getting back HTML, but you're getting back data, mostly in a JSON format. And if you want to learn more about REST APIs in general, you'll also find some helpful resources related to that attached to this video. And I have a whole course, my Node.js course, where I also teach you how to create such APIs. Because you don't use Angular for the creation of these APIs, you use server-side languages like Node.js or PHP instead, but you can communicate with these APIs with Angular. And on that server, you then can have code that does interact with a database to store and fetch data. And of course, there are more reasons for communicating with a server than for storing or fetching data. It's not just about database access. You could be uploading files, or you could be sending some analytics to a backend, or any other reason for why you might need to talk to some backend server. Now, in this module, we will not write such a backend from scratch, since this is way beyond the scope of the course and totally not Angular's job. But I will show you how to use a free dummy backend, which could of course be replaced by any real backend you have, to send requests, to use responses, and so on. Before we start sending requests, it's important to understand the anatomy of an HTTP request. Because a HTTP request is made up of a couple of core parts, which we'll all have a look at in this module here when it comes to configuring them when sending a request. The most important part about a request, of course, is the URL you're sending the request to. That's also called the API endpoint. And it is something like yourdomain.com/posts/1, for example. The exact path here, of course, depends on the API you're interacting with. However, when communicating with a RESTful API, it's not just about the URL, but also about the HTTP verb you're using. Something like post, get, put. This defines which kind of request you want to send to that endpoint. Do you want to store new data? Do you want to fetch data? Do you want to replace existing data? The HTTP verb makes that clear. But it always depends on the API you're working with, which endpoints and which verbs for these endpoints are available. So the official docs for the API is always the place to go, unless you're, of course, writing your own API, in which case you, of course, know which endpoint supports which operations. Now, when we're sending a request, it's nice to know where and how to send it to that place, but you often also need to set additional metadata, the so-called headers of a request. Now, these are kind of optional, or to be precise, some default headers will be appended to a request for you by the browser and by Angular, but you can also append your own headers, and that is therefore also something we'll have a look at. Now, last but not least, for some HTTP verbs, you can also add a body to your request. That's the core data that is attached to a request. For example, if you're sending a post request to create a new piece of data on the server, well, then of course you should attach the information about that piece of data to your request, and you would do that in the request body. Therefore, a request body can be set on post, put, and patch requests, which are requests that do alter data on the server by adding or replacing it. Now that's the general anatomy of a HTTP request. Let's now have a look at how Angular helps us with writing or with creating such requests, how we can work with them, how we can work with the response, and what else Angular has to offer. Now let's dive into using Angular's HTTP features. And for that we need a backend. Now, as I mentioned before, we'll not write our own server-side solution here, because you would do that with a server-side language and not with Angular, and therefore this is of course not the scope of this course. By the way, if you want to see how to build a complete Angular frontend and a custom backend, my mean course, which you also find here on Udemy or on my page, academine.com, is a great place to go. But here, we'll simply use Firebase. Firebase sounds like it's a database only. Instead, it's a whole backend solution, which gives us a REST API as well. And it's a perfect solution for this course and this module because it's free to get started with, and we can send requests there. We can send different types of requests. We can easily see the changes we make through these requests, and we can store data there, and therefore it's perfect. Now, you need a Google account for that. Once you got that, you can go to the console on firebase.com. And there, simply click on Add Project. Now give that project any name you want. And you can leave the other default settings and then check both check marks here. Now this will create a new Firebase project for you. And again, getting started here is free. You can of course check the pricing pages of Firebase to learn what else you can use for free and when it would start cost money. Now, once this is loaded, you'll see an interface that looks something like this. And here we'll go to database. Now again, Firebase is not just a database. It's a complete backend solution that also offers a database, but it's not just a database. It's not an alternative to MongoDB or anything like that. It's more than a database. It's a complete backend service. Now here, we'll not use Cloud Firestore, but instead, if you scroll down, we'll use that real-time database. It's a bit easier to use and gives us a nicer visual feedback. So click on Create Database here, and important, start in test mode. That's important. Later, we will add authentication, but for now, we'll use that test mode to be able to send requests and work with data without being restricted. Normally, you are, of course, protecting against unwanted access. Here, we are temporarily disabling this so that we can interact with that without issues. Now, and that is our basic setup we'll need. The URL you see here will already be the URL you can send requests to. So let's do that, and let's make sure that we now use that to store data by sending a post request. Now attached you find this project here. It's an Angular project which I opened here. A very simple project where we have a form, a template-driven form, where we can enter a title, content, and then send that post here, like a very simple post in a simple block, to store it on Firebase. And later we also want to add logic to fetch all posts that we stored on Firebase and to clear all posts there. But for now, let's go with creating a new post. And for that, if we have a look at our code, you only have the app component, and there in the app component TS file, you have onCreatePost, which will actually get some post data in this format. Now, let's first of all log that to validate that this is correct and that this works. For that, I opened the developer tools here. And now let's write a new post with some content and click Send Post. And we see that here. So this seems to work. That's perfect. Now, of course, we could reset that form here too if we wanted to, but I'm fine like this. The goal now, of course, is to not just log that here, but to instead send an HTTP request, and for that we need Angular's help. To be precise, we need to unlock a new feature, so to say. In the app module, we have to add a new core Angular module, or a new module baked into the Angular framework, I should say, which is the HTTP client module. For that, you simply import HTTP client module here from @Angular common/HTTP. So that package name is @Angular/common/HTTP, and you import the HTTP client module. Now you add that HTTP client module here in your imports array. Just like that. This now unlocks the HTTP client Angular offers in your whole project. And with that, we can now start sending requests in our app component here. In there, we now just need to inject our HTTP client, and I'll store it in a property which I just named HTTP. And it's the HTTP client which you need to import from @Angular/common/HTTP. So make sure to add this import at the top of your path. Now with it imported, we can use it to send HTTP requests. And how does this work now? Now let's say here in onCreatePost, once we got that post data, we want to send it to Firebase. For this, we can use that injected HTTP service, and there you have a couple of methods. These methods are mostly named like the HTTP verbs. So you have get, you have delete, you have post, and that will allow you to send different kinds of requests. Now here, since I want to store data, I'll start with a post request. Now you call this method and it takes a couple of arguments. The first argument is the URL you want to send this request to, and that is the URL you can find in your Firebase real-time database, this URL, or at least this URL is a part of the URL we'll send the request to. So paste that in here, but this is not the entire URL. Now, on a custom or on different REST APIs you're communicating with, you would have clearly defined endpoints like /posts, add, or something like this to which you have to send your requests, and the official docs of the API you're working with would tell you which API endpoint to send the request to. For Firebase, it's a bit differently. You have this starting point URL here, and then you can add your own segments after that, and this will get replicated as folders in this database, so to say. And this looks like you're directly talking to the database, but keep in mind that Firebase only abstracts this away from you. You are still communicating with a REST API provided by Firebase. They just translate your path you're sending it to a folder structure in your database. You're not communicating directly with the database here. And I'm stressing this because it is important to keep in mind that you never communicate directly with a database from inside your Angular app. So let's say here, we want to have a node, a folder, so to say, named posts. Well, then we would simply add posts as a segment here. And important for Firebase, you need to add .json. This simply is a Firebase requirement. It's not an Angular requirement, not a REST API requirement, only a requirement by that Firebase REST API. This now allows us to send a post request to that URL. Now, since it's a post request, it doesn't work just like this, however. A post request also needs a request body. Now, this post method here works such that it takes more than one argument. It has at least two required arguments, the second argument being the request body. So we pass one additional argument here, and that could be our post data, so the data we want to store, this data. Now, very important, you normally send JSON data when interacting with a RESTful API. And actually that will happen here as well, but the Angular HTTP client will take our JavaScript object here and automatically convert it to JSON data for us. So it will still send JSON data, and we'll see this in a second when we inspect that request in the browser developer tools, but Angular will transform this automatically for us. Now with this, we have a request that should work. It has all the core data it needs, the URL and the request body. And for now, we don't need to set any other data. Now let's save this and let's give it a try, shall we? So let's go back to our application, enter some content here, and click Send Post. Did something happen? Let's check Firebase. Well, I don't see any data here, and we would see it here. Let's check the Network tab. So in the browser developer tools and the Chrome developer tools, go to the Network tab here. You see a bunch of network requests actually. These are all the files that are downloaded as part of your Angular application, and all the JavaScript files and so on. Let's clear that. Let's simply send another post, and we don't see any request here. So somehow this request is not being sent. And that happens on purpose. Angular heavily uses observables, as you already learned. And HTTP requests are also managed via observables because they are a perfect scenario or use case for observables. We can wrap them and we can then subscribe to them to get informed about the response and to handle errors and so on. The thing just is, Angular is smart, so to say. If you're not subscribing to that prepared HTTP request, you could say, so to that observable that wraps your HTTP request, if you're not subscribing to it, then Angular and RxJS know that no one's interested in the response, and therefore the request doesn't even get sent, because if no one's interested in the response, then it won't send the request. So post indeed will return an observable, as you can also see here. It does not give us the response or anything like that as a return value. It gives us an observable that wraps your request. And to get access to the response, you have to call subscribe here. And this will then be your response data actually, because Angular, the HTTP client I should say, will do even more than just giving you the response. It will automatically extract the data attached to the response, so the response body, and give you that, though you also have ways of accessing the full response, as you'll learn later. So for now, let's simply console log that response data to get a feeling for whether that works and what we get here. So let's save this, and now with the subscription set up and with us subscribing here, by the way, you don't need to manage the subscription and unsubscribe because it will complete after being done anyways, and it's an observable provided by Angular for which you never need to manage subscriptions. But that's just a side note. So now let's simply test this. Here, let me clear all network requests again. Well, actually, let's first of all open the console again. And let's now try this again. Send a post. And now we get a log here, which looks good. Let's ignore what's in there for now. It's a JavaScript object. We can see that, but it has a name and then some cryptic key here. Let's have a look at the network tab. And there we also see that request now. We actually see 2 requests even. 2 requests to the posts endpoint. Now, that's just a characteristic of browsers. When sending post requests, so not to /posts, but of type post, then they always send 2 requests. The first one, if you click on that, is of type options. That's a different HTTP verb that will, first of all, check whether the post request is allowed to be sent. And if that gets a success response, it will send the actual request, which is this one. And there you see that was of type post. This was the URL it sent it to. It succeeded. These are the response headers we got back by Firebase. And these are the request headers we sent. And for example, this one and the content type headers were added automatically to the request sent for you by Angular. You didn't add these headers, they were added by Angular. And here in the request payload, you also see that JSON data that was attached for you. You can also, of course, see the response here, which is the response we logged to the console. So this is how we send HTTP requests. And besides the general syntax, the core takeaway is that requests are only sent when you subscribe. So requests are sent with the post method, and we do only send them when we subscribe. Let's ignore the data we get back here for now, and let's now add another request that actually gets us all the posts. And for this, I'll add a new private property in here, which I'll name fetch posts. And in here, I want to again use the HTTP client and now the get method and send a get request to that same URL we used for storing the data, because that is the URL from which we'll be able to get that data. Now, before we actually go further, let's have a quick look at Firebase. And there you should now also see that posts node here. And in there you have that cryptic key again, which is an automatically generated ID by Firebase, by the way. That's a convenience feature by Firebase. It generates such IDs for you. But if you expand this too, you see your data. So now the goal is to fetch that data. We want to fetch all the posts that were created. Therefore, we're preparing this get request. And now, since this is a get request, this also needs no second argument, because get requests have no request body because, well, you're not sending any data. You're instead just requesting data. One thing you need to do here too, however, is you need to subscribe. No subscription, no request. So you need to subscribe here, and we should get back our posts here. That's the hope. So we get back our posts here, and we can then console log posts to get an idea of what we're actually getting back. Now I put this into that fetch posts method because we can now call this from 2 different places. From in on fetch posts here, where I now just call this fetch posts. But I also want to call this from inside ng on init. So whenever this page loads, whenever this app loads, I want to fetch posts. And this should therefore call this method and send this request. Let's save this, and this will reload the page and should now already send such a request. And indeed, here is some data we get back. And it looks like we're getting back a JavaScript object, which has one key value pair in our case, where the key is this cryptic key, this cryptic string. And the value of that is the original object we stored. So it's a nested object here. That is the data we originally sent to the back. And this is the data we are getting back. Now, that of course means that if I want to store all my posts in an array here, through which we then can loop to output that, we would need to transform this object here, because it's a JavaScript object, to an array, and we need to transform that data. Well, that screams for observable operators. Transforming data is, of course, something we could also do here inside of subscribe, and that would generally not be a problem. But it is a good practice to use observable operators because it simply allows us to write cleaner code with different steps we funnel our data through that can easily be swapped or adjusted, so that you have a lean subscribe function here and have other steps that focus on other parts. Therefore, here, before we subscribe, we can now call pipe, because pipe, as you learned, is a method that allows you to funnel your observable data through multiple operators before they reach the subscribe method. Now, the operator I need here is the map operator, and therefore I will import map from rxjs/operators. The map operator allows us to get some data and return new data, which is then automatically re-wrapped into an observable so that we can still subscribe to it. If it would not be wrapped into an observable again, we could not subscribe. So let's map here. Let's add map as an argument to pipe, and map is a function which we call, and that function now again takes another function as an input, a function which will get our response data, and that should now return the converted response data. And here the idea is that we return an array of posts instead of an object with that cryptic key, which then holds our actual post. Now, to convert a JavaScript object, which we have here, to an array, we have to manually loop through all the keys and create a new array. So here I'll create a new post array constant, which is empty initially, and then I'll use a for in loop to go through all my keys in response data, which I know will be an object, and then I want to push each piece of data into my posts array. So here I will then use posts array and push response data key, so I'm accessing the key we're currently looking at in response data, and therefore I'm accessing the nested JavaScript object, and I'm pushing that nested JavaScript object into my posts array. However, I don't just want to push that object like this in there. Instead, I want to push a new object in there. So let me add curly braces, and let's use the spread operator now. This will pull out all the key value pairs of that nested object we're accessing here. And let's close this with curly braces too, because this now allows me to also add one new key value pair to that object we're adding to posts array. And that should be an ID field, which actually stores the key. Because that key here, that cryptic string, is a perfect ID, and it is a unique ID generated by Firebase. Therefore, of course, I want to keep that so that we have this, for example, if we wanted to delete a single post or anything like that. So now we're pushing this new object into our posts array here. Now, it is a good practice to wrap this with an if statement if you're using a for in loop, where you check if response data has key as its own property, so that you're not trying to access the property of some prototype. And with that, posts here now really is an array of posts. And now we only need to make sure that we return posts array here in map, so that this is now forwarded to our subscribe function. With that, if that now reloads, indeed here we see we have an array, we have square brackets, and in there we have an element which has a content, the ID we added, and the title. And this is how we use observable operators to transform our data. The next step now, of course, is to output our posts. Before we do that, however, let me bring your attention to a tiny problem we have here, or to a spot where we can improve our code. If we hover over posts here, in your IDE, you probably see the type of posts, and you see that this is of type any. That, of course, means the TypeScript is not able to detect how our posts look like, the format of our posts, because here posts array also is of type any. Because the only thing TypeScript sees is that we add the ID key here, but other than that, the object we push is totally unknown to it because it doesn't know the format of our response data. There it only knows that it's an object, but not how this object looks like. We can tell TypeScript how it looks like. One way of doing it would be to assign a type here on the argument we're getting in map. So we could say, yeah, we know that this actually will be an object where we have a randomly generated string. And now this syntax can look really weird in TypeScript, but in the end, you use a placeholder property name for that by using square brackets here. And then you add key colon string in there, which simply means this is any string key we have here on that object. We don't know the exact property name because it's randomly generated, or not randomly, but it's generated by Firebase, and we do have many different properties, but we know it will be a property that can be interpreted as a string. And now the value held by that property is our actual post data, right? It's the same format we have here. Now, therefore, to simplify this a bit for us, we can, of course, add a new model, let's say a post model here, where I export an interface, and I'll name this post. And this will just have that format here, title and content. And actually will optionally also have an ID. Let's add a question mark here to make clear that this is a string, but it's optional. And now we can use that here. So there we use post. We just need to import that. So let's import post from our post model file here. So from /post.model. And now we know here we have that randomly generated ID, but that will then hold a post as a value. That's that nested element I showed you in the developer tools earlier. With that now, TypeScript suddenly knows what's inside of response data, and now we can also set the type here on our posts array and say, yeah, that will be a post array, which you set by using this type assignment, the name of the type and then square brackets to indicate that it will be an array of these types. This now is improved code because now we can clearly understand what's inside of posts array, and we get better auto completion. For example, if I try to access the first element, you see I can now access ID, content, and title because I now know that it has this format and that therefore is a recommended practice. However, with the Angular HTTP client, there is a more elegant way of assigning the type. You don't need to do this here on the argument in map or in subscribe or whatever you're using to access your data. Instead, the get method is a so-called generic method. This means you can add angle brackets here, and between the angle brackets, you store the type which this response will actually return as a body once it's done. So it's the response body type which you store here, and that will then automatically be handled by the Angular HTTP client, and TypeScript understands this and now knows that the response data will have this type format, as you can tell. And this is also available on post requests. It's available on all requests. You can use these angle brackets to add this extra piece of information, which is totally optional, but recommended and helpful about the data you're getting back. And now here, you know, it'll be a JavaScript object where you have a name property, and the value of that will be a string. Because if you remember, when you send a post, this is a new post, really new. The data you get back is exactly such an object, name property, and then a random string. And now we're making this really clear here so that we also notice in our subscribe function. And if we had code that depends on the types, we get better auto-completion and avoid unnecessary TypeScript errors. So this is optional, but recommended. You can define the response data types here on these generic HTTP verb methods. Let's now output our data now that we're fetching it. For that, when we're getting the data, instead of logging it, since we now transformed this into an array of posts, we can set this loaded posts, which is our property I created earlier, where we now also can be more explicit about the type it will store, because that will be an array of posts, of course. We can set this loaded posts here equal to the posts we fetched. Now we just have to use loaded posts in our template. And for that, of course, in this area where I say no posts available, I only want to say that if we really have no posts. So I'll add ngIf here and check if loaded posts length is smaller than 1, which means we have no posts. If it is longer than 1, then I want to output an unordered list with a class of list group, which is a bootstrap class, which has list items with list group item as a class. And in there, we'll have a h1 tag for the title and a paragraph for the content of the post. Now I want to only show this, of course, and hence I'll add ngIf on the unordered list if loaded post length is greater or equal than 1. So it's the opposite of this condition here. If that's true, we'll show the list. And now I want to loop through all the loaded posts and recreate a list item for every loaded post. So here I'll add ng4 to go through all my posts. So I'll name this post of loaded posts. And then here we can output post title. And for the paragraph, we can output post content. Let's have a look at whether this works. If this now reloads, it fetches the posts, and you see thereafter these posts appear here. Now maybe the heading is a bit big. Let's maybe use h3 here. But the important takeaway is that our data loads, of course. Now that is super awesome. And this shows us how we can make the step from loading the data to outputting it in our front end. We're now outputting our loaded posts. We can refetch them here by clicking fetch, though we of course don't really see a difference here because we fetch the same posts and we have no indicator for whether a request is currently on its way or not whilst we're waiting for the response. Would be nice to have such an indicator. And that can be easily implemented by adding a new property, which you could name isLoading, which initially is false. And you want to set isLoading, or maybe let's name it isFetching because I only want to use it for fetching posts. And you can use isFetching and set it to true whenever you start fetching posts. So here at the beginning of this fetch posts. There you can set this isFetching to true because now we are starting to fetch posts. And once we're done, so here in the subscribe function, we can set this isFetching back to false. Now what's the advantage of this? Well, we can show a loading indicator whilst we're fetching posts. So back here in our template, we want to show no posts available if we have no posts, and also important, if we're not currently fetching. Because if we are fetching posts, then we want to wait for that result and not show no posts available too early. Of course, we also only want to output posts if we're currently not fetching too. So here, I also will output this only if we have posts and we're not fetching. This, of course, means we have a third scenario now, that we are fetching and we don't care about whether we have posts or not. And for this, you could output simply loading or display a nice CSS spinner if you wanted to by using ngIf equal isFetching. Now, let's have a look at that. Let's reload, and you see loading here. And if I click fetch post again, you see loading. Now, unfortunately, Firebase is really fast, and therefore you only see this for a fraction of a second, but you see it does work. And if you had a slower server, you would of course see it a bit longer. The code we have thus far is not bad and it does its job. And if our application were as simple as it is here, it would be perfectly fine. But in bigger applications, and maybe even in this one, we already have a quite big component with a lot of code that is only indirectly related to the user interface. Of course, we want to send a request when a button is clicked and we want to display that response data. But for example, transforming the result, transforming the data, we can do it here. It's not inherently bad, but it is a nice practice to outsource that into services. So that services are the parts in your Angular application that do the heavy lifting, the dirty work, and your components are relatively lean as they can be, and are mostly concerned with template-related work, so with things like the isFetching property and so on. And therefore, let's create a new service now, the posts service here, and I'll create it by exporting a class, posts service, and we need to provide that. And for that, we can use two approaches. We can use @injectable, which you need to import from @AngularCore. And there we can pass in an object and set provided into root, which is the more modern and recommended approach. But you could also provide it here in the providers array of the app module, and this also wouldn't be bad or a problem. Here, however, I will use this approach. Now, what's my idea behind that service? In this service, I want to have my HTTP request methods, so the methods that do the HTTP requests, and I only want to get the responses or the message whether we're done with the request in my front end. So therefore, in this service, I will add a new method, create and store post. You can, of course, name this however you want. And there I expect to get a title, which is a string, and the content, which is a string, as an argument, let's say. And here I want to send my HTTP request. Now, of course, I also want to be able to fetch my post, so we'll add fetch posts here. And there I also want to send a request. Now, of course, I only want to move my code over. That's in the end what I want to do here. So let's grab that HTTP request here from onCreatePost, and let's move it into the posts service here. Now we're sending the HTTP request here. However, for this to work, we need to inject the HTTP service into this post service. So let's add a constructor, and with the help of that constructor, we inject the HTTP client, and we store it in a property named HTTP. And the HTTP client is imported from @angular/common/HTTP. Now, of course, here we have no post data property anymore. I can create that here though, and this will in the end be of type post, and therefore it will have a title and so on, but we first of all need to import our own post model. So let's import post from /post.model. And now to be a real post, we need to set a title property here, which is equal to our title we're getting as an argument. And we need to set a content property, which is equal to the content we're getting as an argument. So the right side of the colon refers to these arguments here. Now that's the post data we're sending. And now we can call create and store post to send that request. So back in the app component, I now need to inject my own posts service, private posts service, like this. And make sure to add that import path here at the top. You need to import post service from there. And now in onCreatePost, I simply call this post service create and store post. I get an error here because I need to pass some data to that method. I need to pass the title and the content. Now I get my post data here, so I access post data.title, and my second argument I send is post data.content. And with that, we should be able to create new posts. Let's add a new post here, the best Angular course, which this one hopefully is. I'm of course interested in your feedback, so I hope so. Send that post. Now we have no logic to automatically update our list of posts down there, but that's fine. We can click fetch posts again, and now we see our post here. So that now still works, but now the logic was outsourced into the posts service. Let's do the same for fetching posts. Let's grab this logic here, and we'll have a problem with isFetching, but I'll come back to this. Let's grab this logic here and move it into fetch posts in the posts service like that. Now, let's remove isFetching and let's remove this loaded posts because we don't have these properties here and we don't really need them here in the post service. isFetching and the loaded posts clearly belong into our app component and not into the service because the component is where we use them, where we want to display them, or where we need them to change what we display in the template. Let's focus on the rest of this code for now. We're missing the map operator, so let's make sure we import that here. Let's import map from rxjs/operators. And with that, we have a request that should work, but we'll still need to fine-tune this later. At the moment, we can get rid of that private method here, of course, and instead, where we previously called this fetch posts, we can now use the posts service and call fetch posts there. So we do that here in onFetchPosts and in ng-on-init. However, what you will see, of course, is that now we have no posts available. Because whilst we're running that code in the service, and indeed you can see that if I click fetch posts, a HTTP request is sent, and we are fetching the posts, whilst all of that is happening, we're not seeing the posts here because we lost the connection between the data we fetched in the service and our template. Let's fix that. Now, to fix that, we have two possible ways of doing that. The first alternative is that we use a subject in the posts service where we next our posts when we got them, and we subscribe to that subject in the app component. And this would be a fine pattern, nothing wrong with that. The alternative, and maybe a bit more suited here, because the subject would be perfect if we have multiple components interested in the posts. That's not the case here. So a simpler and, for this scenario, better solution would be to simply return the result of our get method and of the pipe method thereafter. And that would be our observable. So I don't want to subscribe here. Instead, I only return the prepared observable here in fetch posts. And therefore, right now, no HTTP request gets sent, because as you learned, requests are only sent when someone is interested. So here I'm not subscribing, but now that I return this here, I can and I have to subscribe in the app component. So here where I call fetch posts, I can now subscribe again and I get my posts. And now here we can set this is fetching to false. And I want to set this is fetching to true here right before I start sending the request. And even more importantly, we can set this loaded posts equal to the posts we get back. And this is now the code snippet I can also copy to onFetchPosts. And yes, you could, of course, also outsource this into a separate private method again to avoid this code duplication here if you want to. So now we moved the result handling, so to say, into the component, but the more heavy lifting, the part detached from the template and from the UI, which is the sending of the request and the transformation of the data, that now lives in the service. And this is a best practice when working with Angular and HTTP requests. Move the part that is related to your template, which in my case here is managing the loading status and managing the loaded data, move that into the component, and be informed about the result of your HTTP request by subscribing in the component, but move the rest into the service and simply return the observable there so that you set up everything in the service, but you can subscribe in the component. Now, of course, I'm using a different pattern for creating a post. There I am subscribing in the service, and this can be fine too. If your component doesn't care about the response and about whether the request is done or not, as it is the case here in our application. If the component doesn't care about it, then there is no reason to subscribe in the component. Then you can just subscribe in the service as we're doing it here. But if it does care about the response and the response status, as it does for fetching posts, then having that service component split is great. And now with that, if this reloads, you see the loading indicator again, you see the posts again, and now we have the best of both worlds, and we have a setup which you will see a lot and which you will work with a lot when you're working with Angular. Now that we had a look at how we can send requests, how we can post data, how we can get data, let's finish this basic request sending up by making sure that we can also clear our posts so that we can delete data. And for that, of course, definitely feel free to pause this video and try it on your own first. Try making sure that whenever this onClearPosts method runs, which will happen when we click that Clear Posts button up there, that whenever this method runs, that you send a request that deletes all the posts on the backend. You learned everything you need for that, so here's your chance to pause the video and try it on your own. Were you successful? Well, it's not that hard. It's almost the same type of request we sent before. Now, let's keep the structure of sending the requests in the posts service. So in there, I will add a new method, which I'll name delete posts. Of course, you can name it also clear posts or whatever you want. Now in there, I will use the HTTP client because that is our central client for all HTTP requests we want to send from inside our Angular app. And there we can now use the delete method, which will send a, delete request. Now this method requires a URL to which it should send the request. And since I want to clear all posts, I will grab this URL, which targets the overall posts node, and send my request there so that all the posts there get deleted. Now, if I want to be informed about that deletion process in the component, which in this case I want, but if you chose a different solution, that's fine too. But if I want to be informed in a component, I will return my observable here, and I will not subscribe here in the service, but instead now in the app component, in onClearPosts, I can reach out to the posts service and call delete posts. And since this returns an observable, we now have to subscribe here. Now, why do I want to subscribe here? Well, if I deleted all posts, I also want to clear my loaded posts array here in the component. So I will add a method here where I don't really care about the result of our request or of the response, but I know that this function here will only run if it succeeded. And therefore here, I will then simply just set this loaded posts equal to an empty array again to reset it. And with these changes to the service and to the component, if we go back to our application and we let this reload, if I click clear posts, you see eventually it gets rid of all the posts. And on Firebase, we also see that this posts node does not exist anymore. And of course, we can still add new posts here. So all our old functionality still is there. The only thing we have, of course, is that currently we got no logic to automatically update our list down there once we added a new post. Now you can definitely score some bonus point if you implement this. I'll not do it here because it's not really related to the fetching of data, just to how you react to the sending of a post being done. So with that, we had a thorough look at different kinds of requests we can send. Now, what if something goes wrong? Thus far, our requests always succeeded. But of course, when interacting with servers, things can go wrong. You might not have an internet connection, or you're sending a request with incorrect data somehow because you have a bug in your program or whatever it is. Or your server fails. Maybe it's offline, or there's an error on the server, or you're not authenticated. There are dozens of things that can go wrong. And we can simulate such a thing that can go wrong by going to Firebase, and there in the database, let's go to rules. And remember that when we created that database, we enabled test mode, which essentially means that read and write access to this database is granted to everyone. You don't need to authenticate yourself. Now, we will add authentication in the authentication module later in the course. And therefore, for now, we open this up to everyone. Now, if I lock this down though, so if I say you're not allowed to read, for example, you can still write, but you're not allowed to read, and by setting this to false, there is no condition under which you would ever be allowed, not even if you are authenticated. So if I lock this down, what happens is that if I now try to fetch posts here, you see we get an error. And that, of course, happens, errors occur, but it is important how we react to that error. For now, for example, here, we stay in this loading state, and that is not a great user experience because now we as a user have no idea that there was an error and that something failed. Therefore, proper error handling matters. Now, how can we handle errors? There are different ways of doing that. Let me demonstrate the first possible way. Here, onFetchPost fails because, well, we have an error. Thus far, we only passed one function to subscribe, and that is the function that fires when new data is emitted. Now, as you learned in the Observables section, you can pass more arguments to subscribe, and the second argument is a function that triggers whenever an error is thrown. And there we will get the error object as an argument, and now here we can do something to handle that error, to do something to provide a better user interface, or a better user experience, and that often starts with a better user interface. So for example, here what we could do is we could display an error message instead of loading. So down there where we display loading or the content we loaded, we could actually introduce a new property, error, and set this to null initially, so we have no error initially. If this is not null, so if we do have an error, and we'll add logic to change that soon, I want to add a div here with the classes alert and alert danger, which are bootstrap classes, where I simply have, let's say, h1 tag, an error occurred, and below that I want to output error, because error in my case in this application here could just be an error message, and of course it's up to you how you exactly manage that and what you store in there. Now the idea is that this div is only shown if we have an error. So if error is true-ish, which it is not if it is null. Initially it's null and therefore it's treated as a false value, and therefore initially this will not show up. But as soon as we set this to some string, it becomes true-ish and then this will show up. This also means that I only want to show loading if we are fetching and we're not having an error. Because if we have an error, I never want to show loading, I want to show my alert here. Now, the remaining step is to set that error, and of course I want to do this here in my error handling function, and I will simply set this error equal to error.message, because by default error objects have a message. The question is if that message is helpful, but at least we can set this message for now. Now, important, of course, we are fetching posts not just here, but also in ng-on init, so there we should add this second argument as well. And with that, let's have a look. Let's wait for that to reload, and here it is already. Now, of course, you can see this is the error message we're getting. Might not be too useful. You can definitely tweak that. You can show your own error message. You can dive into that in more details. And if you, for example, need more information from the error response, well, let's have a look at the error we got here. Let me save that. Now if I fetch posts, this is getting logged, and you see what I log here is indeed a full error response object. Now there you see that message we accessed, but you also see you got, for example, another error key with yet another error key that has maybe a more helpful error message. This, however, is not guaranteed to exist. This only exists because our error here is an error response, so the Firebase server sending back a customized error response. Now the important thing to memorize about that, however, is you will get that HTTP error response object by Angular, and it will have an error key, but the detailed content of what's in there depends on the API you're talking to. Firebase gives you an object with another error key and that permission denied message. Your own API might not be sending this or might be sending different data. So it's always important to understand which API you're working with and what this API sends back in the case of a success message or in the case of an error. If you need more information about the error though, and not just that generic message, then you can dive into that error object you're getting, which is that object we're logging here, and there you see you can also get information about the headers, you can get the exact status code that was thrown, which can be very helpful in showing a more useful message, and so on. So you have all of that at your disposal, and I strongly encourage you to simply play around with that to properly handle errors in your application too. However, this is just one way of handling errors. Let me show you another way that might be more suitable in other cases. This other way of handling errors could be interesting in cases like when you send a request and don't subscribe to it in your component. It's easy for us to react to an error in the component here if we do return the observable and we subscribe in the component, because then we can pass this second argument to subscribe, which is this error handling function. But what about creating a post? There I subscribe in the service. Now obviously you could just return the observable there too and simply subscribe in the component instead, and that would not be wrong. But you can of course also implement a different pattern of handling that error. You could use a subject, and that is especially useful if you have multiple places in the application that might be interested in your error. So for example, here you could have your error property, which is a new subject, and subject needs to be imported from RxJS. And that will, let's say, eventually give us a string, that error message, but of course you can store in there whatever you want. And the idea then simply is that here, where we subscribe, where we get that error, we now use that subject. So this error we call next, and we pass on error message. And now the remaining step is that we subscribe to that subject in all the places we're interested in that error message. So here in this example, we would subscribe an ng on init, for example, like this. And whenever we get our error message here, we could set this error equal to the error message. Now, of course, as you learned, it's a good and recommended practice to unsubscribe if you get rid of this component. So I'll add a new property error sub, which is a subscription, and therefore we need to import subscription from RxJS like this. And now we can store our subscription in that property here in ng on init. And now we just need to add on destroy here, this interface, and import that from @Angular core as well. And add ng on destroy, therefore, maybe here at the end of the component. And there we now just want to unsubscribe. So this error sub unsubscribe. Now we use a subject-based strategy for forwarding the error, and that is fine too. No matter how you handle your error, what can be useful is a special operator that can assist you with handling errors. And that special operator needs to be imported from RxJS operators, and it's named catch error, and it does exactly what the name suggests. Now let's say here, when we fetch posts, where we already pipe some data, we got an error, and we want to handle that. Now we can simply add the catch error operator here. We get our error response in here. So we get exactly the same data we would get in that second argument of the subscribe method. And in here, you could now do stuff like send to analytics server or anything like that. So some generic error handling task you might want to do. Maybe not related to the UI, though of course you could use the subject and next the error message here too. But maybe you have some behind the scenes stuff you want to do when an error occurs. Log it somewhere, send it to your own server, your analytics server, anything like that. And once you're done handling that error, you should pass it on though. It definitely needs to be able to reach subscribe, just as you need to pass something here in map as well. So you also now need to create a new observable that wraps that error. And for that, you can import something from RxJS, and that something is throw error. And that is a function that will yield a new observable, and it yields a new observable by wrapping an error. So here we can now throw the error response. You could also throw a new custom error which you generated, whatever you want. Important, you need to return that observable which is created by throw error. And now with that, this of course doesn't do anything useful here, but it's just an idea that you could consider using catch error if you have some generic error handling task you also want to execute. That is error handling and what you can do, some ideas on how to get started with error handling. For the moment, I'll switch this rule back to true so that we can work with the data again, but it is worth keeping these concepts, these ideas in mind, because it can be very helpful and will definitely improve the experience users have on your webpage if you properly handle errors. Speaking of handling errors, one last thing we could do here. In our alert, of course, we could also add a button where we say OK or anything like this. And this is simply there for the user to get rid of that error message, where we then trigger on handle error. And now in that method in the app component, let's add on handle error, and there I simply set error back to null, and this will get rid of this error alert as well. Now to see that, I will indeed quickly switch back to false here again, so that we can get an error. So let's fetch posts, here's the error, let's click OK. Now we get rid of that. Now we see loading again, and that of course should also not be the case. And indeed, the right thing to do would be to reset this isFetching property whenever we get an error as well. Because even if we have an error, we are definitely not fetching data again. So setting isFetching to false here in the error use case when we subscribe is the right thing to do. Because even with an error, you're not fetching data anymore. So that state definitely changed, and therefore it should be reflected in the UI too and in your data too. So now if this changed, here's the error. And if we handle this, we just see no posts available, which makes more sense than loading, I guess. So with that out of the way, however, let's now really switch this back to true. And now we have an error handling strategy that is very basic, but a good start. We now kind of enter the second part of this module, you could say. Thus far, we had a thorough look at how we can send HTTP requests, how we can handle errors, how we can work with the data we get back if we don't have errors, and so on. Now let me dive into a little bit more advanced parts of the Angular HTTP client and how you can configure your requests and which kind of different responses you can back, and so on. Let's start with headers. When sending an HTTP request, and of course we are configuring our requests in the posts service, so this is the place to look at now. So when configuring these HTTP requests, you set things like the URL you send the request to, or in the case of a post request, you also set the data you want to attach to your request. Now, of course, sometimes you also need to set some special headers. For example, when you have a backend that requires authorization and looks for an authorization header, or if you want to set your own content type, or you need to attach a custom header because your API you're sending the request to needs it. Now, setting your own headers is extremely simple. Any HTTP request method, no matter if it's post or get or delete or patch or whatever, any of these methods has an extra last argument. So in the case of get, it's the second argument. In the case of post, it would be the third argument, which is an object where you can configure that request. And there you can configure a bunch of stuff, as you can see. And we'll start with the headers here. And headers now takes a headers object, which allows you to set the headers you want to send. To be precise, it's a HTTP headers object, which you need to import from @Angular common HTTP. So you need to add this import at the top, and this allows you to create a new instance of this object with the new keyword. And to this object, you can pass a JavaScript object here with the object literal notation, where you can have key value pairs of your headers. And headers are, of course, key value pairs. So for example, here you could set your custom header, in case your API would need that, to hello, or whatever you need. You can set any header, any HTTP header pair here. If I do this and I save that, and I now do try to fetch some posts, I fetch posts as before. But if we have a look at the network tab, let's actually do that again with the cleared network tab, and we have a look at our request here. If we inspect the headers, you see here on the request headers, there is this custom header hello, and that's that custom header I attached. And it's as simple as that. You can add as many headers as you want with this simple approach by simply setting the headers config option here to a new HTTP headers object to which you pass your headers in an object literal with a key value notation. Headers aren't the only thing you can set. For many API endpoints, you can also attach certain query parameters. And of course, again, it depends on the API endpoint you're sending the request to, which query parameters are supported. For example, the Firebase REST API, and you can learn that in the official docs, supports one query parameter, which effect we can immediately see. You set parameters by adding the params key here in that same config object where you added headers. And you set params equal to new HTTP params. Now, just as HTTP headers, you import HTTP params from @angular/common/HTTP. Now, HTTP params works a bit differently than HTTP headers. There, you can call set, and now you can set a param name and a value for that. And there, for example, you can set print, and that is a search param, a query param supported by Firebase, print, and you set this to a value to pretty. And this just changes the format in which Firebase returns its data. Now, if we save that, this loads, and now if I clear that and I click this again, and we inspect this request, you see now it has this query parameter attached to the end of the URL. And of course, you could have added this to the URL yourself up there too. You could have added print equals pretty up there and add with an ampersand in between as many key value pairs as you need or as your API endpoint supports. You can do that here in the URL, but by using this params config, it's a bit more convenient because you don't need to concatenate a super long string. You simply set them here with the set method. Now, if you wanted to set multiple params, you can simply do this by adding a search params constant or whatever you want to name it. Create your new params object there. And now here, you can call search params append and append a new param key value pair like print pretty. Important, however, search params, this object is immutable. So you actually need to override this, and therefore this needs to be a variable, with the result of append. So what you would do here in the end is you call append, and this returns a new HTTP params object, and you store that new object, which has these new key value pairs added to it, in the search params variable, overwriting the old one. So you still have a HTTP params object in there, but a new one. And if you have multiple key value pairs, then you simply repeat that step. With append, the old ones will be kept, but the new ones will be added to a new HTTP params object, which will then replace the old one by storing it in that same variable. So here you could also have your custom key, which is not supported by Firebase, but you can still send this. It won't cause any harm. And then you simply add your search params here for the params in your config object, and this is how you can attach multiple params if you want to. We can see the effect here. If I fetch, now you see we have multiple search parameters attached. Again, you could have done that directly in the URL, but by using the HTTP params object and the configuration object, it's a bit more convenient. Now, by the way, in case you're wondering what these parameters do, custom key does nothing. That's just something I came up with. It's not supported by Firebase, but as I mentioned, it's also no problem if we add this. Print pretty does something in the response. It prints this in a more pretty way. It adds some extra white space and line breaks so that this is more human readable. Absolutely does not matter for our app, where we read this with our code anyways, but I just wanted some example to show how to add query parameters. Thus far, we always were only interested in the response data of our request. Right? For example, when we fetch the posts, we get the response data, we map that, and we return the subscription, and then we use that data in the component. Nothing wrong with that, and absolutely what we need here. But sometimes you need access to the entire response object and not just to the extracted body data. Sometimes you need to find out which status code was attached, or you need some response headers. And in such cases, you can change the way the Angular HTTP client parses that response, and you can basically tell Angular, hey, please don't give me the unpacked, the extracted response data you found in the body, give me the full response instead. And let's do that for sending a post request, for example. You do that by adding this extra argument to configure the request, and here I won't set any headers or params. Instead here, we can change the observe key here. Observe takes a couple of values, and IntelliSense here incorrectly shows that I can only set body. That actually is the default, and body means that you get that response data extracted and converted to a JavaScript object automatically. But you don't have to stick to body. You can, for example, also change this to response. By the way, you should get an error if you enter something incorrect, but response is supported. Now, let's see what this is. We are already logging the response data or whatever we get back here in the console. So we should see that when we add a new post. So let's simply enter some content here, doesn't matter. Let's send that post. And now you see you get back the full HTTP response object. You have the body in there, and conveniently, this still already was parsed and converted to a JavaScript object for you. But if you wanted to access it, you would now have to access it by typing response data body here. And you even get auto-completion because TypeScript understands that we request the full response here. So you still have access to that body, but now you also have access to the headers of the response, to the status code, the status text, if it was okay, which will be true if the status code is in the 200XX region, so if it's not a 400 or 500 status code. And that can be more useful in some scenarios, where you maybe don't care about the body, or not only about the body, but you actually want more information than just that. With observe, you can change the kind of data you get back. Now, this is how you observe the response. You can also observe something different. So here, when we delete posts, I will use observe again. And I mentioned that body would be the default, and that extracts the response body and converts it to JavaScript. You also have response, as you learned. Now you also have events. Now, what is events? Let's simply have a look at this events thing by using one other operator, which we can chain in here. And we import that from RxJS operators, and that's the tab operator. And that simply allows us to execute some code without altering the response, so that we basically just can do something with the response, but not disturb our subscribe function and the functions we passed as arguments to subscribe. So here I simply pipe tab in there. I get my event, presumably, since we observe events here. And I can console log this, and you don't need to return anything or anything like that. It won't interrupt the normal observable data flow. It just taps in there, allows you to do something, but then automatically lets the response pass through, so to say. So let's see what that gives us. If I now click clear posts, we see we get two outputs now. And these outputs stem from posts service line 70, which clearly is this console log. So it seems like we got two events here. The first one logs an empty object, or an almost empty object, where we have type 0. And the second one is the HTTP response object. In the end, you have different type of events, and they are encoded with numbers. However, here in code, you don't have to use these numbers. You have a more convenient way. We can check event type and compare this to HTTP event type, which is an enum you can import from @angular/comment/HTTP. This is supported in TypeScript only, and for JavaScript, this in the end just is a map of numbers, so of 0 and so on, and it understands which type of event, so which number here stands for which internal type of event. But here we have a more human-readable way, because now if you type a dot here, you see the different translations. Now these are just the responses for the numbers you see in that log here. And you can actually see that here in the preview. You see, for example, response has a type of 4 by the look of it. This is simply number 4 encoded in more human-readable text. And again, that's a TypeScript-only feature. It is compiled to just that number comparison in the end. And you see that, for example, send has that number of 0. So it looks like we had the send event first, and then we had the response event, and that was also logged. There are other events too, which didn't kick in here. For example, when you're uploading files, you would get back some progress information about that file upload, how it is going, and so on. So here, if you ever, for example, want to check, did I get back the response? Then you can just compare the event type to this event type, so to this number, and see, are we having the response here? And if you do have the response, for example, you could log the event body, because you know, okay, the event we have here is actually my response object. I can safely access the body. if you just send this, so if the type is equal to HTTP event type send, well then, and the TypeScript is really smart here, then you can't access the body. Here you actually have only the type, but you could do something else. You could update something in the UI to basically inform the user that the request was now sent and you're waiting for the response. So that is how you can use these events if you need very granular control over how you update the UI and how and in which phase your request currently is. So to quickly demonstrate this again, if I now fetch my posts and I now clear them, now we have our different outputs here, and this null statement here, for example, is from me accessing the response body, which here just happens to be null, but if there were one, then we could safely access it here. So these are events, obviously something you'll not use all the time, but can be very helpful if you need fine-grained control over your request status. You can not only configure the observe mode here, you can also configure the response type. The default here is JSON, which means the response data, so the data in the body of your response is JSON. And that tells Angular that it should automatically parse it and convert it to a JavaScript object. You could, however, also tell Angular, the response type will be text and please keep it as text. Don't try to convert it to a JavaScript object. It could also be a blob if it is a file, for example. The official docs, of course, are the place where you can learn all about all available response types. So if we use text here, and I add a new post here, oops, send it first, then you still see, of course, that I get null here, because we had null before, and even if this is interpreted as a text, it still prints null. However, you can clearly see it is treated as a text because it is now wrapped in quotation marks. Before, it was treated as the null object that exists in JavaScript. It becomes even clearer if we try using that here when we get posts. There, if I switch the response type to text, we'll see that our application even breaks because it won't work if we try to work with a text response. And I even get an error here because I am using that generic assignment here and I'm saying, hey, the data that is returned here is actually of type JavaScript object that in the end holds a nested post. Well, TypeScript is smart and detects, well, if you tell me that my response data will be of that format, then it needs to be convertible to a JavaScript object. If you then also tell me that the response type down there is text, then you have to be lying somewhere, because it can't be both. It can't be a string, which is simply not in that format, and such a JavaScript object at the same time. So to make this work, we would have to get rid of that generic type assignment, and now we are allowed to save this. And now, of course, you see this breaks here. If I try sending a post and I fetch my post, it breaks and I just see these lines because my response here is in the end now treated as a text and not as a JavaScript object. And actually here it even breaks because the way I try to handle this is not correct. So I will revert this and I will revert this back to JSON, which is the correct data type, which now works. But it is important to also be aware of this option, which you can use to tell Angular in case you are really getting back some text and you don't want Angular to parse it to a JavaScript object, or maybe you are getting back JSON, but you still don't want to let Angular parse it because you want to parse it on your own at a later point of time or anything like that. For this, you can set the response type. The default is JSON, and most of the time, like in probably 99% of all cases, this is the type you want to keep. So typically, you don't need to override that. We're nearing the end, but I won't leave this module without touching on one very important and very useful concept or feature that is also supported by the Angular HTTP client. And that would be interest setters. Now, what are interest setters? We're sending our HTTP requests here, and whenever we want to configure something like search params, we're doing this on a per request basis. And oftentimes, this is the way it should be because every request might need different headers. But let's imagine we want to attach this custom header to all our outgoing requests. And a more realistic scenario would be that you want to authenticate your user and you need to add a certain param or a certain header to every outgoing request, therefore, so that the backend can read that. You don't want to manually configure every request because that is very cumbersome. And for that, you can add intersetters. Now, how do intersetters work though? Let's create a new intersetter by adding a new file. And I will name this the auth intersetter because I kind of want to simulate that we dare attach some header to every request that is required for authentication on our backend. Of course, we're not really using authorization here, but that's just an example. So here I will add a file and I'll name it auth-intersetter.ts or auth-intersetter.service because it actually is basically an Angular service. And in there, you create such an intersetter by exporting a class, and you give that a name which, well, probably should be auth-intersetter service. You can name it however you want, but I will keep that general file naming convention, which we also used in the rest of the course. And this will implement a certain interface, and that is the HTTP intersetter interface, which you need to import from @angular/common/HTTP. Now, this interface forces us to add an interset method. And that interset method here will actually get 2 arguments. And it will get that automatically by Angular when it applies our intersetter. And I'll show you how to apply it in just a second. So here we get 2 arguments, and the first one is a request object, which is of type HTTP request, which you need to import from @angular/common/HTTP as well. This is a generic type, a generic object, so you can use the angle brackets to basically inform Angular about the kind of data this request will yield. And I want to write a generic intersetter here, so I will use any because this will work for any data that might be retrieved by a request. And you have a second argument which is passed to interset, and that is typically called next. You could, of course, rename these arguments, but the first one is a request object, so rec makes sense. And this is a function which will forward the request because the intersetter will basically run code before your request leaves your app, so before it really is sent, and right before the response is forwarded to subscribe. So it steps into that request flow, and next is a function you need to call to let the request continue its journey. But more on that in a second too. Next is of type HTTP handler, which also needs to be imported from @angular-common-HTTP. Now this interset method now allows us to run code that, as I just mentioned, will run right before the request leaves our application. So for example here, we could for now just log request is on its way. And thereafter we should return the result that next yields us. Next, as I mentioned, is a function or actually an object, but an object with an important method that will allow us to let the request continue its journey. To be precise, that's the handle method, which you have to call, to which you should pass that request object. And by calling this, you let the request continue, and you should actually return the result to really let it continue. So that is the setup you need to use to have some code that is run right before the request leaves the app and to still let the request leave the app. If you don't return next handle and pass the request, then the request will not continue and therefore your app will basically break. You definitely have to return this here. Now, with that, we have to provide that service, and we have to provide this in a special way. So let's go to the app module, and in there, add a new element to the providers array, and that should be a JavaScript object now, and not the name of that service, where you have 3 keys. The first key is the provide key, and there you have to use HTTP_intersetters, all capital cases, that is a type that is imported from @angular/common/HTTP. So import that from this package and use it here as a value for provide. This is the token by which this injection can later be identified by by Angular. So it will basically know that all the classes you provide on that token, so by using that identifier, should be treated as HTTP interceptors and should therefore run their intercept method whenever a request leaves the application. The second key you pass to that object is the use class key, where you now point at your interceptor class you want to add as an interceptor. And here that would be the auth interceptor service, which you of course also need to import. And last but not least, you can have more than one interceptor, and you inform Angular about that and that it should not replace the existing interceptors with this one by adding multi and setting this to true. So this is just a dependency injection syntax supported by Angular that allows us to register a service under a different identifier and to have actually multiple services under that identifier, which will then all be provided and injected. Now Angular will do the rest. It will automatically grab all your HTTP interceptors and run their intercept method whenever a request leaves the application. And therefore, with this setup, we should now be able to reload. And we see request is on its way. And if I click fetch posts, you see it again. And if I send a different request, like sending a new post, you see it too, because this code now runs for every request that leaves the app. And if you want to restrict the requests for which this executes, you have to do that here in the interceptor. You got that request object in the end, and that request object has information like the URL to which it's sent. So if you know you don't want to send this to a certain URL, well, then you can use the URL here in a if check and compare it and so on. So you can control that all in here in the interceptor. Inside of an interceptor, you can not only log data, you can also modify the request object. However, the request object itself is immutable. So you can't set request URL to a new URL. That will not work, and you also get an error here. Instead, if you want to modify the request, you have to create a new one, like modified request, sounds like a fitting name for the constant, where you call request clone. And inside of clone, you pass in a JavaScript object where you now can override all the core things. You could set a new URL here, or you could add new headers. If you want to keep the old headers, by the way, then you simply do that by using the request headers and calling append, or you add new params or whatever you want. Now, I wanted to add a header here, so indeed I will access my headers, and I will access the old headers on the original request object, and then simply call append. And as you learned, this will return a new headers object, where I then have all the old headers, but also the new headers. And these will then be set here as headers for this modified request. And here I'll have my auth key, let's say, with XYZ as a value. Of course, this is just some made up header, which doesn't really do anything. And now the important thing here is I do not forward the original request, but my modified request. And that, of course, is a typical use case for an interceptor. You change the request and then you forward that modified request. And if you only wanted to append the auth header for certain URLs, then you could use a if check with the request URL key, for example. Here I will indeed log request URL so that we really see for which request the interceptor ran. And now let's go back and let's fetch some posts, for example. You see the URL is being logged. If we have a look at the network, fetch again, we inspect that request, you see that there on the request headers, auth XYZ was indeed added. And we should see the same if I now add a post. There, if we have a look at the request headers, we also see this. So our interceptor is adding that for all outgoing requests. And therefore, interceptors are a super important and useful feature. You're also not limited to interacting with the request in an interceptor. You can also interact with the response. You do this by adding something here to handle, because handle actually gives you an observable, which I guess makes sense because in the end, your request is an observable to which you subscribe in the end. So this in the end is the request with the response in it, you could say, wrapped into an observable. And therefore here you can of course add pipe and do something with the response if you want to. You could add the map operator here to change the response. For example, of course, you should be careful with that and not change it in a way that the rest of your application breaks. Or what I'll do here, you use tab, which you need to import from RxJS operators, to simply look into the response. Now here in tab, you get an event, and that's important. You always get events here. Remember, I showed you that you can observe different kinds of responses with the Angular HTTP client. No matter what you chose there, here in the intersetter, you always get an event so that you have the most granular access to the response you could possibly have. So here, for example, we could check if the event type is equal to the HTTP event type, which you also need to import, of response, because here maybe I only care about that response. I will log the event before that, however, so that we can see all events we got. And then in here, we could say response arrived, body data, and then simply console log the event body, which here is the response body, of course. Now here again, I'm just doing some logging, but as I just mentioned, you could use other operators like map here and even transform the response. That would be possible. So now if we save that and we go back and we have a look at the console, we see a bunch of output there. Let me clear it to make it a bit easier. And fetch posts again, and now you see request is on its way. Then we have type 0, which is this, the request is now sent event. Then we got the response. Therefore, we now got that response arrived log, and there indeed we now see the response body being logged because that is what I'm doing here. So this is possible too. You can not just interact with the request inside of your intersetter, you can also interact with the response if you want to. You can log it, you can manipulate it, whatever your requirements are. Now to finish up this topic on intersetters, and by the way, we'll see intersetters again in the authentication section of this course, but to wrap it up for now, let's add a second intersetter. Because you're not limited to one, you can add as many as you want. I'll name this one logging intersetter because I only want to do some logging here. And therefore the file name is logging-intersetter.service.ts. And there we now will create a new intersetter. Feel free to pause the video at this point and try it on your own, of course. You do create it by exporting a class, which you should name appropriately, like logging intersetter service. This has to implement the HTTP intersetter interface, which you import from @Angular common HTTP. This forces you to add an interset method, which then in turn gets a request, which is of type HTTP request, and which gets this next object function thing, which is of type HTTP handler. And there you should return next handle, as you learned. And since HTTP request is generic, you should also add angle brackets there and define the type of data it will eventually wrap. Now to next handle, you also have to pass your request then. This is a basic intersetter, but of course it's not doing any logging, which it should if we have a look at the name. So here I will now do some logging, and of course log whatever you want here. So here I'll just log outgoing request and maybe also the URL, though you could of course also log the headers or whatever you want. And on the response, I will now again pipe the tab operator, which is imported from rxjs/operators, where I got the event. And here we could now log all events again, but I only care about the response. So I'll compare the event type to HTTP event type response. And in there, we can console log incoming response and also console log the event body, so the response body if you want to. Now it's a very simple logging intersetter. In the auth intersetter, I'll therefore get rid of that extra logging I'm doing here. So I'll get rid of that pipe method and just return the modified request. I'll also not log these two statements here so that I have a leaner intersetter here. So this intersetter is now only attaching the auth header, and the other intersetter is responsible for logging. Now we just need to add them both. And now here comes something super important. The order in which you provide them matters, because that will be the order in which they are executed. So in the app module here, of course, we provide the other intersetter, the logging intersetter, by simply repeating this object in that providers array. And here you now point at that logging intersetter service, which you have to import. But now this auth intersetter will run first, and thereafter comes the logging intersetter. Now often the order might not matter, but if it does, be aware of that order and order your intersetters accordingly so that the order in which they execute fits your use case and whatever you're doing in your intersetters. And to prove that order thing in the logging intersetter, I'll actually also console log the request headers, because there, since the logging intersetter comes second, we should see that custom key, this auth key, being added. So now with that, if we save that, let me clear the console and fetch it again. We see outgoing request and the URL. We see the headers, and in there, indeed, we have that auth thing with the value of XYZ. And we have incoming response, and we see the response body. And now to really prove that order thing, remember that here we see auth XYZ. Now I guess you can already imagine what will happen if I switch the order here and we log first and thereafter we add the key. Well, if we do that and I clear that and then I fetch, then of course you see we still log the same as before, but if we inspect our headers, here we only got that custom header, which we're not setting in an intersetter. We're missing the auth header though. So the order matters, but other than that, providing multiple intersetters is extremely simple, as you can tell. So that's it for the HTTP module. Quite a long module where you learned a lot about the Angular HTTP client. Now the most common task you will do is of course that you send requests by using post, get, and so on, by adding a URL, possibly a request body, and maybe some request headers. This will be your bread and butter thing, and therefore this is the task you should practice and you should feel confident about. Always remember that these methods like get and post give you back an observable to which you have to subscribe to actually kick off the request and to send it. Since it is an observable, you can use operators, RxJS operators, to transform the data, log data, catch errors, or whatever you want to do. But ultimately, you need to subscribe, and you can do this in a service or in a component, depending on where you need to work with the response. And in the subscribe method, you pass in a function to handle the data you get back, and possibly also an error handling function like this one. This is how you generally work with HTTP requests. Now you got advanced features like the possibility of setting what you want to observe if you are interested in the response or just the body of the response or all the events, which type of data should be returned. You can set query params, and you have that very useful features of intersetters, which can really help you save time and code if you have some header that needs to be appended to every outgoing request, for example. And as I already mentioned, we'll see intersetters in action again later in the course once we add authentication. For now, this is it. Let's now move on to the course project and practice using these HTTP requests there. Let's now apply our newly gained knowledge about sending HTTP requests in our course project. So here's the recipe book as we left it after the last course project section. And now my goal is to make sure that we can actually click these Manage, Save Data, and Fetch Data buttons to, well, save all our recipes on a server in the web, and with the Fetch Data button, of course, to fetch them. So the idea is pretty simple. The idea simply is that we can store and fetch all our recipes we created on demand. Now, obviously, you can alter this in a lot of different ways. You could auto-fetch any recipes whenever the application starts or anything like that. The core thing we'll handle in this section, of course, is the sending of the HTTP requests. So let's take care about this now. For this, we of course need a backend. And just as in the HTTP section, I will use Firebase here because I don't want to write any server-side code because that's simply not the course for that. Angular doesn't run on the server after all. You could of course have your own backend written in PHP or Node or whatever you want. But this again is not the focus of the course. So we will use Firebase here since it's easy to set up, free to use, and has everything we need here. So on firebase.com, visit the Firebase console, just as we did it in the last course section, and there create a new project, which you can give any name you want. Now I will name it NG Course Recipe Book, but again, you are free to pick any name you want here. So NG Course Recipe Book, accept both checkmarks or both terms here, and then create that project, and definitely check out that last course section where we used the HTTP service Angular offers for the first time, so that this is not brand new to you. With this created, let's open our project, and just as before, we'll use a database, and we'll use that real-time database. So not Firestore, because that's a bit more clunky to use, but instead we'll use the real-time database down here, create a database, and for now, start in test mode, so that we have unlimited read and write access without being authenticated, though we will add authentication soon in a separate module. So for now, start in test mode, enable this, and create your database in that Firebase project. And now, as you learned in the last section, this will be the URL you use to save data, or at least a part of that URL we'll use. But before we'll use that, let's go back to our code, and let's make sure that here we have some way of interacting with the backend and of using the Angular HTTP service. To use the Angular HTTP service, just to bring this back in memory, I want to use it here to save and fetch recipes in the end. So to use that, we need a place to make these HTTP requests. Now, the buttons I just showed you can be found in the header. So there, indeed, if we have a look at our project, we have that header component. Here we have the save data and the fetch data buttons, and there's our header component. Now, of course, one thing we could do is we could add click listeners to these buttons, and then in the component body of the header component, we could inject the Angular HTTP service and make our HTTP requests here. Now, this has a couple of disadvantages. One disadvantage is that here in the header component, we have the buttons, but we don't really have the data we want to interact with. The data we want to interact with are our recipes, of course, and these are managed in the recipes service. Therefore, a better place to make these requests would be the recipes service. Though I'll take yet another route here, which is optional though. I will create a new service for this in the shared folder, and I will name this data-storage service. And that is totally optional. You could definitely manage this in the recipe service. I just want to split this up to make it really easy to focus on that HTTP functionality and for you to quickly find it if you later go through that project again. But handling the HTTP requests in the recipe service would be perfectly fine because we are interacting with recipes in the end. Yet here is the data storage service, and there let's export a class, which should be named Data Storage Service to use that typical naming pattern. And we can again provide this. We have to provide this. Now, first of all, we will inject the Angular HTTP service. And since we will inject a service into a service, we need to add @injectable. You learned this in the services section, and it is important to keep this in mind. Theoretically, @injectable is optional. You don't need to add it to your services. But you need to add it as soon as your service gets another service injected, which will be the case here because I will inject the HTTP service. And in addition to that, here we can now also use that newer shortcut of providing this, the alternative to adding it to the provider's array in the app module. We can simply add an object which we pass as an argument to @injectable, where we set provided into root. Now again, as you learned, this is optional. You could not use that and instead add the data storage service here to providers, just as we're doing it with the shopping list service and the recipe service. And on the other hand, you could, of course, also provide these services in the same way we're providing this data storage service now. Now, with that, I already mentioned it. We definitely should inject something into that data storage service, and that something will be the Angular HTTP client. Now, as you learned in that HTTP module, for that to be usable, we first of all need to do something in the app module. There, we need to import the HTTP client module from @Angular common HTTP. So this import statement needs to be added at the top of the app module. And with that added, we have to import that HTTP client module. So now down there in the imports array of our ng module, here maybe after the reactive forms module, because I like to group all the Angular modules together before our custom modules come. So here we can now add that HTTP client module, and this is crucial to unlock the HTTP client functionality in our application. With that, in any part of our application, we can use the Angular HTTP client, which means we can inject it. And that's the next step. Here in the data storage service, I want to send HTTP requests, and I will do that, or we will do that, by using the Angular HTTP client. Now, with the HTTP client module imported into our project, we can inject the Angular HTTP client here. For that, we first of all need to import it. Now here it's named HTTP client, and we import it from @Angular/common/HTTP. Now, I will store it in a private property named HTTP, and again, this is this TypeScript shortcut where by adding an accessor, like private, in front of the argument, TypeScript automatically creates a property of the same name and stores whatever we accept as an argument here in that property. And for Angular's dependency injection to work, we now have to set the type here of that injected argument to HTTP client, so what I imported here. Now Angular is able to inject this, also thanks to us unlocking the HTTP client in the app module. And now we can start writing logic to save recipes to our backend and to fetch them from there. Now, I guess it makes sense to start with saving recipes because it's hard to fetch them if we never save them. And for that, I will add a new method here to the data storage service, which I'll name store recipes. Now, of course, you can name this method however you want. And now here we got two possible routes we could take. We could accept the recipes we want to store here as an argument by injecting by importing our recipe model up here, and then defining that this should be of type recipe array. And then here we could just write the HTTP request where we want to, well, store these recipes on the backend by sending some meaningful request to some URL. Now we could do that. We could also inject the recipes service into our data storage service. That would be the other way. And then we could directly get our currently loaded recipes from that recipe service, and we avoid this extra argument. And that is what I will do indeed. So I will inject another service here, the recipes service, which is of type recipe service. Let's name it recipe service here too. You need to add that import to the recipe service, of course. And now with that injected, I get my recipes by reaching out to this recipe service and by simply getting the recipes with get recipes. So this retrieves our list of recipes, which are now temporarily stored in that constant. Therefore, we can remove that model import up there. We don't need that because we're not using the type. And now with the recipes loaded here in store recipes, we can make our HTTP request. So here we can now use the Angular HTTP client. And now we could definitely make a post request if we would want to add one recipe, but I want to store all my recipes. And I essentially want to overwrite any previous recipes I stored. And for that, Firebase gives us an endpoint which we read by using a put request. And again, that strongly depends on the API you're using on the backend. Here, Firebase works such that we can send a put request to a specific URL to overwrite all the data that is stored under that node. Your backend might work differently. If you're creating your own backend, it might be working differently. It's always depending on the API you're working with. But Firebase works such that if we send a put request to a URL, any data that's in there will be overwritten. So let me copy that here, that URL. Let's add it here. That's the URL I want to send this to, though that's not the entire URL. Instead, it should be sent to /recipes.json. The .json is a Firebase characteristic. You need to add this at the end of the URL. It has nothing to do with the data you're sending or with Angular. And well, /recipes, that's just how the Firebase real-time database works. It gives us a REST API where we in the end define our own nodes, which will then be translated to folders, you could say, where the data will be stored in. So now we're sending a put request there, but a put request, just like a post request, needs data to work. We need to tell Angular what to put on this URL, so to say, or what to attach to this request. And that will be our recipes here, of course. I guess that makes sense. Now, as you learned, this alone will not send the HTTP request. Instead, that request will only be sent as soon as we subscribe. Now, we got two routes we could take here. We can return our observable here by adding the return keyword, and then we can subscribe in the component where we're calling store recipes. Now, in our case here, that will be the header component because that is where our buttons are. And in the end, I'm not interested in subscribing in that component because I don't want to show a loading spinner, though of course you could do that, but here I just don't want to. And therefore there is no need for me to subscribe in the component because the component in this scenario will not be interested in whether that request is done or not. If that's different in your application, obviously you can use the pattern I also showed you in the last section where you do subscribe in the component that triggered that request or that method. So here instead I will subscribe directly in the service because I have no interest in the response in my component. And I will get back a response here. And we can console log that to have a look at it. I will not do much else with it though here. Now with that, we just need to make sure that the store recipes method is getting called. And as I mentioned, that will happen from inside the header component. There we have that save data button. Let's add a click listener here and maybe call on save data or whatever you want to call that method here. And then let's add that method to the header component. And in here, we now have to call our newly added save recipes method in this data storage service. And for that, of course, we need to inject our data storage service here by using its type. Make sure you import that type from your file, from your data storage service file in the shared folder. And now with it injected, in onSave data, we can use the data storage service and call store recipes. And that should already be all. Now let's go back to our application, which should have reloaded. And let's click Manage, Save Data. Here I'm getting back a response. That looks promising. So basically Firebase in this case returns the data we did store. More interesting, let's have a look at Firebase. And there indeed we see a new recipes node. And in there we have these recipes. Now, if you watched the previous module, which you absolutely should, you saw that there Firebase created some cryptic keys for these recipes. It always does it when you post data, when you attach one data piece at a time. If you put data, it assumes that you know what you're putting there. And therefore, if you wanted IDs here for these recipes, you would have to generate and add them on your own. But here, I'm fine with the normal array indexes here, which I have, which will be all we need. That is looking good. Our data is getting stored, including the ingredients, as you can tell. And with that, we finished the part where we store data. Now let's make sure we can also fetch data. So we can store data. How about fetching? Because obviously, we can delete recipes, right? We can get rid of all of them. And in that case, we got a problem here, and we want to be able to fetch data in that case so that we can load all the recipes we have on the server. For loading data, we can again use the data storage service, which makes sense because if we started using that for interacting with the backend, we should definitely stick to it. And there we can now simply add a fetch recipes method, which should be triggered when we click that other button in the header component. So this button, the fetch data button here. Let's already add that click listener and call this on fetch data or whatever you want to call this method, which gets called. And that method needs to be added to the component body, of course. And in there, the goal now is to use the data storage service and call fetch recipes. Now, of course, right now in fetch recipes, we're not doing much. So let's change this by again using the Angular HTTP client. And there we can now send a GET request. Now, obviously, the URL to which we want to send that request is that same URL we're using up there. So let's add that URL here. And let's send a request there to get our recipes. Now, just as before, the question is, where do we want to subscribe? And the answer is, where are we interested in the response? Are we interested in the header component? Well, not really, in my opinion. What would we do with the recipes here? We're not using the recipes in the header. So I'm not really caring about the recipes here, and hence there is no strong reason to subscribe here. Instead, it would be fine to just subscribe in the data storage service, where we already inject the recipes service, because maybe we can do something with the recipes service then to push or to move our fetched recipes into that recipes service, which in the end is the place where we do manage our recipes. So let's subscribe here, and we should be getting back our recipes here, though let's first of all console log this to get an idea of the format of data we get. So we got everything in place. Let's save that. Go back to our application, and it's reloaded in the meantime, which is why the recipes are back here. And let's click Fetch Data. And that's looking good. We're getting an array. Note the square brackets. We're getting an array of recipes. So since these recipes already have the right format, we should be able to just set our currently loaded recipes equal to these ones to override them with the fetched recipes. And for that, in the recipe service, we now just need a method that allows us to override the existing array of recipes. Because we have that starting array of recipes, and we have a function to get the recipes, which means return them from the recipe component from the recipe service to another component. And then we have the same for a single recipe and so on, but we have no method to override that array of recipes here. And it's time to do so now. So let's add a new method in the recipe service, which we can call setRecipes. And there we should get an array of recipes. So let's make it really clear by adding that type. And the idea here is simple. This recipes should be set equal to the recipes we're getting as an argument here. And this will override our recipes here with, well, these recipes. The important thing here just is, since we're changing the recipes, we should then also call this recipes changed next and push a copy with the slice method of our recipes there so that we inform all interested places in our app that we got new recipes, just as we're doing it when we're updating a recipe or deleting a recipe. So with that, we're setting the recipes equal. Now, in the data storage service, instead of logging the recipes, we can use the injected recipe service and call setRecipes to forward our recipes there. Now, we're getting an error here because TypeScript does not understand that the recipes we're getting here really are an array of recipes. And that makes sense. It just understands that here we have the body of an HTTP response, and that could be anything. And therefore, to inform TypeScript about the type, we should indeed add the generic annotation to the get method here, where we can make clear which format our extracted response body will have. And therefore here I will add a recipe array, and that now requires me, or requires us if you're following along, to import the recipe model here from the recipes area so that we can use that type in the data storage service. And now TypeScript does not complain anymore, because now TypeScript understands that the response body will indeed be an array of recipes, and therefore we can validly forward this here. With that out of the way, let's give this a try. Let's first of all delete all these recipes here, and let's now fetch them. And that's looking good. Here they are again, and if we send this to the shopping list, for example, that all seems to work. So we can now manage our recipes, and now we are indeed storing them on a server. We're almost done, but there is some cleanup work we can do related to that. It's nice that we can now load and store our recipes. That first of all means that we no longer need our default recipes here though. So I will comment that out just to have it around in case we do need it again or we want that dummy data again. But I will initialize the recipes property, which is an array of recipes just as before, as an empty array now, so that when our app loads, we have no recipes and we need to load them. That of course is optional, but I guess it makes a bit more sense than loading some dummy data. Obviously, you could do the same in the shopping list area. Now that's the first change. And we also have a bug in this application which we should fix. Let's say we add a new recipe here, summer salad. Let's add this image here, a juicy summer salad. And now the important thing, I won't add any ingredients to that recipe. Instead, let's save it like this, which is valid. We don't need to have recipes. We don't need to have ingredients. And now let me store that. So let's click Save Data. And on Firebase, you can see there is a new item. And that's our summer salad. But please note, obviously it has no ingredients. Now, generally our app works here. But to prevent nasty bugs, when we're fetching the recipes, it would make sense that we make sure that we always have ingredients, even if it's just an empty array, but that the data we loaded in the end has some ingredients, and this property is not undefined. Because if we otherwise try to directly interact with the ingredients, we could get errors. And for that, we can simply add pipe here to our fetch recipes HTTP request and add the map operator, which allows us to transform that data. For that, we just need to import map from RxJS operators. And this, as you learned, is an observable operator that allows you to transform the data in an observable chain, so right before subscribe. Here we get our recipes, but the recipes that might not have an ingredients property. And now here, we can simply return recipes, but call map on these two. And now this can be confusing. Map here in pipe is an RxJS operator. Map here is called on an array, and therefore the normal JavaScript array method map. They happen to have the same name, but they are not the same function. That's an RxJS operator called as a function like this inside of pipe. That is a JavaScript array method. Now map simply allows us to transform the elements in an array. In this case, in the recipes array. It takes an anonymous function which is executed for every element in that array, so therefore for every recipe, and we return the transformed recipe. Now here my idea is to return the original recipe, but if that recipe doesn't have an ingredients array, to set ingredients to an empty array instead. And for this, I will return a new object where I use the spread operator to copy all the properties of recipe, to copy all the existing data. And then ingredients will be set equal to, and now I'll add a ternary expression where I simply check whether recipe ingredients is true-ish, which it is if it is an array with 0 or more elements. And if that is the case, then I will set ingredients equal to recipe ingredients, which means I will not change it. But otherwise, I'll set it to an empty array. So if this here is kind of false, which is the case if ingredients is undefined, if it's not set, then I will set it to an empty array instead. And that's just a tiny improvement here in this observable chain, which doesn't break our app. Of course, it shouldn't. We can still edit our recipe here, interact with it, save that, and everything works as before. But now we have a little bit more protection against unexpected errors, because now we ensure that the ingredients property of the loaded recipes is always set to at least an empty array. We're almost done for the section, but we have another bug, or not really a bug, but a behavior, which I want to get rid of. If we are on a recipe detail page like this here, recipes/2, and you reload, you get an error. You get an error that it can't read the property ingredients of undefined, and the bigger problem here is not related to the ingredients, but simply that we tried to load the detail page for a recipe which doesn't exist, because we're fetching our recipes from a backend. And if we haven't pressed
fetch data before, well, then we simply have no recipes, so accessing the details of our recipe is doomed to fail. Now, there are different ways of making this work. One, of course, would be to simply add a guard that prevents us from accessing recipe/2 or the edit route, which also has an ID encoded in the URL, when we have no recipes loaded and instead redirects us to just /recipes, for example. That would be one way of doing it. We could use such a guard, but we can also use, yet a guard, but another type of guard. We can use a resolver, which are also covered in the routing module. A resolver is essentially some code that runs before a route is loaded to ensure that certain data the route depends on is there. That sounds like a good idea to me. I'll add it in the recipes folder next to the recipes component, and I'll name the file recipes resolver.service.ts, because it is a normal Angular service in the end. In there, let's export a class which should be named recipes resolver service, and this will get the add injectable decorator, because it is injectable in the end, and injectable, as you learned, needs to be imported from @Angular core, and this will then get the provided in root object here to provided application wide automatically. Now the recipes resolver service now needs to implement the resolve interface. Now, resolve is also imported from an Angular package, of course. It's imported from @Angular router. Now, resolve is a generic interface, which means we need to define which type of data will resolve in the end. And in our case, that will be the recipe data, so an array of recipes. And for that, let's also import recipe from the recipe model here. So our resolver will in the end run some code that loads some recipes. We now need to inject our data storage service here, because that is the service that will make the HTTP request. So I'll name it data storage service here of type data storage service, which now also needs to be imported up there from the shared folder, and there the data storage service file. And now the resolve interface forces us to add a resolve method here, which gets data about the route, the activated route snapshot, which is imported from the Angular router, and which gets the current routing state, which is of type router state snapshot, which is also imported from @Angular router. From there, we could get information like the ID we're requesting, but I'm not interested. I want to load all recipes anyways. Otherwise, things like editing them won't work correctly because we need to reinsert them into the array and so on. And therefore, now here, the goal is to return either an array of recipes, which we can't because we need to load it first, or an observable that will in the end yield an array of recipes. And that is something different. That is something we can offer. For that, let's have a look at the data storage service. There we have fetch recipes, and right now we subscribe in here. We just have to tweak this a little bit. I still want to set the recipes in the recipe service from inside fetch recipes, but we can simply do this by adding another RxJS operator, the tab operator. And the tab operator also needs to be imported from RxJS operators. The tab operator allows us to execute some code here in place without altering the data that is funneled through that observable. So in here, we will get our recipes array indeed, and I will simply set the recipes in the service then, as before. But now I will not subscribe here anymore, but instead return this call to this HTTP service. And that means that in the header component, we now have to subscribe here. And you don't even have to pass in a function if you're not caring about the response anyways. So therefore here in the header component, this change of course is a bit redundant, but it's now really helpful here in the resolve method, because here we can now return this data storage service fetch recipes. Now please note that I'm not subscribing here, but I'm simply not subscribing here because the resolver, this Angular feature, will subscribe for me to basically find out once the data is there. You can ignore this error. It's my IDE not understanding that this is valid. So now we should have a valid resolver that loads the data before this page is loaded. So let's now fetch data, open the summer salad and reload, and we still fail. Now obviously because we're not applying the resolver. So let's now go to the app routing module where we have our two paths that rely on a recipe being loaded. And on both these paths, we now have to add the resolve key, which is an array of resolvers. And there we should add our recipes resolver service. And that now needs to be imported. So let's import recipes resolver service from ./recipes. And then there it's that recipe resolver service file. Now let's add that same key, here to the recipe added component. And now Angular will run this resolver before loading this route. So now if I reload this looks much better. And now that data is here, because now what we do in the end is we run through that resolver our data storage service fetch recipes method whenever this route gets loaded. And that is super helpful and important here to ensure that our data really is there when we need it. And therefore, even when editing this, if I reload this edit route, this also works. It takes a bit longer to load because the data needs to be fetched first, but since Firebase is super fast, this is no issue. And now we prevent nasty bugs by us loading data which is not there, because now it is there. And as you learned, of course, saving data and fetching data also works, so that now we can freely delete our recipes as we want. We can always fetch them again, unless we saved again after deleting, of course. If I do fetch my recipes and I try to edit one of them, for example, I want to add an exclamation mark here, you see that these changes are not saved. And the reason for that is the resolver, which is used whenever we visit the recipe detail route. It fetches new recipes from the server, and that simply overwrites our existing recipes, including our changes to these recipes. Now, the solution is to first check whether we do have recipes and only fetch new ones if we don't. So I can inject my recipes service here, like this, import it from recipe service. With this injected, we can get our recipes from this recipe service get recipes. And now we can check if recipes length is equal to 0, then this means we have no recipes and we should fetch them. Otherwise, if this is not 0, we can just return these recipes, because then, well, we do have recipes, so no need to fetch them again. With that change, we can still reload the page whilst we're on it, but we can also, of course, reload the app somewhere else and just fetch data. But now, if I edit this, indeed the changes are saved. If I reload, and I then get my old data, because I didn't save them to the server before my changes, but they were saved locally, and if I would have chosen save data, we would have also saved them on a server. So this is a tiny adjustment which we should make to avoid strange bugs. One thing we haven't covered thus far in this course is authentication. Now, of course, a lot of modern web applications require users to authenticate. That means to sign up and log in, at least to use certain features of these applications typically. And it's also something we can add to our application here. Thus far in the course project, in the recipe book, we're not using authentication. We always interact with our backend where we store our data in an unauthenticated way. There is no feature in our application that would require authentication. Therefore, in this module, you will learn how you can add authentication to an Angular application, how it works, and how to make sure that you lock down parts of your application or the entire application with authentication. First of all, we of course have to understand how authentication works. And with that, I don't mean that users have to enter their email and password and log in, but how it technically works behind the scenes. For that, it helps if we think about how our web application, or how any web application works. We have a client, which would be our browser, the user using the browser, and we have a server. Now, when the user enters his credentials, so the email and password, then this authentication data is sent to a server where that data is validated. We can't do that validation in the browser because all the JavaScript code in the browser is exposed to our users and therefore not stored securely, and the logic there could be changed as well. Users can edit or even disable the JavaScript in the browser. So we can use that to create a nice user experience and to kind of show different parts of our application based on the authentication status, but we can't control or validate the authentication status in the browser. That has to happen on the server, so in a place where the users of our application can't do anything. Now, if you think about a traditional web application where the server would render pages for different URLs you enter, so where the server would render different HTML pages for the different URLs, you would work with a session. But remember that with Angular, we build single-page applications. That means we also decouple the front end, the Angular application, from the back end. For the different pages we visit, that all gets handled by Angular and its router. JavaScript in the browser takes over and re-renders pages or parts of pages as our user interface and the current state of the user requires it. We still reach out to the backend, as you learned in the HTTP modules. We can still interact with a server, but that server will be a RESTful API. And therefore will not use a session because RESTful APIs are stateless. The same would be true for GraphQL APIs, by the way. The core thing is that our backend, our server, will be an API. It will not be a server that renders the HTML pages we're on, and therefore sessions can't be used because our server doesn't care about the client. Client and server are decoupled from each other. They communicate through the HTTP client Angular offers, but besides that, there is no connection. The server doesn't know our client, so to say. And therefore, a session is no solution. A session would be stored on the server, and as I just said, the server doesn't care about our client. Instead, we'll use a different approach where the server will validate the user email and password, and if all that data is valid, the server will send the client a token, a JSON web token typically. That is an encoded string which contains a lot of metadata, and that string is encoded, not encrypted. That's important, which means this string could be unpacked and read by the client. More importantly though, that string, that token, is generated on the server with a certain algorithm and a certain secret which only the server knows. And only the server can validate incoming tokens for their validity. Because the idea is that the client, which is our browser, our Angular app, stores that token in some storage, like the local storage of the browser, and attaches the token to any request that thereafter is sent to the server, which needs to be authenticated. So let's say we need to be authenticated to store recipes. We then need to attach that token in the header or as a query parameter to that request we're sending to the server, so to that store recipes request. Now the server is able to validate that token because the server did create that token with a certain algorithm and a certain private key, which is only known to the server. That is how the token is secured. We can't generate or edit the token on the client because as soon as we do that, it will not fit the algorithm and private key used on the server, and the server is therefore able to determine that that token is invalid, and the server can therefore block access. This is why this is secure, because the server knows more than the client, but we give the client one important piece which is required to authenticate subsequent requests. But that piece is given by the server. It can't be generated on the client for the security reasons I just stated. Now that's the theory. It will become clearer if we simply start implementing it. And that, of course, starts with offering a user interface where users can enter their credentials, where they can sign up and where they can log in. And thereafter, we'll step by step add the logic to create such a token, store such a token, attach such a token to requests, and so on. So back in the project, it's time for new components or for new routes. Because thus far we have our recipes and we have our shopping list area. We now need some area where we can sign in. And my idea here is that in our application here, we have an auth page, an authentication page, where users can sign up and log in. And that auth page is, of course, available in an unauthenticated state. So the user doesn't need to be logged in to visit that auth page, because forcing the user to being logged in would defeat the purpose of an authentication page, right? The recipes page, on the other hand, that page should be locked down and should not be available if the user is not logged in. And the same for that manage dropdown. It should only be shown if the user is logged in, because otherwise we can't interact with that. Or we could, but these actions shouldn't do anything, because that will actually change to requests that need authentication to work. The shopping list should always be accessible, though of course you are free to also edit this and lock both routes down if you're not authenticated. With that, let's start by adding a new area in this application, which I'll create here in my app folder, which I'll name auth. And in there, we need an auth-component.ts file and an auth.component.html file, which is the template for the auth component. Now, in our auth component TypeScript file, we export a class auth component. And as you learned, such a component is created by adding the add component decorator. And there we need to define a selector, which in my case here will be app auth. And we also need to tell Angular where to find our template. And that, of course, will be my auth component.html file in the same folder as this component lives. Now, as you also learned, a component needs to be declared such that Angular understands it. And for this, we can go to the app module. And here we simply add it to our declarations array, the auth component. Simply add it here and make sure you also add an import path to that newly created file. With all of that out of the way, this new component exists. Now, of course, we can work on that template here. And for this, I'll add a bootstrap row, so a div with class row, and a column XS12 to take the full width on all screen sizes. And in there, I want to have a form, and that form should be my, well, sign up and log in form, and we'll add a button that allows the user to toggle between both modes. In the form, I'll add my form group div, which is a bootstrap class, to wrap a label and an input together, basically. And I will then add a label here for my email input, let's say. That also means that here we should add an input with class form control so that it looks good, because the class form control is offered by Bootstrap. And I will give this my email type here. It will also get the ID of email for accessibility reasons, so that this belongs to this label. And with that, we should have that first input. Let's now add a second input. This will be the input for the password. So the for, type, and ID here will all be password. Type password ensures that the characters are hidden. And we also need a button, of course. So let's add another div here with a button, which also gets the class button primary, where we can say sign up for now, and this will later also dynamically change the text based on the mode we're in. Because for that, I will add another button in another div below that, and there I will simply say switch to login, which of course later will also have a dynamic caption. And with that, let's make sure we can see that by ensuring that we can load this component or this component route here. And for that, in app routing module, I want to register a new route which loads the auth page. So here we can register a new path, which can just be auth. The name is up to you though, or the path is up to you, which you want to use. And there, the component I want to load will be the auth component. And for that to work, you need to make sure that you add the import path up there to the auth component. If you now save all of that and you enter /auth here, this is the form we're getting. Doesn't look too bad. Of course, you can change the styling. Actually, I will change it a little bit. There are a couple of things I'm not liking. I want to add more distance, more spacing between these two buttons here. Or actually move them in the same row. Like this, maybe. Yeah, that looks better. And also reduce the width of that a little bit on bigger devices. So there I want to work with col MD6, which is a bootstrap class, which gives us a more narrow column. And I want to add an offset of 3 so that this is nicely centered. Yeah, so here that looks better. This is it. This is the form we'll work with. Now, of course, we later also will add logic to make sure that we automatically are redirected to the off page if we're not logged in, and we can't visit recipes if we are not logged in. But for now, we'll manually go to that off page here. One thing I will already add, though, is in the header, a new link that allows us to go to that off page. Let me replicate the shopping list link here. And now that first shopping list link will go to the authenticate route. So the text is authenticate. The route or link points at /auth, therefore. And if we save that, now we can go to that route with that navigation link here. Perfect. So this is the basic setup with which we'll start. Of course, we're far from being done, because whilst we have this page now, the work just starts. And as a first step, let's make sure we can switch between login and sign up mode here. And thereafter, let's add the logic to actually sign up users and log them in. In order to switch between login and sign up, in the auth component, we need to manage the currently active mode. And therefore, you could, for example, add a property is login mode. But you can name this whatever you want. In the end, the idea here is that you store if the user is currently in login or in sign up mode, and you adjust the user interface, but also what you do when the form gets submitted dynamically based on that property. So initially, that could be true. And then I will add a method on switch mode, which we can call from our user interface to change that property. This allows us to dynamically change what's on the user interface upon an event triggered by the user by using that helper property, a pattern we used many times throughout the course already. So in here we can set is login mode to false, but that's actually not what I want to do. Instead, the idea here is that we change it to the opposite of what it was before. And for that, we can use a handy shortcut. We can change it to not this is login mode. Whilst this might look strange at first, this simply reverses the value. If this previously stored true, then not true will be false, and therefore we now store false. If this stored false, then not false will be true, and we now store true. That's the idea. Now we just have to connect on switch mode and this is login property in our template. Now I want to switch the mode when we click that button here at the bottom. So here, upon a click, we can call on switch mode. That's the idea, because that should be our trigger for switching the mode. But now, of course, we also need to adjust the user interface based on the mode we are in. The form inputs we show shouldn't change, let's say, but the button labels certainly should. Here, for example, we'll not always show sign up, but instead we can use string interpolation to show a dynamic text. We can check is login mode, which is the property we just added. And if that is true, we know we are in login mode. So this button, which is there to submit the form, should actually display login as a text. And don't forget the single quotes here to really output text in there, because you're in the string interpolation syntax. Hence, everything in there is interpreted as JavaScript code. The alternative, and this is a ternary expression here with the question mark, then the code we want to execute if this condition is true, and then a colon, and then the code we want to execute if that condition is not true. So if that is not true, then we are not in login mode, and therefore I want to output sign up, because if we're not in login mode, we are in sign up mode. A side note, by the way, as I just said, this button should submit the form, so we should change it to type submit. The other button here, which switches modes, should be changed to type button so that it doesn't submit that form here. Because if you don't set a type, clicking that button, which is inside of the form, will actually submit it, and therefore if Angular doesn't step in, it will send an unnecessary HTTP request into the void, and even if Angular steps in and prevents the submission, it will trigger the form submission in Angular nonetheless, and we certainly don't want to do that for this button, only for the first one. So now we have that first button changed. The second button here, this text of course also has to change based on the mode we're in. Because if we are in login mode, then we can switch to sign up mode. So in that case that we are in login mode, we want to say switch to sign up. If we're not in login mode, then we are in sign up mode. And then here we should say switch to login because that is the mode we can switch to. If you now save this and have a look, if I click this button now, indeed, correctly, our user interface changes. So this is working, and that's our first important step. The next important step is, of course, that we handle the form input here. Now, handling form input is something you already learned about throughout this course. And here I'll use the template-driven approach, but of course feel free to use the reactive one if you prefer that. Now we got two inputs. The first one, this email input, this one will get ngModel, of course. And besides ngModel, it then also needs a name. And the name can be email, but of course you can take any name you want. I also want to validate whatever the user enters here. So I will add required because this must not be empty, and also the email validator. These are both built-in validation directives Angular ships with, which allow us to validate the input for being there, for being any input at all, and for being a valid email address. Now the password will also receive ngModel and a name, which could be password. Again, that name is up to you. And here, that should also be required. And I also want to have a minimum length here because we will use Firebase REST API for authenticating. And it turns out that this REST API indeed requests us to have at least 6 characters. So here we can add the min length validator and give this a value of 6 so that passwords shorter than 6 will not be accepted. Now I want to disable the button if the form is not valid, and therefore on this form element we'll use that trick you already learned about in the forms section. We get access to that form object Angular creates automatically for us by creating a local reference, giving it any name you want, like auth form, but that name is up to you. And then you set this equal to ngForm. And now this will give you access to the Angular form object. And we can now use the auth form reference here, for example on this button, to disable it if not auth form valid. So if the auth form is not valid, then the submit button will be disabled. And indeed now you see it is disabled. And if I enter an email address here, it still is disabled. If I start typing a password, it is disabled. And only as soon as I have 6 characters, it gets enabled. And if I convert this to something which is not a valid email address, it also gets disabled. So this works. We got working validation. Now, of course, when we submit the form, we also want to do something. So here on the form element, as you already learned it in the form section, we can add ng-submit, and there we can trigger the onSubmit method and forward our auth form or just the auth form value, whatever you want. I will submit the entire form. Now, in the auth component, we therefore can add onSubmit here, and we'll get our form object here, which is of type ngForm as an argument, and therefore you need to import ngForm from @AngularForms. And now here we can, of course, for example, console log the form value and also call form reset to reset it once we're done. So let's give this a try. Let's go back here. Let me enter an email address and a password. And you see the form was reset correctly. It was disabled again. This button was disabled again. And you also see this is the data I got. This is the data I entered. This is now the data we'll use to actually use Firebase to, for a start, create a new user, and then to also, of course, log users in. I'm back in my Firebase project, and as with the normal HTTP requests, I really want to emphasize that you, of course, don't need Firebase to add authentication to an Angular application. You can add it with any backend, be that a REST or a GraphQL API. Your backend just needs to offer endpoints you can use to create new users and to log users in to get such a token, therefore. If your API supports that, and most APIs do, and if you're creating your own API, you can, of course, add your own auth logic, then you can use that API. You don't need Firebase. I'm just using it because it's easy, free to use, doesn't require us to write server-side code. That's the only reason. And with that, let's go to the authentication page here. And there, we now have to set up a sign-in method. Well, actually, before we do that, let's go to the database again. And there, let's go to rules. And under rules, previously, we unlocked this by setting read and write access to true for everyone. And this means that everyone can read our recipes, get our recipes, and store recipes. Everyone can interact with our database here. Now, this was required in the past because we had no authentication in place. Since this is about to change now, it's about to change these settings. And therefore, you should now change this to auth unequal null here for both read and write. This will tell Firebase that only authenticated users should be able to read and write data. Now, of course, if you were using Firebase for your project, you can set up more sophisticated rules for different resources, and the official Firebase docs are then the way to go. Here, I want to lock down everything, my entire Firebase database, if users are not authenticated. Publish these rules to make sure they have an effect. And what you will already notice now with this change is that if you go to recipes and you fetch data, you get an error here, a 401 error that you're not authorized. Now, of course, we could handle that error in a better way by displaying a nice error message here or anything like that, but we won't even reach that page soon because we will lock down access to it in our frontend to provide a good user experience and avoid that a user is able to visit a page where he's not going to be able to do anything anyways. So for now, we can go there and we can fail, but soon this will change. But now we need to go back to Firebase and enable authentication so that we can slowly add the logic to be able to visit our authenticated routes again. So here under authentication on Firebase, click on Setup Sign-in Method and choose email and password and click Enable here, only that top one. Now click Save, and now you got that built-in Firebase authentication active, where you can send requests to certain endpoints offered by Firebase to create users and to log users in. And you'll then see your users here under Authentication in the Users tab. Now, which endpoints are that though? Let's start with signing users up. You can simply Google for Firebase Auth REST API, and you should find an article in the official docs which gives you an overview over the REST endpoints Firebase offers to you for creating users and logging users in. Here on the right, you see the different things you can do with that backend, with that REST API Firebase offers you. It's a different REST API than we used before. It's not our database REST API we created automatically. It's a dedicated authentication API offered by Firebase. And we need only two methods: signing users up with email and password and signing users in with email and password. So of course, let's start with signing users up because we can't sign in if we have no users, right? This is the URL to which you need to send your request. So this is the URL we'll have to send a request to with this data, with the email, password, and then this return secure token thing, which we also have to add to our request body, which is a Boolean that essentially should always be true. Firebase just needs that. You can ignore that. Your API might not need that. Now we'll get back a response with, for example, the email address, the ID of the user, because Firebase automatically creates a new unique ID for each user. And we also get back that ID token, which is that token I mentioned on the slide earlier. So Firebase already gives us such a token once we sign a user up. We don't even need to sign in thereafter. We automatically get the token when the user is signed up. We also get an expires in field, which tells us how long that token will be valid, because for security reasons, these tokens will expire. For Firebase, for example, they at the moment expire after 1 hour. Thereafter, you either have to refresh them, which we'll not cover here, or log in again. Back to this URL though. We need to send this request, and that screams for a new service here that actually deals with that request sending. So in the auth folder, I'll add my auth service.ts file, which is a service that will be responsible for signing users up, signing users in, and managing that token of my user. In that auth service file, let's therefore export a class auth service, and that service will receive the @injectable decorator, which is imported from @AngularCore, where I will use that shortcut for providing it by setting provided into root in that object we can pass to injectable. The alternative would be to add it to the providers array of the app module. Now in that auth service, we can of course start relatively simple by adding one method, a sign-up method. And this method should do just what the name suggests. It should sign the user up. It should send a request to that sign-up URL. Therefore, we will need the Angular HTTP client, of course. And this needs to be injected. So let's add the constructor. And now make sure you got add injectable here. Even if you provided the service in the providers array of the app module, as soon as you inject the service into a service, you need add injectable. Not necessarily with that object being passed to it, but you need the add injectable decorator itself. And now we can inject the HTTP client, which I'll store in a private property named HTTP, and the type will be HTTP client, and it's imported from @angular/common/HTTP. In the signup method, we can now use the HTTP client to send let's have a look at the documentation, post request here. Send a post request to that URL, so copy that URL here, and here we'll use the post method, and then send a request to this URL. Now please note that in this URL we got that API key thing, which in the end is just something you have to replace with your Firebase API key. And you can find that Firebase API key in your Firebase web console, and there, by clicking on that gear icon under project settings, and then it's this API key here, which you need. You can simply copy and paste that. And then replace API key here, including the square brackets, with that copied key. This is the URL we have to send a request to. Now, since it's a post request, we of course also need to attach some data. So let me attach a JavaScript object here. And that JavaScript object should hold three properties, the three properties this endpoint expects: email, password, and return secure token. These are the three data pieces this backend endpoint requires. And therefore, I'll send my email here. And I do expect to get that here as a string. I also expect to get the password as a string. So I will send the email here, email key, gets the email value here, and then the same for the password. Password key gets that password value. The values here are the arguments I'm getting. You could name these differently. Email and password have to be named like this because our API expects exactly these keys. It also expects a return secure token, so you must set this as well. And as you can learn in the official docs, this should always be true. So therefore, let's simply set this to true here. Perfect. So this now will send an HTTP request to that backend here, to this URL. As you learned, the HTTP client does nothing without someone subscribing though. And we're not even calling the signup method anyways. So let's return this prepared observable now so that we can subscribe in the auth component, which is where we might also be interested in getting the response of that. Because if we get an error, we probably want to display an error message. And whilst we're waiting for the response, we might want to show some loading indicator. So therefore, returning the observable such that we know the current state of the request in the auth component makes a lot of sense. We also can define the format of the data we'll get back, because we will get back these 6 fields here. And therefore, I will create a new interface actually here in the auth service, because I only need it in here, and we don't even need to export it therefore. It'll just be an interface which I'll name auth response data, and this interface defines how such an object will look like, how our auth response data will look like, and it will have 6 properties as you learn: kind, ID token, email, refresh token, expires in, and local ID. So let's add all of them. Kind is a string. As you see here, they are all strings. ID token is a string. Email is a string. Then also we got the refresh token and expires in. So refresh token is a string. Expires in is a string. And last but not least, local ID, which is the generated user ID, that also is a string. Now, why am I defining the interface here? It is totally optional. You don't need to do that. But it is a good practice in Angular and in TypeScript apps to define the types of data you're working with. And as you learned in the HTTP client module, when we send an HTTP request with the Angular HTTP client, these methods here, post, get, and so on, these are our generic methods where we can hint which type of data we will get back. And here we know for this post request, we will get back data in this format, which is now exactly the format I stored in this auth response data. And therefore, we can add the angled brackets here and simply pass auth response data here, this interface we just generated, between these angled brackets, so that we inform TypeScript that this post request will yield us a response in which body we find data in this format. And this can be helpful for when we want to work with that response. With that out of the way, in the next lecture, we will actually fire this method from inside our auth component and also make sure we handle potential errors and we handle the loading state correctly. Time to fire that signup method. For that, let's go back to the auth component. And here in onSubmit, before we reset the form, instead of logging our values, I want to extract my email, which I can by accessing form value email. And the same for the password. So my password will be form value password. Of course, you could also add an extra check, first of all, where you check if the form is not valid by adding an exclamation mark. And then you just return. Normally, this method should not be triggered if the form is invalid because we disable the submit button. But if a user should hack away into that and kind of manually enable that button, which you can do with the browser developer tools, of course, well, then we still have this in line, and this still gives us an extra validation step. If the user disables this as well, which would also be possible, well, then the incorrect data will simply be sent to the backend and will fail there. If a user wants a bad user experience and forces himself into that, we can't do anything about this. But having that extra step makes sense, I guess. More importantly, though, we are extracting email and password, and therefore now we need to inject the auth service into the auth component so that we can call that signup method we just added. For that, let's add a constructor and store the auth service in a private property named auth service like this. Of course, make sure you do import your auth service, therefore. And with the auth service injected in here, let's call this auth service signup and forward that email and password which you extracted. And thereafter, we can reset that form. Now, in the auth service, in the last lecture, we set up that signup method such that it returns this prepared observable, which is ready to send this request here. And therefore, we have to subscribe to the response or to the return value of signup, which is that observable. Now, in that response here, we get our response data if the authentication, if the signup succeeds. So here, let's simply log the response data for now. And of course, we might also get an error. And for that, let's grab that error and console log that as well if one should occur. Good. With all of that out of the way, this should actually be working. One thing that's missing, by the way, now that I look at this, we'll add it later, is the login mode currently is not respected. At the moment, we always send a signup request here. Of course, we want to change this. And actually, let's implement it right now already. Let's check this is login mode. If we are logging in, then at the moment, we can't do anything because we only added the signup logic thus far. And therefore, right now, we can only do something in the else block. In the else block, I simply want to send this HTTP request. Here, we can't do anything at the moment. Resetting the form is something I always want to do. So now with that out of the way, let's go back to our user interface. And let's enter our email and the password. And let's try logging in. And that should actually not work. And indeed, we see no output there. So now let's try signing up by switching to sign up and entering our credentials. You can enter any credentials you want. Click sign up, and this looks good. We get back a response which has that kind response, which has that email expires in, that token, which is this cryptic string, local ID, which is that automatically generated user ID. That looks quite good. If we have a look at our Firebase web console here under users, and you click that refresh button, you also should see the user here. So this is looking really good, and this seems to work. Now, as an additional check, if you use that exact same data again, or at least the same email address again, Now you should get an error because that user already exists, and therefore here I get a 400 error, where if you dig into that error field, you see I got a code 400 with a message of email exists, which is kind of a code Firebase gives us telling us that this email address already exists. This is something we can now use to handle that error, and I also want to show a loading spinner whilst we are waiting for this to be submitted. Let's start with the loading spinner, and for this you can enter CSS loading spinners to find loading.io, which is a page where you find a lot of beautiful loading spinners. And I will simply grab this one, but of course you can grab whatever loading spinner you want. And I will just copy all that code here, which is the CSS code, and create a new file in the shared folder here, a new folder first of all, which I'll name loading spinner. And in there, let's add the loading spinner component TypeScript file. And important, also a loading-spinner component.css file. And into that CSS file, copy that CSS code you just grabbed and change that white color to a color of your choice, because this is the color of the spinner and white is something you won't see. So here I will simply change that, let's say, to a nice dark blue color, but of course you can take any color you want, and replace white in all places where it occurs with that color, which should only be 2 here for this spinner at least. Now in the loading spinner TypeScript file, in the loading spinner component TypeScript file, let's export a class loading spinner component, and let's give that the add component decorator, which is imported from @Angular core. Give it a selector of app-loading-spinner, and then a template, which could be a URL pointing at an external file. But here we'll have a very short template, and I'll just grab that HTML code from the loading spinner page, which is the HTML code you need for this spinner to work. And I'll add this as my template here. Looks quite unstructured, but this is all this spinner needs to work. And thereafter, more importantly, I'll add style URLs, and there add one URL to my array of URLs, which points at my loading-spinner.component.css file I just added. With that, we prepared that loading spinner component. Of course, as always with all components, we need to declare that. So in the app module, let's add the loading spinner component to the declarations array, and make sure you also add an import path at the top of this file pointing at that loading spinner file in the shared folder. So that's the loading spinner component. We can now use this in the auth component here, because here I essentially want to hide the entire form if we are currently loading. Now to find out whether we are loading, here in the auth component TypeScript file, we can add a new property, isLoading, and we'll follow a similar logic as we did for isLogin_mode. We'll change this isLoading property dynamically and update the UI based on it. Initially, we are of course not loading, but in onSubmit, as soon as we made it past this if check and the data extraction, so right before the requests get sent, we can set this isLoading to true, because now we clearly are sending a request and we are loading. And I'll set this back to false as soon as we're done. So both here for the success case as well as the error case. In both cases, we should set isLoading back to false, because we're not loading anymore. We got a response, even if it should be an error. Now the isLoading property can be used in the template to hide the form, simply with ngIf. There we add ngIf to the form element, and by checking for isLoading, or for the form here actually for not isLoading, we ensure that the form only shows up if we're currently not loading. If we are loading, I want to show that spinner, and for that, I'll simply add a div here, and in that div, I'll add my app-loading spinner component, and that entire div will only be shown if we are loading. Now let's give this a try, and let's save that. Go back to our application, enter our data, switch to sign up, and here's our spinner. Of course, I still get my error thereafter, but the spinner works. Now obviously it would be nice to center that spinner, and here we can do this quick and dirty on that div by adding an inline style and setting text align to center. Of course, you could also manage this through a CSS file if you want to. This, however, should do the trick here. If we now try to sign up again, this was centered as you saw. Now that's the loading spinner. but I also want to show an error message, an alert, in case we got an error, in case we had a problem with logging in. And therefore, the error should be handled as well. Hence, let's go back to the auth component. And we already managed whether we are logging in or whether we're loading. Now, I also want to store an error here. And initially, that is null, because initially we have no error. But in theory, that will be of type string, because it should hold an error message, let's say. Now, you can get as sophisticated as you want and store more information in here, have a more complex error object. But for the UI, I only care about the message. And I either have no message or I do have a message. So therefore, let's now go to onSubmit here to the error case. And instead of logging my error message, I will simply set, or I will still log it, but I will in addition also set this error equal to an error occurred. And we'll add a more specific error message in a second. So here an error occurred is set. And in my auth component, therefore, I'll now add another div using the bootstrap alert and alert-danger classes to give us a nice alert view. And in there, a paragraph where we output that error text, because keep in mind that the error property of this component is just a string. Now, when should this div be shown? Of course, only if we have an error. So let's add ngIf and check for the existence of error here to make sure this only shows up if we do have an error. And therefore now if you go back, you see nothing here. But if you try signing up for a user that already exists, you now see an error occurred here. This of course is better because we now give the user a hint about which error occurred, or that an error occurred to be precise, but we don't tell the user which error occurred. So that's the thing we'll do in the next lecture. Would be nice to be more specific about that error message here. Now, if you inspect the response we're getting back, you can of course see that on the response object we have that error field. And if we dig into that, there's another error field, so a nested error field. And if we dig into that, we see we have a message. That's a message provided by Firebase. And if you have a look at the Firebase REST API documentation and you scroll down a bit, you see common error codes that are thrown by that endpoint. And that would be, for example, email exists. So in the end, we just have to check for these codes and we can output a more helpful error message. Now we could do that here in our component. Here where we get that error, we could check with a switch statement, for example, if my error response, maybe we should name this error response to be more specific about what this is, because it's the full response object. And on there we have an error key, and we have an error key, and there we have a message key. We switch on that message, and then we have a case where this is email exists, for example, and now we set this error to this email exists already, for example, like this, instead of doing it like that. If we would save that code here, it already should do its job. And if I try signing up with that email address, I get the email exists already. Now we could do that here, but handling everything of that here in the component is not necessarily the best possible way of doing that. It moves too much logic into the component, which should primarily focus on updating the UI and not so much about handling the response correctly. And that therefore screams for the usage of an RxJS operator that allows us to handle errors here in the service in our observable chain we're setting up here, so on this observable. For that, we can simply pipe on this observable and add RxJS operators. And here I'm interested in one operator, and that is the catch error operator. Now, catch error needs to be imported from rxjs/operators to be available in that file. And we will also need one other thing, and that will be the throw error function from just RxJS, which will create a new observable that wraps an error. Because if you remember the earlier sections in this course, RxJS always needs to return an observable down there, and catch error catches the error, but you still then need to return a new observable. and that observable should still wrap the error so that it still ends up here in that error case in our subscription. And we do want to end up there. I just want to move more logic from there into the observable chain. And indeed, therefore, we can grab that switch statement and move it into here. In catch error, we get that same error response we previously got in the subscribe function. And therefore, in here, we can switch on that error response, error message, and set the error, though, a bit differently. We can add a new variable, error message maybe, an unknown error occurred. That could be our default message in case we can't identify a more specific error. And then here I'll just set the error message to this email exists already. Now important, this switch statement here will fail if the error we're getting doesn't have that format. And that could be the case, for example, if we have a network error. So therefore here, I'll check if the error response does not, therefore the exclamation mark at the beginning, have an error key, or if it does not have an error key on the error key, to avoid that this access here fails. Because if it has either no error key or then no nested error key, then we know we can't access that message because the error we're getting seems to be in a different format. And therefore, in this case, I immediately want to return throw error and wrap my error message here. So that will throw an observable that in the end just wraps that message. Otherwise, we'll make it into that switch statement here. And there we have only one case. We'll add more cases later. Here, I then also in the end want to return throw error with my error message. So now that error message conversion logic happens in the auth service, which is a better place for that, and in the auth component, here in the error case, we now just get the error message because we subscribe to an observable here, which here in the error case will be an observable that only contains a message because we throw an error observable that just includes that message. So we know that we get the error message here as a data point. We can print it here, but more importantly, of course, we can now set this error equal to that error message. And this should now have the effect that if we go back and we try creating that same user again, we get this email exists already here, which is, of course, the same behavior as before, but now with the logic moved into the service, which is the place where that logic should be, so that our component is way leaner. So we spent quite some time here on the sign-up process, but therefore we already got a nice error handling step here in place, which is not too bad. But now it's, of course, all the time to sign users in and not just up. And of course, our UI doesn't change on whether the user signed up or in at the moment. That's also something we'll take care about. But first of all, let's make sure we can send a request to the login endpoint as well. For that, in the auth service, let's start by adding a new login method. And login also takes an email and also takes a password, which should also be a string, unsurprisingly. And in login, we still have to send a request. Let's check out which URL we should send it to. Here in the Firebase auth REST API, if we want to sign in, this is the request, the URL we should send a request to. It should be a post request, as you can tell. And therefore, let's, in the login method in the auth service, use the Angular HTTP client and send a post request to that URL. Now again, that API key needs to be replaced, and therefore, obviously, we use the same API key as up there for signing up. Let's grab that and replace it down there, including the square brackets, just like this. And this login request also takes an email, a password, and this return secure token key as a request body. And that, of course, is the exact same body as we have here for signing up. So I can just copy and paste it from there, just like that. This will now send such a HTTP request. Let's see which data we get back. For that, in the official docs, we see we get almost the same response as we got it for signing up, but there is one extra field, the registered field, which is a Boolean, and therefore, to be able to use that same auth response data interface, I'll add registered here, but add a question mark to indicate that this is optional and a Boolean, because the sign up request will actually not yield it, but the login request will yield it. So now here on logging in, I will also add the angled brackets after post and inform TypeScript about the request response data we'll get back that this is of type of response data. Now, just as for signing up, I want to return this observable so that we only prepare it here, but we can then subscribe in our auth component. And therefore now in the auth component, here we have our logic for sending that sign up request. In the is login mode, we therefore now can reach out to auth service login and also forward email and password here. And then we have pretty much the same logic as down there. So I can grab this subscribe block here and also use it up here, because in the end, I want to control my loading state and the error. And since it is the same subscribe block, of course, we can write this a bit differently and not repeat ourselves here. We can simply create a new variable of ops for of observable, which will in the end be of type observable, a type you need to import from RxJS. And that observable is a generic type, which means we also have to identify which kind of data this will yield eventually. And that data will, of course, be our auth response data. And therefore, now we actually need to export this auth response data interface so that we can import it into the auth component and be really clear that this auth response data will be yielded here by that auth observable. And for that, you, of course, also need to import auth response data from the auth service file. Now, why do I create that auth observable variable here, though? The idea is that we simply change the observable this variable holds in our two branches of this if check here. But at the end, after this if check, at least one of the two observables will be stored in there, or exactly one of the two. But we know that there will be an observable stored in that variable. And therefore, we can then just subscribe on that observable here after this if block, like this, and only change what's in the observable inside of the if block. So for example, here for logging in, we could set auth ops equal to this auth service login without calling subscribe here. And for signing up, we set auth ops equal to this auth service sign up without subscribing here. Can get rid of that code here, because that subscription code now lives below the if-else statement, because we know that after the if-else statement, at least one of the two observables, or exactly one of the two, but certainly one of the two, will be stored in auth ops, and therefore subscribing to it is safe. And then since we want to do the exact same things upon subscribing, control the loading state and set the error, we can share the code and reduce the code we write here. So now we should also have our login route in place. Let's give it a try. So here for the user, which I already created, let me enter the credentials and click login. And this response looks quite good. Now let's try a user we haven't created yet, test2. And now I get object here as an error. Now that doesn't look too helpful. So we certainly need to work on the error handling logic. But besides that, it's working. So let's now take care about the error handling logic. The problem, of course, is that for logging in, we don't use the error handling logic we use for signing up. And therefore, we get the full error response, which we try to output as a message. Hence, we see object here. Now, actually, it would be nice to share that error handling logic between both observables. So between the sign up and the login observable. And that, of course, is possible. We can create a new private method here in the auth service. Private because we'll only use it in that service, which we could name handle error, and where we get an error response, which is of type error response, HTTP error response to be precise. And that is imported from @angular/comment/HTTP. So I get that response here. And in there, I want to have that code. So I want to basically dive into the response, check it, and then throw a new error observable. So I copied that entire code into the handle error method, where I set up let error message, then check the error response for the error field, and then for the nested error field. Then we have that switch statement, and we in the end return a new thrown error in an observable, either here or here. Now, instead of setting up this anonymous method up there, we can pass this handle error into catch error. And this handle error refers to this private method here. So now we have this central place for handling errors, or this central function, and we use that here. We can now use that same pipe with catch error on our login observable here. So there I add that exact same pipe. This means that this handle error function now runs for both observables that are related to signing up, as well as for observables that are related to logging in. And therefore now if we save this, we should see a different error message if we try to log in with a user that doesn't exist. Now we see an unknown error occurred. And it makes sense that we see this message because in our handle error function, we only handle the email exists error here in this switch case statement. Now we can simply add more cases, because for logging in, you see common error codes are email not found or invalid password. And I guess it would make sense to handle these two cases since they look relatively common. Important, of course, if you don't want to give any hints away, whether the email or the password was the wrong thing, you can, of course, also handle both with the same error message that doesn't give any hints. Here, I will be more specific to practice this a bit better. So let's break here after this case and then handle the email not found case, where I will set my error message to this email was or does not exist, then break, and then add another case for invalid password, like this, where we can set the error message equal this password is not correct. Again, you could use the same error message for wrong password and wrong email to give no hint away for what of the two things was wrong to enhance security. But here I want to be specific because this allows us to better practice this all, I guess. Now with this tiny change in place, which I guess already shows the magic of using that central error handling logic, we don't need to change anything anywhere else. We only added 2 new cases to this handle error function and we're done. So with this simple change, if I now try to log in for a user where the email address doesn't exist, we get the email does not exist. And now if I take the existing email address but a wrong password, I get the password is not correct. So our error handling is working, and we got the sign up and the login route in place. The next step, of course, is to finally start using that login data, start storing that token, and adjust our user interface to the current authentication status of the user. Let's start storing data about the user, whether the user is authenticated, and so on. And for that, I think it makes sense to start off by creating a user model. So in the auth folder, I'll add a new user.model.typescript file. And the idea here is that this model stores all the core data that makes up a user and even helps us with validating whether that token is still valid. Because remember, I said that the token would expire after 1 hour, and we'll need to therefore also find out not only if a token exists, but if it is still valid. And I want to manage this in this model. Therefore, I'll export a class here with a name of user, which I guess is a fitting name for, well, a user model. And in there, we can use a constructor so that we can create a user with the new keyword. And there, again, I'll use the TypeScript shortcut of automatically storing arguments of the constructor in properties of the class by adding an accessor in front of the property name, in front of the argument name, which will then also be used as the property name. And there, a user should have an email, which is of type string. A user also should have an ID, which is of type string. And we need that token. And this I will store as a private property underscore token, which is a string. And also a token expiration date, which should be a private property underscore token expiration date, which will be a date object, so of type date. Now, why underscore and why private? Private because the token should not be retrievable like this. Instead, when the user, or you as a developer, want to get access to the token, you should actually be required to do that in a way that will automatically check the validity. And this can be achieved by adding a getter here with the get keyword, which I'll name token now. Now, what is a getter? A getter here looks like a function. We add parentheses and then a function body, but you actually access it like a property. So you will be able to do something like user.token. This is how you will be able to access this. Because it's a getter, it's a special type of property, you could say. It's a property where you can write code that runs when you try to access this property. So it's a property plus plus, you could say. A getter also means that the user can't override this. So setting user token to something new, this will throw an error because it's only a getter, not a setter. There are setters too, but we don't need them here. You set a token when you create a new user object, and we will always create a new user object when a user logs in. So therefore, we have that getter named token, and the idea here is that we, of course, return this underscore token here, but before we do that, we can add certain checks. Or to be precise, I want to add one check. I want to check if this token expiration date does not exist. So if this does not exist, or if the current date, which we get with new date, that's a JavaScript feature, that's the current timestamp, not just the date, but also the current time. If the current timestamp is greater than this token expiration date, so if it does exist, but it is smaller than the current timestamp, then we know that the token expired, right? Because if the token expiration date is smaller than the current date, then it's in the past, and that means even if we have a token, it's not valid anymore. And therefore, in that case, I will return null, even though we might have a token. That's the logic I want to add in this user object for now, or in that user class for now. With that created, in the auth service, I want to store the authenticated user, and I will actually store it as a subject. So for that, let's add a user subject with new subject. The subject here is, of course, imported from RxJS. And this will be a generic type where we store the user in the subject in the end. So the user needs to be imported from the user model. And now with that, the idea, of course, is that we emit a new user, we next a new user whenever we have one, we log in, or also when we log out, when we clear the user, when the user becomes invalid or the token expired. So now here, for example, for signing up, we know that when we succeed, if we don't have an error, we get the auth response data, which contains that token we need for the user, which contains the email and the expiry date. And therefore, I want to add a new operator, a new RxJS operator to that pipe here, to that observable pipe. This will be the tap operator. Now, the tap operator, just like catch error, needs to be imported from RxJS operators. And if you remember, tap was an operator that allows us to perform some action without changing the response. So it steps into that observable chain, but it doesn't stop it, block it, or change it. It just runs some code with the data you get back from the observable. So with the response in this case. Therefore, here we get our response data. And here I then want to create my new user. For that, I'll create a new constant user where I call new user using that user model. And we need to forward that email because we expect that as our argument here in the constructor. We need to forward the ID, which is the REST data local ID. That's the generated user ID generated by Firebase. We need to forward the token, which is our ID token. And we need the expiration date, which should be a date object. Now, that's not part of our response. That is something we have to generate. And for that, I'll add a new constant here, expiration date, where I create a new JavaScript date object based on that expires in time we get back from Firebase. Now, expires in, if you check the Firebase docs here, is a string, but in the end, it holds a number, the number of seconds until the ID token expires. So therefore here, all we have to do is we have to get the current date, and on that, we can call getTime. That's the current timestamp in milliseconds since the beginning of time, which in JavaScript was in 1970. So we have the current timestamp in milliseconds, and to that we add rest data expires in, which we have to convert to a number by adding an extra plus in front of it. So we add rest data expires in times 1000. Because expires in, that is in seconds. This is the timestamp in milliseconds. Here, therefore, we need to multiply the seconds with 1000 to convert this to milliseconds as well. And this gives us the expiration date in milliseconds. And by wrapping this with new date, as I'm doing it, this will convert it back to a date object, which is a concrete timestamp in a date object form and not in milliseconds anymore. So this is the expiration date, which we now can pass as a fourth argument here to that user constructor. Here it is. So this constructs the user with the data we get back from the backend and with our expiration date. Now we can use the subject to next that user. So to set this or emit this as our now currently logged in user in this application. Now, just as before with the error handling, we need the exact same logic for logging users in. And therefore we can use the same approach as for the error handling. I'll add a new private method, handle authentication or whatever you want to name it. And there I expect to get the email. I expect to get the token. I expect to get expires in, let's say, as a number. And now we can grab that code we just wrote here in tab and move that here into handle authentication. Now use expires in, which is not coming from response data and which does not have to be converted to a number because we already expect it as a number. Use the email here. We also need the user ID, so let's expect that as a string as well. So use the user ID here and also use the token here. Now we have handle authentication that would do everything we need related to authentication. Here in tab, when we get the response data, we now just have to call this handle authentication and forward rest data email, rest data local ID, rest data expires in as a number. So let's add a plus in front of that. And before we add this, we also need rest data token, ID token, excuse me. So we basically call handle authentication with all the data this function needs. And now we can just copy that tab operator here and move it into the pipe for our login route. So that there, we now also call this handle authentication. We forward all that data. And in here, in handle authentication, we then use that data to create a new user and log the user in. Now, that's creating the user, that's logging us in. The next step, of course, will be to also redirect the user in the user interface and navigate us away, and also to then update the UI and, for example, show a logout button in our header and only show the manage buttons here if we are logged in. So update the entire header based on the auth status and, as I just said, forward us when we do log in. Let's start by forwarding the user to a different route once the user is logged in. Now, since we always want to redirect the user once we authenticate it, we of course can do this in two different places. We can either do it here in handle authentication, or we do it in the component here instead of subscribe in the success case only, of course. Now, it's up to you when you do that. If you prefer redirecting in the component or from inside a service. Both is valid, and if you need no data from either the service or the component and you have no strong reason for doing it in one place or the other, it's totally up to you where you do that. Now, you could argue that you want to keep your service a bit cleaner and don't interact with the user interface in the service, so don't directly influence the user interface, and therefore you maybe don't want to interact with the router in here, though I see no problem with doing that, and we did it before in the course as well. Nonetheless, to mix things up, here I will do it in the component, and I will inject the router, the Angular router, which is injected from @AngularRouter. And with the router injected in the auth component, Here in subscribe, but only in the success case, of course, I want to use the router and navigate to /recipes like this. This is a great example for programmatic navigation now, where you couldn't use a link in the template because you want to navigate once some action is done and you don't want to navigate when a user clicks something, but only once the user clicked the button and the login is done. Therefore, we need to navigate from inside code because this is where we know once this is done. So now let's give this a try and let's see if it works. Let's try logging in. And we go to recipes. Great. Let's now try to create a new user. So here with test2, switch to sign up and click sign up. And this works too. So navigating works. Of course, we still can go back to authenticate because we still have it here in the header. And on the other hand, if we're not authenticated, for example, if I reload the app, then all the previous state is lost and we're not authenticated because the user object doesn't exist anymore in memory. We'll soon add something to persist it, but for now, that's how it is. So even if we're not logged in, we still see recipes, even though we don't really want to be able to go there. So the next step will be that we correctly reflect our current status here in the UI, and that in this application mostly means in the header. In the header component, if we have a look at the HTML code, in the end, the goal will be to disable this recipes link if we are not logged in, to disable the authenticate link if we are logged in, because there is no sense in logging in again if we are logged in, right? To always show the shopping list, to disable the dropdown if we are not logged in, because saving and fetching data is only available if we are logged in, and to also show a logout button that allows us to, log out. Let me start with the logout button here. For that, I'll add a new list item here, and in there, an anchor tag, where I say logout, without any reference or router link set, just like this. Now let's also add this style here to make sure we get a nice cursor when hovering over that, but that's of course totally optional. Now we have that logout button here, and now we need to make sure we get the current authentication status into the header component. So we basically find out, do we have a user with a valid token or not? And we then also need to use that information to update the template correctly. Now, for that, first of all, in the auth service, right now we manage our user here through a subject. This will inform all places in the application about when our user changes. And right now, even though we haven't implemented all the logic for that yet, let's assume that it always changes when the authentication status changes. So even if the token expires, the user subject will emit a new value, which is then null, because then the user is invalid. We haven't added that logic yet, but we will add it. So let's assume that the subject here is our source of truth, and therefore the header component, since it's always there in our application, can subscribe to that subject to update correctly based on the user status. So in the header component TypeScript file, we can now inject the auth service, which is of type auth service, of course, and you need to import auth service from that path. And we can then add ng on init by adding the on init interface here, which is also imported from @Angular core. And inside of ng on init, I want to set up a subscription to this auth service user. So we can set up a subscription here. And as you learned in the RxJS section, such subscriptions should be managed by you so that you unsubscribe if it's not required anymore. For that, I'll add a new private property user sub, which is of type subscription. And subscription is imported from RxJS, so this import needs to be added to the header component. And with that added, we store the subscription in that user sub property. And now also add on destroy here, which is also imported from @Angular core, so that we are forced to add ng on destroy where we can clear that subscription. So here I call this user sub unsubscribe. The more interesting part for us, of course, happens inside of subscribe here, because there we get a user object. And now, as I mentioned, let's rely on the fact that this user is either null if we're not logged in, or exists, so if it's the user object is not null, but it's a concrete object, if we are logged in. So if we have a user, we are logged in. That's the core idea. Therefore, let's add a new property here in this component, which you could name is authenticated. Of course, the exact name is up to you. And let's assume by default that is not the case. So it's false. Is authenticated is false. Here in this subscribe function, when we get a user, we then set this is authenticated equal to a check. If not user, then I want to set the value to false, because then we are not authenticated if we have no user object. Otherwise, it's true. Now, this is the check I want to have, and we can actually shorten this. We can write not user. This might look strange, but it's a little trick where we basically check if we not have a user, which will be true if the user is null and false if we have a user object. But that is the opposite of what we need. Hence, I add an extra exclamation mark to then inverse this value and get true or false. To be precise, I get true when we have a user and false if we have no user. And in case you want to see what's happening there, simply console log not user and then console log not user. And you will see what's happening here. So with that, we change is authenticated. Now in the header component, we can use that property to update it appropriately. Recipes should only be visible if we are authenticated, and therefore with ngIf, we can make sure it's only visible if is authenticated is true. So ngIf is authenticated is added to this link, or actually not just to the link, but to the entire list item here. The authentication link here, on the other hand, should only be added if we're not authenticated. So add an exclamation mark in front of is authenticated. Shopping list should always be visible, so nothing needs to change here. Logout should only be visible if we are authenticated, because if we are not authenticated, we clearly can't log out. So this should only be visible if we are authenticated, so without an exclamation mark here. Now this drop down here should also only be visible if we are authenticated, because if we're not authenticated, we can't fetch and store data anyways. With that, if you save this and this reloads, you should only see authenticated and shopping list as a default, because we start non-authenticated. But now if I do log in here with valid credentials, this changes and you see the user interface also changes. You see now we have recipes, we have shopping list, we have logout and so on, and we don't see the authenticate page anymore. Clearly, we can reach it if we manually visit /auth, and this reloads the app anyways and loses our authentication status, by the way. But that's a different thing. The important thing here is that the user interface updates correctly. Now, with the user interface updating correctly, before we work on things like storing the token and protecting certain routes so that we can't visit them even if we directly enter the URL, before we dive into that, let's make sure we now actually can use our token to fetch data, because that is still not working, even though we are authenticated. Why? Why is our authentication status ignored when we try to fetch data? Well, because just because we know that we are authenticated and that we have the token somewhere in our user object, Firebase doesn't know that. We're not attaching it to that outgoing request, and therefore Firebase has no chance of understanding that we have a valid token. We need to add that token to the outgoing request to let Firebase know about that. And for that, we need to manipulate our outgoing HTTP requests that are related to data storing and fetching. Hence, we need to look into the data storage service where we have fetch recipes and store recipes. And these requests here now need to be edited such that we do attach our token to them. The token we are storing in the user object in the auth service. For that, let's inject that auth service here into the data storage service. Of course, make sure you add the import path. And now we need to get access to the user in both store recipes and fetch recipes because we need to get the token there. Now we could set up a subscription to the user, But I don't care about every change to the user. Instead, when we try to store or fetch recipes, I just want to get the token of the currently authenticated user. I don't want to have an ongoing subscription. Hence, in the auth service, we now should also store the token or the user in a way that we can access it through different means. So not through a subject, which is great for reactively updating the user interface, but that we also have a way of on-demand fetching of the user data. Now, there are a couple of different ways of achieving that. Since we're only interested in the token, we could just store the token here in a variable, which is null initially and which will hold a string eventually, where we set the token whenever we also emit a new subject. That would be possible and wouldn't be wrong. But we can actually also use a different type of subject here. This subject is a subject to which we can subscribe and will get an information whenever new data is emitted. Now, actually, there is a different type of subject RxJS offers, which is called behavior subject. Now, this is also imported from RxJS, and generally it behaves just like the other subject, which means we can call next to emit a value and we can subscribe to it to be informed about new values. The difference is that behavior subject also gives subscribers immediate access to the previously emitted value, even if they haven't subscribed at the point of time that value was emitted. That means we can get access to the currently active user, even if we only subscribe after that user has been emitted. So this means when we fetch data and we need that token at this point of time, even if the user logged in before that point of time, which will have been the case, we get access to that latest user. Now, therefore, behavior subject also needs to be initialized with a starting value, which in my case will be null here. It has to be a user object, and null is a valid replacement because I don't want to start off with a user. Now, we don't need to change anything in the auth service. We still emit our user as we do before with the next function. But in our data storage service, now we can reach out to the auth service user, get the currently active user, and be done with that. And that's just what I want to do here, for example, when we fetch recipes. So here, we reach out to the auth service, there to the user, and now the thing just is, I don't want to set up an ongoing subscription, and still I need to subscribe to get that user. So to make sure I only get the user once, and thereafter I'm done, of course we could manually immediately call unsubscribe thereafter, or you use pipe, and then a special operator RxJS gives you, and that would be the take operator. Take is also imported from RxJS operator, and take is called as a function, and you simply pass a number to it. And I pass 1 here, and what this tells RxJS is that I only want to take one value from that observable, and thereafter it should automatically unsubscribe. So this manages the subscription for me, gives me the latest user, and unsubscribes. And I'm not getting future users because I just want to get them on demand when fetch recipes is called. So whenever this code executes. I don't want to set up an ongoing subscription, which gives me users at a point of time I don't need them anymore. So thereafter here in subscribe, I get my user object, but only once. And we don't need to manually unsubscribe. In there, we can then use this HTTP request observable and set it up in there and attach our token, which we get out of the user. The problem just is, here we're in subscribe of an observable, and here we create yet another observable. And in the end, I want to return this observable here, but returning from inside subscribe does not work. We have to return on the top level of this method. The solution is that we pipe these two observables, the user observable and the HTTP observable, together into one big observable. And now this is getting a bit more advanced here related to RxJS, but still pretty easy to understand in the end. You simply add another operator here to pipe for the user observable. And there we can use exhaust map. Exhaust map is also imported from RxJS operators, and whilst the name might look strange, it does something very simple. It waits for the first observable, for the user observable, to complete, which will happen after we took the latest user. Thereafter, it gives us that user. So in exhaust map, we pass in a function. There we get the data from that previous observable. And now we return a new observable in there, which will then replace our previous observable in that entire observable chain. So we start off with a user observable, and once we're done with that, this will be replaced in that observable chain with the inner observable we return inside of that function we passed to exhaust map. So in there, I will return this HTTP request where I get my recipes. This is now returned inside of exhaust map, and therefore this entire observable chain now switches to this HTTP observable. Now regarding map and tab, which we used before, we can cut that. And since we already are in a pipe method call here, and we added take and exhaust map, we simply add the other two operators as next steps after the exhaust map. And then we return this overall observable. This means that we can still subscribe to that observable returned by fetch recipes, and in the end it will be an HTTP observable because we switch it here. We then also apply all the other operations we did, and to the outside world nothing will change. But inside we utilize this user observable, got the user out of it one time only, unsubscribed to that observable, and then automatically replaced it with a new observable here. Now, of course, this alone doesn't do everything. We got the user now. Now we can extract the token. And how do we add the token now to this request? Well, for Firebase and the real-time database REST API, which we're targeting here, we add a token as a query parameter in the URL. For other APIs, you add it as a header in the request. For the Firebase real-time database API, you add it as a token, as a query parameter. That's just how it is. You can read that in the official Firebase docs. Now, to add a query parameter, we got two options. We can do it manually by setting a question mark, and then the parameter name has to be off. That is what you can learn in the Firebase docs. And you set it equal to plus user token. Or, to not set it manually like this, you add a second argument to the get method, which is an object where you can set the params, as you learned in the HTTP client module. And there you set the new HTTP params object here, where you call set, and then you set auth equal to user.token, like that. And HTTP params needs to be imported from @angular/common/HTTP. Now, what if that token would for some reason be undefined? If that would happen, we wouldn't have a big problem. Our request would just fail because we send an invalid token to the backend then. But we will later also add code to automatically log the user out when the token expired, so we shouldn't even get into such a situation. So let's save that. Let's go back to Authenticate and log in here. And let's now try and fetch data. And that looks quite good. Here's our data, and if we inspect the network tab, and I have a look at this request, this it is, here under headers, let me increase this a little bit in size. Here under headers, you see that this auth parameter was added and that this is our token, and it seems to work since we fetched all the recipes. So that is working, which of course is great. So with the token added to fetch recipes, obviously we also want to add it to store recipes. Now we can use the same logic we used in fetch recipes in store recipes. But since we're using the Angular HTTP client, we could also use another feature offered by that client. Because what we do here in the end is we manipulate all these outgoing requests in the same way. What could we use here? An intersetter. So let's add such an intersetter here to use that intersetter to manipulate our requests instead of manually doing it twice. I'll add it in the auth folder because I'll name it auth-intersetter.service.ts because it is an authentication related intersetter. And the class name therefore will be auth-intersetter-service. And since I'll plan on injecting something there, let's add @injectable like this, and import injectable from @AngularCore. Now, important, don't add the object with provided in root here, because we will provide this differently. As you learned in the HTTP section, we have to provide it such that Angular understands it. Now, this service should implement an interface provided by the @Angular common /HTTP package, and that interface would be the HTTP intersetter interface here. So let's add implements HTTP intersetter here, and that forces us to add an intercept method, and that intercept method actually needs to get 2 arguments: the request, the HTTP request, which is a generic type of type any, so we don't know which data all the requests will return, and we have next, which is our HTTP handler. And you need to import these types from @Angular/common/HTTP, and definitely watch the HTTP client module to learn more about that. Now there you also learn that you need to return next handle and pass in your request. However, not the request like this, but actually I want to edit the request and add my token. Therefore, let's add a constructor and inject the auth service here, which is of type auth service. And that service needs to be imported. So let's import auth service from /auth service. And with that injected, we can now reach out to the auth service, to the user, which is a subject and therefore an observable, and subscribe to it. Now, we have the same problem as before, though. In the end here, we need to return an observable. This also is an observable, and therefore I'll solve this problem in the same way as before. In the data storage service, we used pipe, take one, exhaust map, and so on. It's pretty much the same now. I'll grab this code here with the exhaust map and the pipe method, and we'll fix it here in a second, and go to the auth intersetter and use this code in that place. Close all parentheses. Import these operators from RxJS, of course. So import take and exhaust map from RxJS/operators so that this works. And now, since we got the user in here, in there we can return next handle request, and we can edit the request based on the user here now. And we return this overall chain, which just as before will be a chain that in the end has this handle observable being returned, because we swapped the user observable with that one in the map function here, in that map operator. So all we have to do here now is we have to clone our request and update it. So the modified request is created by calling request clone, and to clone we can pass in an object where we can update the params by setting them to a new set of HTTP params, which is imported from @Angular/common/HTTP, where we call set and pass in the params. So auth is the name of the param we need, and user.token is the value. Now, of course, we should handle the modified request, and with that, this intersetter should add the token to all outgoing requests. Now let's make sure we provide that token in the app module. Here under providers, I want to add a new object where I add the provide keyword and use HTTP intersetters, which is imported from @Angular/common/HTTP. This is the identifier for this provider. Then use class, and there I'll use the auth intersetter service. For that, we need to import that service here at the top. So let's import auth intersetter service from the auth folder, and there the auth-intersetter.service file. And last but not least, as you learned, set multi to true to allow for multiple intersetters, even if you're only using one. So now with that, the intersetter is added here. Now we just need to fix the data storage service again, because now we don't need to use the logic we had in there a second ago, because we now moved that into the intersetter. So now we directly return this observable, and we simply call pipe there and pass in map and so on into this pipe. We don't add the params here as well. Now we should use this intersetter for outgoing requests. If we now go to Authenticate and we log in again, we get an unknown error. Do you have any idea what could be the reason for that error? It becomes clear if we inspect the outgoing request here. We're trying to log in, so let's retry this here with the cleared request tab. And somehow, no request gets sent at all. So our request fails before it even gets sent. And that is actually stemming from our auth intersetter. Because there, we're using that logic for every outgoing request, including our sign up and login requests. Now, when that happens, what we try to do is we subscribe to the user service and we get null as a user, therefore, because this is what we initialize our user at the beginning. Here it is null when our app loads. So user here is null, and therefore when we try to access the token, this fails because we try to access token on null, this throws an error, and the request doesn't even get sent. How do we work around that? Well, we can add a check here and check if we don't have a user. Then we just return next handle for the original request, so we don't try to modify it. We only try to add the token if we have a user. Alternatively, or in addition, you could also check the URL of the outgoing request and only add the token for specific URLs or exclude certain URLs. But here, this should do the trick already. So now if we try logging in again, this looks way better. And now if I try fetching data, this also still works, but keep in mind that this now uses the intersetter. The advantage of the intersetter now, of course, is that this also automatically works for storing recipes, because this uses the same intersetter automatically. So if I delete a recipe and I click Save Data, you see this also succeeds. Otherwise, we would have an error down there, and we can also prove it by fetching data again. This doesn't change, so we are not fetching a third recipe because we overrode them on the server with our save action. So that's the intersetter in action. Before we move forward and make sure we also store the token in a persistent way on our computer so that it is also there if the app reloads, because at the moment reloading means we lose our state and we're logged out again. So before we take care about that, and before we then also protect certain routes so that we can't even visit /recipes if we're not logged in, before all of that happens, let me make sure that logging out works, so that if I am logged in, clicking the logout button here does log us out. And for that, let's go back to the auth service, and in there where we have sign up and log in, let's add a log out method. And logging out is super simple. In the end, we just use our user subject and we call next and we pass null to set our user to null. That's our initial state, and that's now the state again. And this will make sure that our entire application treats the user as unauthenticated, because that's the logic we used everywhere, and therefore now we should update our UI, and also our intersetters will not work correctly anymore for requests that require authentication, which is exactly the behavior we want, because we can't authenticate ourselves anymore. The missing piece, of course, now just is that we link this logout method to our header. There we have that logout button. Let's now add a click listener there and call on logout maybe. And in the header component TypeScript file, we can add on logout here and use the auth service, which we're already injecting, to call logout. And now let's give this a quick try. Let's authenticate, log in, and if I now click logout, this works. One nice thing would be that we are redirected. And now here, I'll not do it in the component, but in my service, because whilst I only have one place for logging in my application, which is the auth component, there are multiple possible sources which could lead to a logout. It's not just the header component. We will also add logic to automatically log us out once the token expired soon. And therefore, I want to redirect here in the logout method in my service, in this method here, and not in a component. So therefore, let me now inject the router here into that auth service. Router, as always, needs to be imported from @AngularRouter. And with the router injected, we can redirect here in the logout method, again, to make sure that no matter how we're logged out, we always redirect the user and we're not stuck on some component on some page where we can't do anything anymore. So there, let's redirect to /auth. I guess this makes sense once we're logged out. Let's give this a final test. If I do log in here and I log out, I'm back on Authenticate. So that is all working, that is all nice. The next mission will be to persist the token so that it is still there once we do reload the app. We got the general authentication flow up and running. Well, we're not protecting unauthenticated access to the recipes route. We'll do so soon. First of all, though, I want to make sure that once we are authenticated, we don't just keep that status as long as we're navigating around in the app, but that we also keep that status, that we also keep that token which we have once we reload the page. Because at the moment when we reload the page, we lose all that status, because when you reload the page, your Angular application restarts. The old one is basically dumped. And since right now we're managing everything in memory, remember that we're storing the token in a user model which happens in JavaScript only and which therefore happens in memory. Since we managed it all in memory, we'll lose all that state whenever the application restarts, because that memory gets cleared automatically. There is no connection between the last time we ran this Angular app on this web page and the current time. So there is no connection and the memory is lost. So if we want to store that token, we have to store it somewhere else and not in a JavaScript variable or a class property. We have to store it in a persistent storage that survives page reloads and browser restarts, that we can write to and that we can fetch data from. Now, what would be such a storage? In a browser, you got different storages. You can't access the normal file system on your device, but you can work with cookies or with local storage, which is an API exposed by the browser to store simple key value pairs basically on the file system but controlled by the browser. And we will use local storage here to store that token. To do that, let's go to the handle authentication method in the auth service, which is where we do create our user object and emit it to our application. And there, besides emitting it to the application, we also want to store it in our storage. And for that, you can simply use local storage and call set item. This allows you to write an item to the local storage and to store data there. Now there, I will give this a name of user data, and this name is up to you. This is basically the key by which you will be able to retrieve it later. And then you have to write some data to that key. You can store some data there. Now, the data I want to store there should just be that user object, because that contains all the data I want to save. The email, the user ID, the token, and the expiration date. These are the pieces of data I want to store. So we can write the user to the local storage, though not like that, not as a JavaScript object. Instead, we have to convert it to a string. We can do that with the JSON object and the stringify method. That is built into JavaScript, and it simply serializes a JavaScript object. It converts a JavaScript object to a string version of it, so to say, so to text, and that text is getting stored in the local storage. Let me show you how this works. If we save that and the application therefore restarts, if we go to Authenticate and we do log in here, it works as before, but now in the Chrome DevTools, if you go to the Application tab there, you can go to Local Storage and expand this, and there pick your storage, and you should see that user data key there now, and in there you find that data you just saved to the storage. And this is all text. It's the JavaScript object converted to a text. Hence, you there see the email, you see the long token, you see the token expiration date. All of that is stored in there. Now, and with all of that being stored in there, we can of course also retrieve it from there when our application restarts. For that, we can add a new method, which I will name auto login, because it basically is a method that will try to automatically set the user to log in when the application starts. And it will do so by looking into the storage and checking whether there is an existing user snapshot stored. So in auto login, the goal now will be to retrieve data from the local storage. For that, we can access the local storage and get our user data item. And that is a synchronous method which gives us our user data like that. So we can retrieve user data from local storage just like this. The first thing which I'll do then is I will check whether that exists. If we don't have user data, so if this is false-ish, we can return, because in this case, well, we can't log the user in. There is no stored user data, so the user definitely needs to sign in on his own. Otherwise, if we make it past this check, user data is set, and there is some snapshot we were able to retrieve from that local storage. Now, important, the snapshot we're retrieving here is also a string, because we're saving it as a string down there. And therefore, if we want to work with that as a normal JavaScript object, we have to convert it back by calling JSON parse here. And this will simply just take the string in JSON format and convert it back into a JavaScript object. Not into our user model, though. It will not have this token getter, for example, but into a simple object literal, which has all the keys that we stored in that storage. So basically, this string here converted back to an object literal in JavaScript. With that, here in auto login, we can create a new loaded user by calling new user. And there we now can pass in data from that user snapshot we're loading. Now we can add a type annotation here to be more specific about which type of data we'll have in that snapshot. And that will have an email which is of type string, we'll have an ID which is of type string, we'll have underscore token which is a string, and we'll have underscore token expiration date. Is that what I named it? This key here, we'll have that in here as well. And this will also be a string, not a date object. We'll have to convert this manually. So that's the data we're fetching from the local storage. And therefore now when we create a new user, we can pass in user data email, we can pass in user data ID, we can pass in user data underscore token because our token getter, as I mentioned, is part of the user model, but we can't save methods in a JSON snapshot, and therefore it only contains the properties we had in there, which are these 4 properties. So we retrieve the underscore token and also the expiration date. We just need to convert this to a date object again, which we can do with the built-in date constructor, to which we simply pass our token expiration date string. Because that string is basically a date format string, you can see it here at the bottom, and JavaScript is smart enough to convert this back into a date object. This is now the loaded user with whom we can interact. And there we first of all need to check if this user has a valid token. So we can simply check if loaded user token, if that is true-ish. Now remember, token now is a getter, because now we're working with the model again. And in that token getter, we are comparing the token expiration date that was stored with the current date. So this will return null, which is a false-ish value, if there is an invalid token, if the token expiration date is in the past. So this will only be true-ish if it is a valid token, which still has an expiration date in the future. And therefore, only when we make it into this if check, we want to emit this loaded user as the currently active user. So in here, we can then access this user, our subject, call next and forward the loaded user as our new authenticated user, because at this point of time, we know we have a user with all the data we loaded, and the token also still is valid. So this is our logged in user. This is the auto login function. Now let's see if it works. Let's go to a place that runs early in our application lifecycle, and that would be the app component, because this runs as soon as the app starts. Don't need these functions in there. Let's now implement onInit here, so that we are forced to add ng onInit. Can also get rid of that feature selected part here in the app header, by the way. This is all something we don't need anymore. We're not using that function anymore. So back to the app component. Here in ng onInit, in the app component, I want to use the auth service. So it's time to inject it here. Auth service like that. Make sure to add the import path at the top so that this gets imported correctly. And with that injected in ng onInit, let's call this auth service autologin to see whether that works. If I now save this, theoretically we should log the user in automatically because we have a saved snapshot. And indeed, if I reload, this looks good. The entire user interface, the entire header, signals that the user is logged in. Otherwise, we would not be seeing the recipes page and the logout button here. So automatically logging the user in seems to work correctly here. Having the auto login in place is great, but what about an auto log out? Because our token will expire. It has an expiry time of 1 hour once we get it. And therefore right now we have a bug in the app because this token will never expire, or the token will expire, but our application won't reflect that. We will automatically log the user in forever because we now have that snapshot here. And we never clear that snapshot. And sure, we could clear it when we log out, and we should do that, and we will do that. But it will never clear automatically. If the token expired after 1 hour, nothing changes in our application. And that, of course, is something we have to change. So first of all, in the auth service, we should make sure that since we store a snapshot upon logging in, we also clear that snapshot here in the logout function. Because if a user logs out, we certainly have to clear everything about that user in our application, and that includes the local storage. So here we should take our local storage, and we can simply call clear to clear all the data in the local storage. That, however, only makes sense if we have no other data in there. If we do have, then we clear that as well. So it's better if we don't clear all the data, but instead if we call remove item and we just remove that user data key and the data that's stored there. Now that's step number 1, that we do actually clear the data when we log out. But now we also need to set a timer when the token is stored, or when we first get a token, so that we know when to invalidate that token at a later point of time. And for this, I'll add yet another method here, which I'll call autologout. We have autologin for automatically retrieving user data and logging the user in. Now we need a method that sets a timer and manages a timer for automatically logging the user out. Autologout should get the expiration duration here, which is a number, as an argument. So this will be the amount of milliseconds we have until the token is invalid, let's say. Of course, you could write this in a different logic, but I will go with milliseconds, which we get as an argument here. And then we can use set timeout in here to set that to that duration. And after that duration here, I want to call this logout. So the logout function we have here should be called automatically after our expiration duration. Now, the important thing is that when we do log out, we clear that timer. Because if we log out automatically, then it's no problem. Then the timer expired. But if we log out manually because this button is pressed, we also call logout, and then we still have that timer in the background, which calls logout again at a later point of time. Now, we don't want to do that. If a user logs out on his own, then the current session, so to say, the current lifetime of the token we have ends anyways, and therefore we should also clear that token expiration timer when we log out. Now, clearing that timer is not too hard. We simply store it in a property, which we can name token expiration timer, but you can name this however you want. And this will actually be of type any. And now let's store our timer down there. Set timeout returns a reference to that timer. So we can simply store that in token expiration timer. And in the logout function, we now just have to clear that timer. So in there, in logout, we should check if we do have an active timer. because maybe we don't. Maybe it expired anyways, then we can't clear it. But if we do have an active one, so if this is true-ish, then we should clear our timeout here and set this token expiration timer, or pass this token expiration timer into clear timeout. And this will, clear the token expiration timer. And thereafter reset token expiration timer back to null manually. So now we clear the timer when we log out, and we also set it here. Now, of course, we just have to make sure we do call auto logout, because currently we aren't doing that. And we need to call auto logout to make sure that this timer actually starts. Now, where do we need to call that? Basically, whenever we emit a new user to our application. So whenever we use our user subject. And that would be the case here in handle authentication and also in auto login. Now, let's start with handle authentication. There, we do emit our user. Now, right after doing that, or right before doing that, doesn't matter, we should call auto logout and pass our current expiration time into that auto logout function. Now, the current expiration time, of course, is our expires in value here, which is in seconds, times 1000. Because we expect milliseconds in auto logout, since expires in is in seconds, times 1000 gives us the amount in milliseconds. Now, that's handle authentication. In auto login, it's a tiny bit more complex. Here, when we know that we do have a token and we therefore emit our user to the application, there we also want to call this auto logout. But here, we now have to calculate the remaining time. We do have our token expiration date after all, and of course we can always find out what the current date is. So our expiration duration is basically this timestamp here. So the token expiration date wrapped into a date in milliseconds, which we get by calling getTime, minus the current timestamp, which we get with new date, in milliseconds with getTime. So future date, the token expiration in milliseconds, minus current date in milliseconds, gives us the difference in milliseconds, and that is the duration we have until the token expires, which we should pass to auto logout. Therefore, now this reloads, and we're logged in. Now, if I call logout, we wipe our data and application, and we are logged out, of course. And now let's try if our timer works correctly. And to simulate this, I'll manually set this to 2000, only temporarily, so that this expires after 2 seconds, so that we can't really see if it works. And let's now log in. And we see our user data snapshot here on the right, and now it's gone, and we're redirected, because now we logged out after 2 seconds. So auto logout seems to work. Let me now reverse this to the expiration duration, which we of course want to have here. We don't want to have that extremely short horizon here. Instead, let's log the expiration duration and see what we get there. If we do log in again, like this, then we see this here is 1 hour in milliseconds. And if I reload, you see now it's a shorter value. This comes from auto login, and that is the remaining duration we have. So this doesn't look too bad. This looks like it's working correctly. Still, there are things we should improve. For example, we can still visit the recipes route when we are not logged in. I can just type it here, and here I am. This is something we definitely want to prevent in our application. So how can we prevent that users can visit /recipes if they are not authenticated? Do you remember the routing section? There we had a look at route guards, and that is exactly what we need here. A route guard allows us to run logic right before a route is loaded, and we can deny access if a certain condition is not met, and this is exactly what we need here. For that, in the auth folder, let's create a new file, and I'll name it auth.guard.ts, and that will be my, well, as the name suggests, authentication guard. And in there, let's export a class authGuard, which should implement the canActivate interface. Now, this is imported not from this path, but from @angular/router, And since this technically is a service, and of course you could name it export class off-guard service, therefore, since this is a service, we need @injectable here. Whoops, injectable, like this, which is imported from @AngularCore. And here you can use provided in root to provide this application wide if you want. Again, you could also add it to providers in the app module. So that is the auth guard. Since we add the canActivate interface here, we now have to add the canActivate method. The canActivate method has to be implemented in a certain way. It receives the currently active route, which is of type activated route snapshot. And you can, by the way, see this if you press Command or Control and click on the interface. Then you can see the definition here. So we get two arguments, the activated route snapshot and the router state snapshot. So that's the second thing here, router state snapshot, both imported from @AngularRouter. And canActivate then has to return either a Boolean or a promise that eventually yields a Boolean, expressed here by using this generic promise notation, or an observable, which eventually will yield a Boolean. And for that, you also need to import observable from RxJS. This is how canActivate should look like. And right now we're getting an error because we are not returning anything when we are expected to return a Boolean, a promise, or an observable. Now, what can we return here? We want to return the status as we can derive it from our auth service. So here, let's inject the auth service, which is of type auth service, and which you need to import from the auth service file. And then in there, we can find out whether the user is authenticated or not by looking at that user behavior subject. So here we can access this auth service user, and now don't subscribe here but return it instead, because this already is an observable. It's a subject and therefore also an observable. However, not an observable that returns a Boolean. Instead, it is an observable that in the end returns a user object. But this can be fixed easily. We just add pipe and use the map operator, which is imported from RxJS operators, to transform the observable value here. So we get our user, and we want to return true or false, so we can simply return exclamation mark user, which is that trick which converts a true-ish value, like an object, so anything that is not null or undefined, to true, so to a real Boolean, or that converts a false-ish value, like null or undefined, to a true Boolean, so to false in this case. So now we have an observable that really will return true or false, and that should allow us to use that activate guard in front of the routes that we want to protect. So now with canActivate added here, let's go to the app routing module. And here, of course, it's this path here, the recipes path, which I want to protect. So in there, we can add the canActivate key, which is an array of all the canActivate guards you want to register for this route. And here it's only one route, it's the auth, only one guard, it's the auth guard, which you also need to import, of course. With that changed, let's save that and let's see if it works. That doesn't look too bad. We are kind of stranded here, and we should take care about that, but at least we can't access /recipes. Though, is this really the right behavior? Let's have a look at application. This is empty, so let's try logging in now, like this. And we can visit recipes, so here we are granted access. This is looking good. And now let's reload the recipes page. And this also works. So indeed, this works, and it gives us the right data. The guard works correctly here. What we should make sure, though, is that when we log out and we manually try to go to /recipes, that we actually redirect the user to a page where he can do something like the authenticate page. And to do that, we can go back to the guard. In there, we are returning true or false. But now if we have a closer look at the canActivate interface by Command or Control clicking on it, we see we can actually return more than just observables or promises or booleans. We can also return a URL tree or a promise or an observable that yields a URL tree. This is a relatively new feature, and it was added basically for this exact use case for authentication. It was added so that you can redirect users when the URL they're trying to visit is blocked. So for can activate, for this guard, which you often use in connection with authentication, you have now a more convenient way of redirecting users. In the past, with older Angular versions, you had to manually redirect. So for example, here, you would have added a tab, RxJS operator, which you need to import, by the way. And there you would get that is auth information, because map gives us true or false, is the user authenticated or not. And then here you could check if not is auth, you know, okay, I don't want to grant access. Then you would inject the router like this from @AngularRouter, of course. And with the router injected in here, you would call this router navigate and go to /auth, for example. And this works. If I save that and the app reloads, you see, if I type recipes here, I automatically go to auth. Nothing wrong with this. But in some edge cases, this could lead to race conditions with multiple redirects that kind of interfere with each other. And therefore, instead of using this approach, you can now also use a different one and not return true or false here, but return true if you want to grant access, but not false otherwise, but this URL tree. So here I'll store the result of my conversion here in isAuth. And if we have isAuth, so if this is trueish, then I will just return true. Otherwise, I want to return a URL tree. And now such a URL tree can be created with the router, which you still need to inject therefore. But there you can now call create URL tree. And there you can simply pass in your normal array of segments, of route segments you want to navigate to. So for example, /auth. I'm getting an error here because the types I added here don't include the URL tree. We just need to update this to meet the specification of the interface. And yes, a URL tree is allowed there. You just need to import that type from @AngularRouter. And then it is fine to return an observable that either yields a Boolean or an URL tree. The same for a promise, and also instead of a normal Boolean. So returning a URL tree or promises or observables that yield URL trees are okay. We're doing that here. And therefore now if we save that, we get the same behavior as before. If I visit /recipes, I'm forwarded to auth. If I just try to load localhost 4200, we also go to auth, because if we just try to load the page as it is there, first of all, we get redirected to recipes, but there we then have the guard, which then continues redirecting us to auth. So now we have an auth guard in place that should do its job and that makes sure that we really can only reach the recipes page if we are logged in. But there we can reach it without issues, even if we reload the app, because we're using auto login, but also auto log out to clear everything once our token expired. Now with that, we're almost done with the guard, but there's one thing I want to edit in this auth guard. Right now, we're subscribing to our user service here. We're mapping that value into true or false, and we are returning a URL tree if it is false, and if we want to redirect. The one issue we have here is that we essentially set up an ongoing subscription here, though. This user subject, of course, can emit data more than once. And I don't want that here. This can lead to strange side effects if our guard keeps on listening to that subject. Instead, we want to look into that user value for one time only and then not care about it anymore unless we run the guard again. And therefore here, just as in other places too, we should use take1 to make sure that we always just take the latest user value and then unsubscribe for this guard execution, so that we don't have an ongoing listener to that, which we really don't need. And therefore here you need to import the take operator, the take RxJS operator, and add it here in front of map so that we don't have an ongoing user subscription. With that, if you save that, you see I can still visit recipes here after reloading, so the guard generally still seems to work. But now if I log out and I try to access recipes, we fail, as we should. If I now log in again, we succeed. So the guard now still works as before, but now we avoid nasty bugs which could occur due to us rerunning the logic in the guard when we really don't want to rerun it. That's it for authentication. In this module, we added an auth service to our Angular application to manage the entire front-end authentication logic we need. That includes signing user up and signing the user in based on the inputs in that form here. It also includes things like switching between sign up and sign in, showing error messages, and storing a token that we then get after a successful login. We're also storing the token such that it persists once we reload the page. And we can also use that token to then fetch data and save data from our now protected Firebase backend. Again, as I stressed throughout this module already, Firebase is just one example here. The general logic of how you exchange tokens always is the same. Now, you also learned that there is more to managing the token than just logging in and getting a token. You don't just want to store it in memory, you want to store it in a place that survives browser reloads. And you want to make sure that it is cleared once it did expire. We also used a routing guard, to protect a route against unauthenticated access, our recipes area in this case, with help of the auth service and the logic we have in there. Last but not least, we made sure that the header is updated correctly based on our authentication status, which in turn is derived from our auth service and the user we're storing there in this behavior subject. Behavior subject because unlike a normal subject, this always gives us access to the previous value, and that simply helps us ensure that we can get access to the user even if in this part of the application where we need it, we missed the previous user update. And that's it for authentication. I hope you learned a lot here and you now feel confident adding authentication to your applications as well. In this module, we'll have a look at components again, but now at dynamic components. Now, what are dynamic components? Dynamic components are essentially components which you create dynamically at runtime. So let's say you want to show an alert, you want to show a modal, some overlay, which should only be loaded upon a certain action. For example, you have an error and you want to not show that error box, which we're currently showing in our course project, but you want to show an overlay on the entire screen or something like that. That could be done or could be implemented by using dynamic components. And dynamic components is not a specific term, not a specific feature provided by Angular, but we can simply add components that we load through our code. And that's exactly what we'll do in this module. You will learn how to create such a component and how to then load it on demand, how to communicate with it, and also how to get rid of it. For that, I'm back in a course project, and the part I want to handle with dynamic components is here on the login when I enter incorrect credentials. At the moment, we then have that spinner and then we see that error message there. Now, nothing wrong with that way of displaying an error. It's perfectly fine, you don't have to change that. But to demonstrate how you could load a component dynamically, I will change it. I will not use that box here, but instead we'll build a very simple alert box, which is presented as an overlay here on the screen with a nice backdrop that hides the background. And in that alert box, we can then simply click OK to get rid of it and have another try here. So that's the idea. Let me now go back to code. And here, the goal now is to first of all build such an alert. And I'll do that in the shared folder. I'll name that alert. And in there, I'll create my alert.component.ts file where, well, I want to build that alert component. Now, my alert component here will be a simple box that, is loaded as an overlay on the entire screen. And therefore, let's here export a class, alert component like this, and give it that add component decorator. Now, in that decorator, I'll assign a selector, app alert, and add the template URL where I want to point at an external template, the alert.component.html file, which we therefore also have to create in that same folder. And that is my basic component for now. Now, the alert component here then receives, of course, some markup. And here I will include both the backdrop and that overlay box in one and the same component. Of course, you could also split this into multiple components. So here we'll write some custom CSS actually, and I'll add a div with a class of backdrop. That will be the backdrop, so basically that thing in the background that blocks access to the rest of the page and ensures that the focus is on the alert box. And that box is the second div I'll add here. I'll give that a class of alert box, something like this, to not interfere with the alert class provided by Bootstrap, because I don't want to use that. And in that alert box here, I'll keep this really simple. I'll just add a paragraph where we can output the message with string interpolation, and that is referring to a message property we haven't added yet to the component. We'll do that soon. And I also want to have a button to close that alert. Therefore, I'll add another div here. I'll name this alert box actions. So that's my class name here. And in that div, I'll add a button with class button primary. Now I'm using Bootstrap classes here again to get that button styling. And here we can just say close. So this could be an alert box. It's missing some styling. So let me add an alert component.css file here as well and point at that file in our component declaration here. So style URLs receives a pointer at alert.component.css. So far, so good. Now, in the alert component, I do have that message property which I want to output. And therefore, in the alert component TypeScript file, we need that message property. And that will be a string, and it should be settable from outside. And therefore, you learned that we can add @input here. And the input needs to be imported from @AngularCore to make this settable from outside. With that, the alert component is almost finished. Let's now add it to the app module here. Add it to the declarations there, the alert component. And now let's see how we could add it. Well, we could go to our auth component, to the template there, of course. And there, right now, I do have that alert box, which is shown when we do have an error. Now I'll comment that out and instead use app alert here. And there we have to set the message property, which we made bindable with @input. And I'll set this to error. And I'll show the entire alert box here with the app alert element only if we have an error. So now we're simply just showing our own alert component. So far, nothing too fancy, of course. Now, this custom alert component now will receive some styling, and I'll start with the backdrop, so that thing in the background. That will get a fixed position, top 0, left 0, a width of 100 VW actually, which is the viewport width, so not the not percentage to not take the container width, but the entire viewport width. A height of 100 VH to take the entire viewport height as well. Then a background of RGBA 00.75, which is a slightly transparent black background color. A set index of, let's say, 50 to be above all the other elements that could be there. And yeah, that should be it. Now the alert box, this is the other element we have, should also get some styling. First of all, this will get a position of fixed too. Top here could be, let's say, 30 VH to have it 30% inside of the viewport, to not have it sit right at the top of the viewport. The left will actually be, let's say, 20 VW. The width of this thing here will then be 60 VW, because then we have 20 to the left and 20 to the right to center this nicely. I'll not set a height. The height should be determined by the content that's in there. And I'll give it a padding, though, of, let's say, 16 pixels. A set index of 100 to be above of the backdrop. A background color of white. And a slight box shadow with these settings here to hopefully make it look good. So that's my alert box. Now we also have that alert box actions class, which holds that button where we can close everything. And there I just want to add text align right to push this all the way to the right. Now, of course, you can adjust this however you want. Let's see this. Let's wait for this to reload and then enter some incorrect credentials here. And here is our alert box. This is this nice modal now. And of course, you could go way more advanced here. You could use ng content to pass dynamic DOM into that box here, whatever you want. But this is our box. Of course, at the moment, we can't close it though. But creating that is the first step. Now, how can we load this dynamically? And of course, also, how can we then close it? It is important to understand that dynamic components in general just means that you wanna display some component dynamically, which means it's not always there, but it's there once something specific happens in your code. Therefore, you typically want to control programmatically when that component should be loaded, when it should be displayed. And you already learned about a way of doing that, and we're currently using that way. And that way is ngIf. ngIf is awesome because it allows you to use a declarative approach, which means you simply add that component selector in your template, and then you use ngIf to still only load it upon a certain condition. So you use ngIf to control whether the DOM really has that component or not. And therefore, ngIf definitely is a great approach of loading a component dynamically. It saves you a lot of extra work, which you will have to do with the alternative approach you're about to learn, and it's definitely worth a thought and has no major downsides. And at the moment, as I mentioned, we are using ngIf here in this project. We're using it in many places, and we're also using it for this alert box. And I'll show you how to finish the entire alert flow before we then have a look at that alternative. Nonetheless, what would be the alternative? The alternative is that you use something which in the past was named Dynamic Component Loader. Now, this was a helper utility that doesn't exist anymore or that you shouldn't use anymore. But in the end, it's now about a general concept, you could say, of creating a component in code and then manually attaching it to the DOM. So there you have to control in your code by yourself how that component is instantiated, that data is passed into it, and also that it is removed. So everything ngIf does for you, you have to do on your own there. Still, this approach can be useful. It also, of course, allows you to control it entirely from code, and you don't have to touch the template. Sometimes you might not want to do that, or you have no real way of adding the component to the template. And therefore, this is also an interesting approach. Now, we'll have a look at both here. We started with ngIf. Let's finish it up with that approach before we then dive into creating components and managing components from code. So we started with ngIf, and therefore at the moment our alert component here is simply included with its selector and controlled with ngIf. The huge advantage of this is that we don't have to manually create it, and we also can pass data in as we learn it here with property binding. It also means that listening to events is super simple and straightforward. If we want to make sure we can also get rid of that alert, all we need to do is we need to emit an event, and we make that event listenable from outside with the help of add_output, which you import from @AngularCore. And we could name this close, and this will be, or will hold a new event emitter, which we import also from @AngularCore. And that event emitter could now also transport some data, but here I'll actually add void as a type because I won't emit any data. I'll just emit the, hey, this was closed event. Now, to emit this, we need a method here. For example, onClose. And now this will be triggered whenever a user clicks this close button or the backdrop. So here we can register a click listener and fire onClose. And we do the same when the backdrop is clicked, let's say, to dismiss the modal in that case as well. So both these things, the backdrop and this button, will trigger onClose. And in onClose, we can now simply use the close event we created and manually emit it. Now this allows us to go back to the auth component, and in there we can now listen to close, and here we can now call on handle error, for example, whatever you want to name it. This is a method we now have to add to the auth component, maybe here. And in on handle error, I essentially just want to reset the error, so I'll set error back to null. And by doing that, the condition for displaying the error will be removed because we're using error here in ngIf, and if that is null, then this whole alert will not be shown anymore, and therefore this will then close the alert. So let's try this again. Let's enter invalid credentials. Here is the alert. If I click here, we get rid of it. If I now enter invalid credentials again, let's try the close button, works too. So now this is the finished flow with ngIf, and I strongly recommend using that flow. There are rarely situations where you absolutely need the imperative approach you're also going to learn about. Using this approach with ngIf is so much easier, and therefore really is an approach you should use when you have a scenario where you need to show some component dynamically when some condition is met. Nonetheless, let's now see how we could create that alert component entirely in code and control it from there. So now the alert will not be shown here by using ngIf, and hence I'll comment this out as well. And I'll not add anything to the DOM here, for now at least. Now my goal is to instead create that alert component dynamically and show it dynamically. And dynamically is the wrong word maybe, I mean programmatically from inside code. Now for that, we first of all need a new method, because now we have to write some code to show the error alert. And I'll turn this into a private method, show error alert. I added this to the auth component, and show error alert has to be called whenever we have an error. So here, when we set the error, we now have to call this show error alert. And of course, we could now also change the general flow to not set the error globally on a property here, but instead pass it here into show error alert. And that is what I will do here. I'll still set it globally because we used that in the past, but you wouldn't need that now because this error property now has no real use because we're not using it in the template anymore. Still, I'll leave it here because we used it in the past, but you don't need it anymore for this approach. Instead, show error alert will receive the message. So let's accept it here. It will be of type string. And in here, the goal now is to dynamically create our alert component. Now for this, you manually need to instantiate a component. Now, a simple approach you could take would be that you import your alert component here. So you go to the shared folder, import it from the alert folder, and then from there you import the alert component. Now we have access to the alert component, which we defined in that file. And now, of course, you could think that you simply create an alert component and save it in alert CMP constant maybe by calling new alert component. It is a class after all. Now this is valid TypeScript code, but it is not valid Angular code. This will not throw an error if you compile it, but it also won't work in any way. You can't work with that alert component then in the way Angular needs to work with it. Because Angular does a lot more than just create an object when it instantiates a component. It needs to wire it up. It needs to wire it up to change detection into the DOM. This here would be a normal JavaScript object, and that is not what Angular needs. So therefore, you can't create your own component like that. This here won't work. Instead, you need to let Angular create this component. And for that, Angular gives you a tool, the component factory. To get access to that tool, you need to inject something. And you don't inject the component factory itself. Instead, you inject a component factory resolver. Now, of course, it is up to you how you name that argument. And again, I'm using that trick here where this automatically gets stored in a private property. It's up to you how you name this, but the type thereafter is component factory resolver. And that's really important. It has to be the resolver, not the component factory itself. Component factory resolver is then imported from @Angular core. Now with the component factory resolver injected, in show error alert, you now use that resolver to get access to component factory. Yeah, sounds strange, right? But this is how the flow works. So there, you now use the component factory resolver, and there you have a resolve component factory method, which gives you access to a component factory as provided by Angular. Now to that factory, you have to pass the type of your component, which in our case here would be the alert component. Now you don't instantiate this, you don't have new in front of this or anything like that, you just pass in the type, so that Angular knows where to look for that component, which it then should create for you. This method here will return a component factory, or to be precise, an alert component factory. Not the component itself, just the factory. So this now is essentially an object that knows how to create alert components, which is a great first step at least. Now with that factory, we can use that factory to create a concrete component. But for this, we also need a place where we can attach it in our DOM. And we don't have that place yet. We need to tell Angular where we want to add that component. And now you could think that you use some way of getting access to some element. Let's say here we want to add it. So we add a div with a local reference, add here. And with add viewChild, we could get access to that, as you learned earlier in the course. But this is not how it works. Angular needs a view container ref, which you might remember from the directives deep dive section. A view container ref is essentially an object managed internally by Angular, which gives Angular a reference, a pointer, to a place in the DOM, you could say, with which it can interact. And this object has more than just like the coordinates where it sits. It has methods like, hey, please create a component here. And we need something like this. Now, to get access to such a view container reference, there is a nice trick, or actually not a hack, it's the official approach for getting access to it. We can create a helper directive. Now that directive could be named placeholder. You can name it however you want. And I'll name it placeholder.directive.ts. That's the file name. And in there, we export a class. I created this in a shared folder, by the way. I export a class, placeholder directive. And that will receive the add_directive decorator, of course. Now, this add_directive decorator needs one thing, and that's the selector. The selector here should be an attribute selector, so that we can add this directive as an attribute to any element. And I'll name this app placeholder, like this, following the naming patterns you should use for naming directives with this camel case notation. So we have the placeholder directive, and now this directive needs to do one important thing. It needs to inject the view container ref. And you learned this in the directive deep dive section. You can inject a view container ref like this. You need to import view container ref from @Angular core. And this automatically gives you access to the reference, to a pointer at the place where this directive is then used. So this will allow you to get information about the place where you use that directive. And as I said, that will not just be coordinates, but the view container ref has useful methods, for example, for creating a component in that place where it sits. So you essentially get access to the place where the directive is added to, and you not just get access in the sense of where is this, but also in the sense of please add something there. Now, we need to turn this into a public property using that TypeScript shortcut where this argument is automatically stored in a property of the same name. And this property is publicly accessible so that we can access that view container ref from outside. Now, why do we need that? Because now we will be able to add the directive to some place in our DOM, in our templates, and then get access to it with @viewChild, and then get access to that public view container ref to work with that view container ref of that directive. Let's implement that step by step. Before we can do that, let's make sure we also declare that directive in the app module. Here, the placeholder directive. Make sure to also add the import, of course. And now let's continue. With the placeholder directive added, let's go back to the auth component, and now we need to add a new element here. Now you could add a div, but there is a better element. You should use ng template here. This is a directive Angular ships with, which will not actually render anything to the DOM, but still is accessible in the Angular templating language. This is great because we don't add the overhead of an extra DOM element here. Instead, we can now simply just, get access to a place in the DOM. To ng template, we add app placeholder like this new placeholder directive we created. By the way, you don't have to create it here. You can also create it outside of that row here if you wish to, anywhere here. So now we have that ng template element added, which is considered by Angular when it parses the template, but which does not render a real element to the real DOM, which is great. But we will be able to get access to this place in the DOM thereafter. It's simply remembered internally by Angular, you could say. So now we have that. How does it help us? Well, in the auth component TypeScript file, we can now get access to that directive with the help of @viewchild, which you already learned about in the component deep dive section. Viewchild is imported from @Angular core, and to @viewchild, you pass a selector. Now you could pass in the name of a local reference as a string, but that's not the goal here. Instead, you can also pass in a type, and it will look for the existence of that type in the template. So if we pass in the placeholder directive as a type, it will automatically find the first place where we use that directive in the template of this component. So here I'll add placeholder directive, and this needs to be imported from your placeholder directive file, of course. And I'll add it as a type like this, and as I mentioned, @viewchild will then find the first occurrence of that directive in the DOM. Then we can store this in a property of that component, like alert host would be a fitting name because it will be the place where we host our alert, and this will be of type placeholder directive, of course. So we get access to that directive we use in the template, and we store that in alert host. Now that alert host can be used in show error alert. We have our factory down there. Now we can get access to the view container reference of our host. So here we can get access to this with host view container ref, for example, and this simply is the view container ref we find in our alert host, which is the directive we selected with @viewchild view container ref. Because our host has the view container ref property, because it is just the directive we're selecting in our template, and our placeholder directive, of course, exposes view container ref as a public property here. So therefore, since we expose it there, we can get access to it here in the auth component. And I'm storing it in a new constant. You, of course, don't need to do that. You could continue working with that. So now I store a reference at that view container ref property in the host view container ref constant. Now, the next thing is that we clear anything that might have been rendered there before by simply calling clear on this view container reference. As I mentioned, the view container reference is not just like a pair of coordinates. Instead, it is an object that allows you to interact with that place in the DOM. And clear simply clears all Angular components that have been rendered in that place before. And I want to clear everything before I render something new. Now we're almost there. Now we can use our component factory to create a new alert component in that host view container reference. And this is done by simply now using our host view container reference and calling create component. As I mentioned, you have methods for creating things in that place. So here I create a new component, and this now does not need the type of the component, but it needs such a factory. So here I pass in that alert component factory we created earlier. And this will now create a new component in that place. Let's give this a try. Save all the files. And let's wait for this to reload. And now let's try logging in with fake credentials. And I get an error. I get an error that no component factory found for alert component. Did you add it to ng module entry components? Now what is that? Well, we proceeded with rendering the component programmatically, but now when we tried to test it, we had this strange error. And a quick side note here. If you're not getting this error, if it just works for you, then this is the case because you are using Angular 9 or higher. This is simply a tiny change that was made behind the scenes of Angular, so the general syntax and so on didn't change. What I showed you works in all Angular versions, but in Angular 9 or higher, there was a behind the scenes change which makes this work out of the box, which of course is great. But if you are getting this error, which is also not unlikely because not everyone is using the latest version, well, then here's why we get it. It didn't find a component factory for alert component. Well, we created one here, right? Why didn't it find that factory? Well, ignore the first part. This here is the interesting part. Did you add it to ng module entry components? For this, you need to understand how Angular actually works behind the scenes when it comes to creating components. Of course, any component, as well as directives and pipes, you plan on working with, you need to add them to your declarations array. And we did this for the alert component. We did this for all the components that were loaded. This is important for Angular to understand what's a component or which components and directives and so on you have in your app. Because it does not automatically scan all your files, you need to tell it which components exist. Still, this alone only makes Angular aware of it, so that it is able to create such a component when it finds it in one of two places. The first place would be in your templates. If in your templates, let's say of the recipe list component here, if it finds something like app recipe item, like this selector, it basically looks into the declarations array, finds it there, and then is able to create that component. Great. The other place where Angular will look for this component is in your routes. In your route config, when you point at a component there, Angular will also check that in the declarations array, and if it finds it there, it is able to create such a component and load it. Now, one place that does not work by default is when you want to create a component manually in code, which is the exact thing we're trying to do in the auth component. There, we're creating our own component factory with the alert component, and now here, Angular does not automatically reach out to the declarations array. It simply doesn't do that. You can complain about that, still it's the case. You instead deliberately need to inform Angular that, in this case, the alert component will need to be created at some place and that Angular basically should be prepared for this. It will prepare itself for this creation when it finds a component in the template or in a route config, but here it won't. Now, to tell Angular to be prepared for the creation of that component, you need to add a special property to the object you pass to ng module. Besides declarations, imports, and so on, there is a property we haven't worked with thus far, and that is entry components. Entry components also is an array, and it's an array of component types, but only of components that will eventually need to be created without a selector or the route config being used. So whenever a component is created by selector or you use it with the route configuration, you don't need to add it here, which is why thus far we haven't added anything to entry components. For alert component, it's differently, and there you simply need to add alert component to entry components. Now, one extra note about this entry components property though, depending on the Angular version you're using, you might not need it. If you are working in a project that uses Angular 9 or higher, and you can check your package.json file to find out which version you're using, if you're in a project with Angular 9 or higher, you can omit entry components by default, because their Angular under the hood uses a different rendering engine. Its name is Ivy, and there it works differently under the hood. So the other syntax doesn't change. The only difference is that you can omit entry components. You don't have to. Specifying it there too isn't a problem. You will never make an error if you do specify entry components. Just in some cases you could omit it. Now Angular is ready to create that component whenever you prompt it to, and you do prompt it to create that component here. So now if you save this, after adding that component to the entry components list, and you try this again, you get your component here. And this is now created programmatically in code. But of course, it's not working correctly. We can't dismiss it, and we're also not seeing a message here. How can we make this work? Of course we see no message here, and of course we can't dismiss it by clicking, because in our alert component here, we do have add input and add output, but we're not using property or event binding on our component at the moment because we created it here in code. We can't use the square brackets or the parentheses syntax here. So how can we now pass data into that component or listen to an event or remove that? Well, we simply have to store the component that is created here in some constant or variable with which we can work thereafter. So here I will store my component. However, it's just a reference, a pointer at that component, and therefore I'll name it component ref in this constant. Now we can interact with that component. We can use our component ref here, and this has an instance property which gives us access to the concrete instance of this component that was created here. Now this instance should have the properties we added to our component. So it should have a message and a close property because both here are properties of the alert component. And indeed, if we type a dot here, you see close and message here. So now we can set message here equal to the message we're getting as a string. And this should ensure that the message is displayed. Let's give this a try and let's save everything and try logging in with wrong credentials again. And indeed, here's our message. Oh, that's great. Now for closing, we simply manually have to listen to our close event here. And for that, I again reach out to the instance and then to close. And remember that close in the end here is just an event emitter. Now you learned that you should use event emitter basically only here when it's decorated with add output. And whenever you manually subscribe to something, you would want to use a subject. Here is basically the only exception to that rule. Since this is a component where we have add output, because we could use this component by selector as well, we have an event emitter, and yet here I manually want to subscribe. And here this is okay. So here we subscribe to this, and whenever this fires, we'll run this function which I passed to subscribe, and in there we essentially want to clear that component reference, right? Therefore, let's first of all store the subscription because we should manage this manually here. Private close sub, which is of type subscription, which is imported from RxJS. Because the event emitter from Angular is based on the subject actually, and therefore it has the same type of subscription. So here I'll store this. Close sub. And now when we do close it, so when we make it into this function here, we can call this close sub unsubscribe because I want to clear that subscription because I know that this component will be removed. And of course, to remove the component, we use our host view container ref, and there we can call clear again to clear all content that was rendered there. So let's give this a try. Click on the backdrop, and it's gone. Let's try this again. Let's also inspect it in the DOM. Here we can see it is being rendered. That's the app alert component. If I click close, that indeed is removed from the DOM. So this works. One tiny piece of extra cleanup I want to do is I also want to clear that subscription here if we get rid of the off component. Because if that off component is removed, we also don't want to have that old subscription here sit around anymore. So I will implement on destroy here into the off component. On destroy, of course, is imported from add Angular core. And with on destroy imported, here we have to add ng on destroy. And there I want to check if we have an active close subscription. And if we do have one, because we only have one if we showed that error alert, therefore we need to check for the existence of this first. If we do have one, then I want to unsubscribe. And now this ensures that when we do see that error here and we somehow would get rid of that off component, we have no real way, but still then we would not have that ongoing subscription anymore. So with that, now I can close this and I'll try again with correct credentials, and this now looks way better. So this is how you can dynamically create a component from inside code. In this module, you learned about 2 ways of creating a component dynamically. The simpler approach is by using ngIf, and as I mentioned already, I recommend using that approach as often as possible. If you have no strong reason for managing this in code, for example, you're creating a third-party library and want to give users of your library an in-code way of showing an alert, that would be a good reason. But if you have no strong reason, definitely consider this. It's way easier, and Angular does all the heavy lifting for us. And remember, this doesn't render anything in the DOM if this condition here is false. So you're also not cluttering your DOM with unused or unnecessary content. So strongly consider using ngIf. But if you got another use case, or you absolutely just want to do it programmatically, this is how you do it. You create your own component factory, and then you use a view container reference, which you can get access to with the help of a helper directive, for example. You use that to then dynamically create and render your component with the help of Angular. Important for that approach is that any component you are rendering like this needs to be added to the entry components array in your module, in your ng module. Otherwise, you will get an error. Now, these are the 2 different approaches. I hope this helps you with your future projects.